Chapter 1. Programming in C. Basic concepts. Character set. A character refers to an alphabet, digit, or a special symbol. Alphabets, capital A to capital Z, and small a to small z. Digits, 0 to 9. Special symbols. Tilde, exclamation mark, hash, percentage sign, caret, ampersand, asterisk, opening parenthesis, closing parenthesis, hyphen or minus, plus, opening curly brace, closing curly brace, opening square bracket, closing square bracket, less than, greater than, comma, full stop, vertical bar, question mark, backslash, colon, semicolon, double quotation mark, single quotation mark, and white space. Identifier. Identifier is a user-defined name used for nomming a variable or a function. Rules for nomming an identifier. Consists only of letters, digits, and underscore. Starts only with an alphabet or underscore. Keywords cannot be used. Can be as long as you like. The first 31 characters are significant. Example. The following are valid identifiers. Role no, role underscore no, underscore role underscore no, role no, and name 2. The following are invalid identifiers. To name and role space no. Variable. The name itself represents a value and is not constant. Variable is a data name whose value varies or changes during program execution. Variable name is a name given to a memory cell, which may be 1 or multiple bytes. Data types. Represents the type of data and the set of operations to perform on data. Data type. Data types are classified into 4 categories. Primitive or basic data types, character, float, double, and integer. Derived data types, array, structure, pointer, and union. User-defined data type, enumeration. Valueless data type, void. Table, type, keyword, and number of bytes. The table shows the keyword used for each primitive data type and the memory occupied by it. Integer uses the keyword int and occupies 2 bytes. Floating uses the keyword float and occupies 4 bytes. Double uses the keyword double and occupies 8 bytes. Character uses the keyword char and occupies 1 byte. Declaring a variable. Before using a variable, you must give some information to the compiler about the variable. That is, you must declare it. A declaration statement includes the data type and the variable name. Syntax. The syntax for declaring a variable is data type, followed by variable underscore name, followed by a semicolon. Written as data type, var underscore name semicolon. Example. Int role underscore no semicolon. Char ch semicolon. Float age semicolon. When we declare a variable, memory space is allocated to hold a value of the specified type. The allocated space is associated with the variable name. The allocated space is associated with a unique address. Table 1. Visualization of declaration. First example. Int role underscore no semicolon. A variable named role underscore no is declared as an integer. Since no value has been assigned, it contains a garbage value. The memory address shown is 2002. Second example. Int marks equals 10 semicolon. A variable named marks is declared as an integer and initialized with the value 10. The memory address shown is 3008. Third example. Float diameter equals 5.9 semicolon. A variable named diameter is declared as a floating point variable and initialized with the value 5.9. The memory address shown is 4252. Fourth example. Char ch equals single quote a single quote semicolon. Here, ch is the variable name. A is the value stored in the variable. And 2820 is the memory address of the variable. Note, the default value is garbage, that is, an unknown value assigned randomly. Renaming data types with typedef. Typedef is a keyword that can form complex types from the basic type and assign simpler names for such combinations. This is more helpful when a declaration is very tough, confusing, or varies from one implementation to another. Example: the data type unsigned long int is redefined as long as follows. Typedef unsigned long int long semicolon. Uses of enumerated data types. Enumerated data types are most useful when working with a small, discrete set of values, where each value has a meaning and is not just a number. A good example is the months January, February, March, and so on up to December, which are 12 in number and can be assigned consecutive numbers. The main advantages are storage efficiency, and the C code becomes more readable. Constants. A constant value is one which does not change during the execution of a program. C supports several types of constants: integer constants, real constants, single character constants, string constants, integer constants. An integer constant is a sequence of digits. It consists of a set of digits from 0 to 9, preceded by an optional plus or minus sign. Spaces, commas, and non-digit characters are not permitted between digits. Examples of valid decimal integer constants: 1, 2, 3, minus 31, 0, 5, 6, 2, 3, 2, 1, plus 78. Examples of invalid integer constants: 20, 000, rupee symbol 1000. Single character constants. A single character constant represents a single character enclosed in a pair of single quotation marks. Examples of character constants: single quote 5, single quote x, single quote semicolon, single quote. String constants. A string constant is a set of characters enclosed in double quotation marks. The characters in a string constant may be alphabets, numbers, special characters, and blank spaces. Examples of string constants: double quote VSHAL, double quote 1, 2, 3, 4, double quote C language, double quote exclamation mark, 4 dots, question mark, double quote. Nomming constants. A name given to a constant value. The value of the name does not change during program execution. Using the const keyword. When we use the const keyword with a data type, memory is allocated to the variable, and the initialized value does not change. Example: const int equals 10 semicolon. Const float pi equals 3.141 semicolon. Using define. Example: hash define x10. Hash define pi 3.141. Here, hash define is an instruction to the preprocessor. The preprocessor replaces each occurrence of the name with its value in the program before execution. Operator. An operator is a symbol that performs operations on given data elements. Table 2, Precedence and Associativity. The following table shows the precedence and associativity of operators. In C, the precedence decreases as we move from top to bottom. Parentheses, open parenthesis and close parenthesis. Index operator, open square bracket and close square bracket. Member of operator, arrow. Member of operator, dot. These operators are evaluated from left to right. Pre-increment, plus plus. Pre-decrement, minus minus. Unary minus. Address of operator, ampersand. Indirection operator, asterisk. These operators are evaluated from right to left. Arithmetic operators, asterisk, slash, and percentage symbol. Evaluated from left to right. Arithmetic operators, plus and minus. Evaluated from left to right. Bitwise shift operators, left shift and right shift. Evaluated from left to right. Relational operators, less than, greater than, less than or equal to, greater than or equal to, and not equal to. Evaluated from left to right. Bitwise exclusive OR operator, caret, Evaluated from left to right. Logical and operator, ampersand, ampersand. Evaluated from left to right. Logical or operator, vertical bar, vertical bar. Evaluated from left to right. Conditional operator, question mark, colon. Evaluated from right to left. Assignment and compound assignment operators, equals, plus equals, minus equals, asterisk equals, slash equals, and percentage equals. Evaluated from right to left. Separation operator, comma. Evaluated from left to right. Note, for the assignment operator, only a variable is allowed on the left-hand side. Operator precedence decreases as we move from top to bottom. Example 1. Int a comma b, comma c semicolon. A equals b equals c equals 0 semicolon. This assigns the value 0 to a b and c. Example 2. Int a comma b equals 55 comma c equals 10 semicolon. This initializes b with 55 and c with 10. B plus c equals a semicolon. This is invalid because only a variable is allowed on the left-hand side of the assignment operator. Example 3. Int a equals 15, b equals 20, c equals 2, d equals 5, e equals 10, f, g, h, I semicolon. F equals a left shift c semicolon. Here, O is left shifted by c times, and the result is stored in F. The value of A is 15, which in binary is 1111. After the first left shift, it becomes 11110. After the second left shift, it becomes 111100. One left shift multiplies 15 by 2, giving 30. The second left shift again multiplies 30 by 2, giving 60. Therefore, 15 multiplied by 2 raised to the power 2 equals 60. Hence, the value of f becomes 60. Note, left shift multiplies the value by 2, while right shift divides the value by 2. G equals a ampersand b semicolon. The binary value of A is 0, 1, 1, 1, 1. The binary value of B is 1, 0, 1, 0, 0. Applying the bitwise AND operator gives 0, 0, 1, 0, 0. This is equal to 4. Therefore, the value of G is 4. H equals a vertical bar B semicolon. The binary value of A is 0, 1, 1, 1, 1. The binary value of B is 1, 0, 0, 0, 0. Applying the bitwise or operator gives 1, 1, 1, 1, 1. This is equal to 31. Therefore, the value of H is 31. I equals a caret D semicolon. The binary value of A is 1, 1, 1, 1. The binary value of D is 0, 1, 0, 1. Applying the bitwise exclusive OR, or XOR, operator gives 1, 0, 1, 0. This is equal to 10. Therefore, the value of I is 10. Example 4. Int A equals 100, B equals 200, C equals 300, X semicolon. Equals open parenthesis a greater than B close parenthesis question. Mark open parenthesis a greater than C close parenthesis question. Mark a colon C close parenthesis colon, open parenthesis, B greater than C close parenthesis question. Mark B colon C close parenthesis semicolon. The condition a greater than B is false. Therefore, the second condition is evaluated, and C is selected. So, equals C. Hence, the value of X is 300. Example 5. Int I equals 10, J equals 10, X, Y semicolon. Equals I plus plus, plus, plus plus I, plus I plus plus, plus, plus plus I, plus 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 I. This executes as plus plus I, pre-increment, plus plus I, pre-increment, plus plus I, pre-increment. So the expression becomes equals I plus I plus I plus I plus I. Then, I plus plus post-increment, I plus plus post-increment. Therefore, equals 65, and I equals 15. Y equals J minus minus, plus, minus minus J, plus J minus minus, plus, minus J, plus, minus J. This executes as minus minus J, predecrement, minus minus J, predecrement, minus minus J, predecrement. So the expression becomes Y equals J plus J plus J plus J plus J. Then, J minus minus, post-decrement, J minus minus, post-decrement. Therefore, Y equals 35, and J equals 5. Example 6. Int I equals 10 semicolon. Print, open parenthesis, double quote, percentage D, percentage D, percentage D, percentage D, percentage D, double quote, comma, I plus plus, comma, plus plus I, comma, plus plus I, comma, I plus plus, comma, plus plus I, close parenthesis, semicolon. The values in print are evaluated from right to left. So the order of evaluation is I plus plus, plus plus I, plus plus I plus plus, plus plus I. The output printed is 14, 14, 13, 11, 11. Next, print, open parenthesis, double quote, percentage D, double quote, comma, I, close parenthesis, semicolon. This prints 15. Type conversion. C allows mixed mode operations. That is, variables of different types may appear in the same expression. To perform the operation, the data needs to be converted into a compatible type. The conversion takes place in two ways. Implicit type conversion. C automatically converts any intermediate values to the proper type, so that the expression can be evaluated without losing any significance. For mixed mode operations, generally the lower type is automatically converted to the higher type before the operation proceeds. Explicit type conversion. C allows the programmer to use the type conversion operator to convert a data value to the required type. Syntax. V1 equals, open parenthesis, type, close parenthesis, V2, semicolon. The type written inside the parentheses represents the destination type. Example. Int A equals 3, B equals 2, float x, y, semicolon. Case 1. Equals A divided by B, semicolon. Results. Equals 1.000000. Case 2. Y equals, open parenthesis, float, close parenthesis, A divided by B, semicolon. Results. Y equals 1.500000. In case 1, integer division is performed. Therefore, the division operator returns an integer. While assigning the value to x, it is implicitly converted to 1.000000. In case 2, open parenthesis, float, close parenthesis, A converts the value of A into a floating point value. The second variable, B, is an integer. The compiler implicitly converts B to float, performs floating point division, and stores 1.500000 in the floating point variable y. Notes. C allows both implicit and explicit type conversion. Type conversion is of two types. Narrowing, conversion of a higher type to a lower type. Widening, conversion of a lower type to a higher type. Widening and narrowing. The order of data types is character, integer, long, float, double, and long double. Moving from character towards long double is called widening. Moving from long double towards character is called narrowing. Note, narrowing causes loss of data. Input-output functions. Function and purpose. Print prints a formatted string. Scanf reads a formatted string. Getchar reads a character. Putchar displays a character. Gets reads a string. Puts displays a string. Format specifiers and their purpose. Percentage C represents a single character. Percentage D represents a decimal integer. Percentage E represents a floating point number. Percentage F represents a floating point number. Percentage H represents a short integer. Percentage O represents an octal integer. Percentage represents a hexadecimal number. Percentage S represents a string. Percentage U represents an unsigned decimal integer. Note: scanf open parenthesis, double quote, percentage S, double quote, comma, string underscore var, close parenthesis, semicolon, does not read a string that contains white space. Hence, to read a multi-word string, use gets open parenthesis, string underscore var, close parenthesis, semicolon. Example 1. Which of the following comments regarding the reading of a string using scanf and gets is true? Option A, both can be used interchangeably. Option B, scanf is delimited by the end of the line, while gets is delimited by blank space. Option C, scanf is delimited by blank space, while gets is delimited by the end of the line. Option D, none of these. Answer: Option C. Program structure. A C program consists of the following parts: documentation section, preprocessor commands, global declarations, main function, body of the main function, user-defined function area. The basic structure is /*, documentation section */, preprocessor commands semicolon, global declarations semicolon, main open parenthesis, close parenthesis, open curly brace, body of main semicolon, close curly brace, user-defined function area semicolon, documentation section or comments, ignored by the compiler, provides additional information to the user to improve readability. Preprocessing tells the compiler to do preprocessing before compilation. For example, #include less than stdio.h greater than. This tells the compiler to include the stdio header file. Global declaration contains variable declarations that are accessible in more than one function. Function. Functions are the main building blocks of a C program. Every C program contains one or more functions. A mandatory function called main, open parenthesis, close parenthesis, instructs the compiler to start execution from here. User-defined area. Here, the user can define their own functions. Control statements. The statement that controls the execution sequence of a program is called a control statement. Control statements are classified into 3 types: selection statements, if and switch; iterative or looping statements, while, do while, and for; unconditional jump statements, break, continue, return, and go to; selection or decision-making statement. A selection or decision-making statement makes a decision to select and execute statement or statements based on a condition. C supports 2 selection statements, if and switch. The if statement is called a two-way selection statement. Syntax. Simple if open parenthesis, expression close parenthesis. Statement or statements. If else. If open parenthesis, expression close parenthesis. Open curly brace. Statement 1. Close curly brace. Else. Open curly brace. Statement or statements. Close curly brace. Else if latter. If open parenthesis, expression 1 close parenthesis. Open curly brace. Statement 1. Close curly brace. Else if open parenthesis, expression 2 close parenthesis. Open curly brace. Statement 2. Close curly brace. Else. Open curly brace. Statement 3. Close curly brace. Nested if. If open parenthesis, expression 1 close parenthesis. Open curly brace. Statement 1. If open parenthesis. Expression 2 close parenthesis. Statement 2. Else. Statement 3. Close curly brace. Else. Statement 4. Note, if the expression evaluates to true, the statements inside the if block are executed. Otherwise, the statements inside the else block are executed. Example 2. Consider the following program segment. If open parenthesis, a greater than b, close parenthesis, print open parenthesis, double quote, a greater than b, double quote, close parenthesis, semicolon. Else, print open parenthesis, double quote, else part, double quote, close parenthesis, semicolon. Print open parenthesis, double quote, a less than or equal to b, double quote, close parenthesis, semicolon. The statement, a less than or equal to b, will be printed if option A is greater than b, option B is less than b, option C is equal to b, option D all of these. Answer, option D. Because the statement print open parenthesis, double quote, a less than or equal to b, double quote, close parenthesis, semicolon is not part of either the if block or the else block. Therefore, it is executed in all cases. The switch statement. The switch statement is a multi-way, or n-way, selection statement. Syntax. Switch, open parenthesis, variable underscore name or expression, close parenthesis. Open curly brace. Case constant 1, colon. Statement 1. Break semicolon. Case constant 2, colon. Statement 2. Break semicolon. Dot dot dot. Case constant n, colon. Statement n. Break semicolon. Default colon. Statements. Close curly brace. Notes. For a switch statement, only integral types, that is, integer or character, or an expression that evaluates to an integral value, are allowed. The absence of a break statement after a case causes the execution to continue with all the following case statements after the matching case block. Example 3. Consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 10 semicolon. Switch, open parenthesis, I close parenthesis. Open curly brace. Case 10, colon. Print, open parenthesis, double quote, case 10, double quote, close parenthesis, semicolon. Case 15, colon. Print, open parenthesis, double quote, case 15, double quote, close parenthesis, semicolon. Case 20, colon. Print, open parenthesis, double quote, case 20, double quote, close parenthesis, semicolon. Default colon. Print, open parenthesis, double quote, default case, double quote, close parenthesis, semicolon. Close curly brace. Close curly brace. Output. Case 10, case 15, case 20, default case. Reason. Since there is no break statement after each case, execution continues through all the remaining case statements after the matching case. Example 4. Consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 10 semicolon. Switch, open parenthesis, I close parenthesis. Open curly brace. Case 10, colon. Print, open parenthesis, double quote, case 10, double quote, close parenthesis, semicolon. Break semicolon. Case 8 plus 2, colon. Print, open parenthesis, double quote, case 8 plus 2, double quote, close parenthesis, semicolon. Break semicolon. Default colon. Print, open parenthesis, double quote, no matching case, double quote, close parenthesis, semicolon. Close curly brace. Close curly brace. Result. The program raises a duplicate case error during compilation because the expression 8 plus 2 evaluates to 10, which is the same as the previous case value. Looping statements. Sometimes, there is a need to execute one or more statements repeatedly for a number of times, or until a condition is satisfied. C supports the following looping statements. While, do while, for, while statement. Syntax. While, open parenthesis, condition, close parenthesis. Open curly brace. Statement or statements. Close curly brace. If the condition is true, the block of statements is executed, and control returns to the condition. The statements continue to execute until the condition becomes false. Notes. The while loop executes the block 0 or more times. The while loop is called an entry control loop. Do-while statement. Syntax. Do. Open curly brace. Statement or statements. Close curly brace. While, open parenthesis, condition, close parenthesis, semicolon. The do-while loop is the same as the while loop, except that the statements are executed at least once. Notes. The condition is not evaluated before executing the block for the first time. The do-while loop is called an exit control loop. Example 5. Consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 0 semicolon. While, open parenthesis, I not equals 0, close parenthesis. Open curly brace. Print, open parenthesis, double quote, %d double quote, comma, I, close parenthesis, semicolon. I++ semicolon. Close curly brace. Close curly brace. Output. No output. Because the condition is false the very first time, the loop body is never executed. Now consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 0 semicolon. Do. Open curly brace. Print, open parenthesis, double quote, %d double quote, comma, I, close parenthesis, semicolon. I++ semicolon. Close curly brace. While, open parenthesis, I not equals 0, close parenthesis, semicolon. Close curly brace. Output. Displays 0 to 32,767, and then minus 32,768 to -1. The for loop. The for loop provides a more concise loop control structure. Syntax. For open parenthesis, expression 1, semicolon, expression 2, semicolon, expression 3, close parenthesis. Open curly brace. Statement or statements. Close curly brace. Expression 1. The initialization expression may contain multiple initializations. It is executed only once before the loop executes for the first time. Expression 2. The condition expression. Only one condition expression is allowed. It may be a single condition or a compound condition and is evaluated before every execution of the loop. Expression 3. The modification expression may contain multiple statements. It is executed after the completion of the loop body during every iteration. Note: all the expressions inside the parentheses are optional. However, the 2 semicolons are compulsory, even if there are no expressions. Odd loops. In the for, while, and do-while loops, the condition specifies the number of times a loop can be executed. Sometimes, the user may not know the number of times a loop has to be executed. If a loop has to execute an unknown number of times, the concept of odd loops is used. Odd loops can be implemented using the for, while, or do-while loop. The following program illustrates an odd loop. Hash include, less than stdio.h, greater than. Main, open parenthesis, close parenthesis. Open curly brace. Int num, x semicolon. Num equals 1 semicolon. While, open parenthesis, num equals 1, close parenthesis. Open curly brace. Print, open parenthesis, double quote, enter a number, double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote, %d double quote, comma, &x, close parenthesis, semicolon. If, open parenthesis, x %2, close parenthesis, equals 0, close parenthesis. Print open parenthesis, double quote, number is even, double quote, close parenthesis, semicolon. Else. Print open parenthesis, double quote, number is odd, double quote, close parenthesis, semicolon. Print open parenthesis, double quote, do you want to test any number, double quote, close parenthesis, semicolon. Print open parenthesis, double quote, for yes, enter 1. For no, enter 0, double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote, percentage %d, double quote, comma, ampersand num, close parenthesis, semicolon. Close curly brace. Close curly brace. Unconditional jump statements. C language permits jumping from one statement to another. C supports the following unconditional jump statements. Break. Continue. Return. Go to. Break statement. The break statement breaks the execution sequence. When a break statement is executed inside a block or loop, control comes out of that block or loop. Syntax. Break semicolon. Continue statement. The continue statement is used to skip a part of the loop under certain conditions. Syntax. Continue semicolon. Return statement. The return statement terminates the execution of a function and returns control to the calling function. Syntax. Return, expression or value, semicolon. Go-to statement. The go-to statement jumps from one point to another within a function. Syntax. Reverse jump. Label 1, colon. Statement or statements, semicolon. Go to label 1, semicolon. This is called a reverse jump. Forward jump. Go to label 2, semicolon. Statement or statements, semicolon. Label 2, colon. This is called a forward jump. Reverse jump executes the statements repeatedly, whereas in a forward jump, the statements are skipped from execution. Example 6. Consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I semicolon. For open parenthesis, I equals 1, semicolon, I less than or equal to 10, semicolon, I plus plus, close parenthesis. Open curly brace. If open parenthesis, I equals 5, close parenthesis. Break semicolon. Print open parenthesis, double quote, percentage %d, double quote, comma, I, close parenthesis, semicolon. Close curly brace. Close curly brace. Output. 1, 2, 3, 4. If I equals 5, the break statement terminates the loop. Example 7. Consider the following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I semicolon. For open parenthesis, I equals 1, semicolon, I less than or equal to 10, semicolon, I plus plus, close parenthesis. Open curly brace. If open parenthesis, I equals 5, close parenthesis. Continue semicolon. Print open parenthesis, double quote, percentage %d, double quote, comma, I, close parenthesis, semicolon. Close curly brace. Close curly brace. Output. 1, 2, 3, 4, 6, 7, 8, 9, 10. If I equals 5, the continue statement skips the remaining statements of that iteration. Therefore, 5 is not printed. Example 8. Output for the following program segment. For open parenthesis, I equals 1, comma, j equals 10, semicolon, I less than 6, semicolon, plus plus I, comma, minus minus j, close parenthesis. Print open parenthesis, double quote, backslash n, percentage %d, space, percentage %d, double quote, comma, I, comma, j, close parenthesis, semicolon. Output. 1, 10. 2, 9. 3, 8. 4, 7. 5, 6. Note. Since the first statement allows multiple initialization and multiple update statements, expression 1 and expression 3 do not raise any error. Exercises. Practice problems 1. Directions for questions 1 to 15. Select the correct alternative from the given choices. Question 1. What will be the output of the following program? Void main, open parenthesis, close parenthesis. Open curly brace. Int I semicolon. Char I, open square bracket, close square bracket, equals double quote backslash 0 double quote, semicolon. If open parenthesis, print, open parenthesis, double quote, percentage s backslash n double quote, comma, a close parenthesis, print, open parenthesis, double quote, okay, backslash n, double quote, close parenthesis, semicolon. Else, print, open parenthesis, double quote, program error, backslash n, double quote, close parenthesis, semicolon. Close curly brace. Options. Option A, okay. Option B, program error. Option C, no output. Option D, compilation error. Question 2. Output of the following program will be hash define false -1, hash define true 1, hash define null 0. Main, open parenthesis, close parenthesis. Open curly brace. If, open parenthesis, null, close parenthesis. Puts, open parenthesis, double quote, null, double quote, close parenthesis, semicolon. Else if, open parenthesis, false, close parenthesis. Puts, open parenthesis, double quote, true, double quote, close parenthesis, semicolon. Else. Puts, open parenthesis, double quote, false, double quote, close parenthesis, semicolon. Close curly brace. Options. Option A, null. Option B, true. Option C, false. Option D, 1. Question 3. Main, open parenthesis, close parenthesis. Open curly brace. Print, open parenthesis, double quote, percentage x, double quote, comma, -1 left shift 4, close parenthesis, semicolon. Close curly brace. For the above program, the output will be Option A, FFF0. Option B, FF00. Option C, 00FF. Option D, 0FFF. Question 4. For the following program, hash define SQR, open parenthesis, a close parenthesis, a asterisk, a. Main, open parenthesis, close parenthesis. Open curly brace. Int I semicolon. I equals 64 divided by SQR, open parenthesis 4 close parenthesis, semicolon. Print, open parenthesis, double quote, percentage D double quote, comma, I close parenthesis, semicolon. Close curly brace. The output will be Option A, 4. Option B, 16. Option C, 64. Option D, compilation error. Question 5. Hash define CLRSCR, open parenthesis, close parenthesis, 1000. Main, open parenthesis, close parenthesis. Open curly brace. CLRSCR, open parenthesis, close parenthesis, semicolon. Print, open parenthesis, double quote, percentage D backslash N double quote, comma, CLRSCR, open parenthesis, close parenthesis, semicolon. Close curly brace. Output of the above program will be Option A, error. Option B, no output. Option C, 1000. Option D, 1. Question 6. Output of the following program is main, open parenthesis, close parenthesis. Open curly brace. Int I equals -2, semicolon. Plus I, semicolon. Print, open parenthesis, double quote, I equals percentage D, comma, plus I equals percentage D backslash N double quote, comma, I, comma, plus I, close parenthesis, semicolon. Options. Option A, error. Option B, -2, +2. Option C, -2, -2. Option D, -2, 2. Question 7. Main, open parenthesis, close parenthesis. Open curly brace. Int N, semicolon. printf, open parenthesis, double quote, %d, double quote, comma, scanf, open parenthesis, double quote, %d, double quote, comma, ampersand n, close parenthesis, semicolon. Close curly brace. If the input is 20, what will be the output? Option A 20. Option B 1. Option C 2. Option D 0. Question 8. How many times will the following code be executed? Open curly brace. Equals 10, semicolon. While, open parenthesis, x equals 1, close parenthesis. X plus plus, semicolon. Close curly brace. Options. Option A never. Option B once. Option C 15 times. Option D infinite number of times. Question 9. The following statement. Printf, open parenthesis, double quote, %d, double quote, comma, 9%5, close parenthesis, semicolon. Prints. Option A 1.8. Option B 1.0. Option C 4. Option D 2. Question 10. Int a semicolon. Printf, open parenthesis, double quote, %d, double quote, comma, a close parenthesis, semicolon. What is the output of the above code fragment? Option A 0. Option B 2. Option C garbage value. Option D 3. Question 11. Printf, open parenthesis, double quote, %d, double quote, comma, printf, open parenthesis, double quote, time, double quote, close parenthesis, semicolon. Options. Option A syntax error. Option B outputs time 4. Option C outputs garbage. Option D prints time and terminates abruptly. Question 12. The following program. Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 2, semicolon. Open curly brace. Int I equals 4, comma, j equals 5, semicolon. Printf, open parenthesis, double quote, %d, double quote, comma, I, comma, j, close parenthesis, semicolon. Close curly brace. Printf, open parenthesis, double quote, %d, double quote, comma, I, comma, j, close parenthesis, semicolon. Close curly brace. Options. Option A compiler error, unrecognized symbol j. Option B, prints 2545. Option C, prints 4525. Option D, none of the above. Question 13. What is the output of the following program fragment? For open parenthesis, I equals 3, semicolon, I less than 15, semicolon, I plus equals 3, close parenthesis, semicolon. Printf, open parenthesis, double quote, %d, double quote, comma, I, close parenthesis, semicolon. Options. Option A a syntax error. Option B an execution error. Option C prints 12. Option D prints 15. Question 14. What is the output of the following program segment? Int A equals 4, comma, B equals 6, semicolon. Printf, open parenthesis, double quote, %d, double quote, comma, A equals B, close parenthesis, semicolon. Options. Option A outputs an error message. Option B prints 0. Option C prints 1. Option D none of these. Question 15. The statements. A equals 7, semicolon. Printf, open parenthesis, double quote, %d, double quote, comma, open parenthesis, A plus plus, close parenthesis, semicolon. Prints. Option A value of 8. Option B value of 7. Option C value of 0. Option D none of the above. Practice problems 2. Directions for questions 1 to 12. Select the correct alternative from the given choices. Question 1. If the condition is missing in a for loop of a C program, then Option A, it is assumed to be present and taken to be false. Option B. It is assumed to be present and taken to be true. Option C. It results in a syntax error. Option D. Execution will be terminated abruptly. Question 2. Which of the following operators in C does not associate from the right? Option A equals. Option B plus equals. Option C postfix plus plus. Option D greater than. Question 3. In the C programming language, x minus equals y plus 1 means. Option A x equals minus x minus y minus 1. Option B x equals x minus y plus 1. Option C x equals x minus y minus 1. Option D equals minus x plus y plus 1. Question 4. Minimum number of temporary variables needed to swap two variables is. Option A 1. Option B 2. Option C 3. Option D 0. Question 5. A preprocessor command. Option A need not start on a new line. Option B need not start on the first column. Option C has hash as the first character. Option D comes after the first executable statement. Question 6. Printf open parenthesis double quote %d double quote comma printf open parenthesis double quote %d double quote comma printf open parenthesis double quote time for kids double quote close parenthesis semicolon. Option A outputs time. Option B syntax error. Option C outputs 9. Option D none of the above. Question 7. For open parenthesis, I equals 1, semicolon, I less than 5, semicolon, I plus plus, close parenthesis. If, open parenthesis, I not equals 3, close parenthesis. Printf, open parenthesis, double quote, %d double quote, comma, I, close parenthesis, semicolon. Output. Option A 1 2 3 4 5. Option B error. Option C 1 2 4 5. Option D 0 0 0 0. Question 8. Which operator in C takes only integer operands? Option A asterisk. Option B slash. Option C percentage. Option D plus. Question 9. An unrestricted use of the goto statement is harmful because. Option A. It increases the execution time of the program. Option B. It increases the memory of the program. Option C. It decreases the readability and testing of the program. Option D. None of the above. Question 10. What will be the output? Main, open parenthesis, close parenthesis. Open curly brace. Int I equals 0, comma, j equals 0, semicolon. If, open parenthesis, I ampersand j plus plus, close parenthesis. Printf, open parenthesis, double quote, %d dot dot %d, double quote, comma, I plus plus, comma, j, close parenthesis, semicolon. Printf, open parenthesis, double quote, %d dot dot %d, double quote, comma, I, comma, j, close parenthesis, semicolon. Close curly brace. Options. Option A 1 dot dot 1. Option B 2 dot dot 2. Option C 0 dot dot 0. Option D 1 dot dot 1, 1 dot dot 1. Question 11. What is the output? Main, open parenthesis, close parenthesis. Open curly brace. Int A equals 0, semicolon. Int B equals 20, semicolon. Char equals 1, semicolon. Char Y equals 10, semicolon. If, open parenthesis, a comma B comma X comma Y, close parenthesis, semicolon. Printf, open parenthesis, double quote, hello, double quote, close parenthesis, semicolon. Close curly brace. Options. Option A logical error. Option B garbage value. Option C hello. Option D 20. Question 12. What will be the value of count after executing the following program? Main, open parenthesis, close parenthesis. Open curly brace. int count equals 10, comma, digit equals 0, semicolon. While, open parenthesis, digit less than or equal to 9, close parenthesis. Open curly brace. Printf, open parenthesis, double quote, percentage d backslash n, double quote, comma, plus plus count, close parenthesis, semicolon. Plus plus digit, semicolon. Close curly brace. Close curly brace. Options. Option A 10. Option B 11. Option C 20. Option D 21. Previous year questions. Question 1. Which one of the following are essential features of an object-oriented programming language? 1. Abstraction and encapsulation. 2. Strictly typeness. 3. Type-safe property coupled with subtype rule. 4. Polymorphism in the presence of inheritance. Year, 2005. Options. Option A 1 and 2 only. Option B 1 and 4 only. Option C 1, 2 and 4 only. Option D 1, 3 and 4 only. Question 2. Which of the following statements are true? 1. A programming language that does not permit global variables of any kind and has no nesting of procedures or functions, but permits recursion, can be implemented with static storage allocation. 2. Multi-level access link, or display arrangement, is needed to arrange activation records only if the programming language being implemented has nesting of procedures or functions. 3. Recursion in programming languages cannot be implemented with dynamic storage allocation. 4. Nesting of procedures or functions and recursion require a dynamic heap allocation scheme and cannot be implemented with a stack-based allocation scheme for activation records. 5. Programming languages that permit a function to return another function as its result cannot be implemented with a stack-based storage allocation scheme for activation records. Year, 2008. Options. Option A 2 and 5 only. Option B 1, 3 and 4 only. Option C 1, 2 and 5 only. Option D 2, 3 and 5 only. Question 3. What will be the output of the following C program segment? Char equals single quote a single quote semicolon. Switch open parenthesis, close parenthesis. Open curly brace. Case single quote a single quote colon. Printf open parenthesis, double quote, choice A backslash n, double quote, close parenthesis. Case single quote B single quote colon. Case single quote C single quote colon. Printf open parenthesis, double quote, choice B double quote, close parenthesis. Case single quote D single quote colon. Case single quote E single quote colon. Default colon. Printf open parenthesis, double quote, no choice, double quote, close parenthesis. Close curly brace. Year, 2012. Options. Option A no choice. Option B choice A. Option C choice A, choice B no choice. Option D program gives no output as it is erroneous. Question 4. Suppose n and p are unsigned int variables in a C program. We wish to set p to nc3. If n is large, which one of the following statements is most likely to set p correctly? Year, 2014. Options. Option A p equals n multiplied by open parenthesis n minus 1 close parenthesis multiplied by open parenthesis n minus 2 close parenthesis divided by 6. Option B p equals n multiplied by open parenthesis n minus 1 close parenthesis divided by 2 multiplied by open parenthesis n minus 2 close parenthesis divided by 3. Option C p equals n multiplied by open parenthesis n minus 1 close parenthesis divided by 3 multiplied by open parenthesis n minus 2 close parenthesis divided by 2. Option D p equals n multiplied by open parenthesis n minus 1 close parenthesis multiplied by open parenthesis n minus 2 close parenthesis divided by 6.0. Question 5. The secant method, is used to find the root of an equation f of x equals 0. It is started from two distinct estimates, x sub o and x sub b, for the root. It is an iterative procedure involving linear interpolation to a root. The iteration stops if f of x sub b is very small, and then x sub b is the solution. The procedure is given below. One expression is missing and is marked by a question mark. Which expression should replace the question mark so that it correctly follows all the steps of the secant method? Year, 2015. Options: Option A, Option B, Option C, Option D. Question 6. Consider the following C program. Hash include, less than stdio.h, greater than. Int main, open parenthesis, close parenthesis. Open curly brace. Int I, j, k equals 0, semicolon. J equals 2 multiplied by 3, divided by 4 plus 2.0, divided by 5 plus 8, divided by 5, semicolon. K minus equals minus j, semicolon. For open parenthesis, I equals 0, semicolon, I less than 5, semicolon, I plus plus, close parenthesis. Open curly brace. Switch, open parenthesis, I plus k, close parenthesis. Open curly brace. Case 1, colon. Case 2, colon. Printf, open parenthesis, double quote, backslash and percentage d, double quote, comma, I plus k, close parenthesis, semicolon. Case 3, colon. Printf, open parenthesis, double quote, backslash and percentage d, double quote, comma, I plus k, close parenthesis, semicolon. Default colon. Printf, open parenthesis, double quote, backslash and percentage d, double quote, comma, I plus k, close parenthesis, semicolon. Close curly brace. Close curly brace. Return 0, semicolon. Close curly brace. The number of times the print statement is executed is. Year, 2015. Question 7. Consider the following C program fragment, which is meant to divide by y using repeated subtraction. The variables x, y, q, and r are all unsigned int. While, open parenthesis, r greater than or equal to y, close parenthesis. Open curly brace. R equals r minus y, semicolon. Q equals q plus 1, semicolon. Close curly brace. Which of the following conditions before execution of the fragment ensure that the loop terminates in a state satisfying x equals open parenthesis y multiplied by q plus r close parenthesis? Year, 2017. Options. Option A, q equals r, and r equals 0. Option B, greater than 0, and r equals x, and y greater than 0. Option C, q equals 0, and r equals x, and y greater than 0. Option D, q equals 0, and y greater than 0. Question 8. Consider the following C program. Hash include, less than stdio.h, greater than. Int main, open parenthesis, close parenthesis. Open curly brace. Int m equals 10, semicolon. Int n, and 1, semicolon. N equals plus m, semicolon. N1 equals m plus, semicolon. N minus, semicolon. Minus n1, semicolon. N minus equals n1, semicolon. Printf, open parenthesis, double quote, percentage d, double quote, comma n, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The output of the program is. Year, 2017. Functions. A function is a block of code that performs a specific task. It has a name and is reusable, that is, it can be executed from as many different parts of a program as required. Functions make it possible to perform modular programming. In this style of programming, the high-level logic of the overall problem is solved first, whereas the detail of each lower-level function is addressed later. This approach reduces the complexity in writing a program. Every C program can be thought of as a collection of functions. Main, open parenthesis, close parenthesis, is also a function. Types of functions. Library functions. These are the inbuilt functions of the C library. These are already defined in header files. Example 1. Printf, open parenthesis, close parenthesis, is a function used to print output. It is defined in the stdio.h file. User-defined functions. Programmers can create their own functions in C to perform specific tasks. Example 2. Hash include, less than stdio.h, greater than. Main, open parenthesis, close parenthesis. Open curly brace. Message, open parenthesis, close parenthesis, semicolon. Close curly brace. Message, open parenthesis, close parenthesis. Open curly brace. Printf, open parenthesis, double quote, hello, double quote, close parenthesis, semicolon. Close curly brace. A function receives 0 or more parameters, performs a specific task, and returns 0 or 1 value. A function is invoked by its name and parameters. No two functions can have the same name in a single C program. The communication between the function and the invoker is through the parameters and the return value. A function is independent. It is completely self-contained. It can be called at any place in your code and can be ported to another program. Functions make programs reusable and readable. Example 3. Return the largest of two integers. Int maximum, open parenthesis, int a comma, int b, close parenthesis. Open curly brace. If, open parenthesis, a greater than b, close parenthesis. Return a semicolon. Else. Return b, semicolon. Close curly brace. Note. Function calls execute with the help of the execution stack. Execution of a C program starts with the main, open parenthesis, close parenthesis, function. Main, open parenthesis, close parenthesis, is a user-defined function. Defining user-defined functions. To work with user-defined functions, it requires the following concepts about functions. Declaration of a function. Definition of a function. Function call. Declaration of a function. A function declaration specifies the name of the function, the parameters to pass, including their type, order, and number, the return type after completion of execution. Example 4. Int maximum, open parenthesis, int, comma, int, close parenthesis, semicolon. Or int maximum, open parenthesis, int a comma, int b, close parenthesis, semicolon. Syntax. Return underscore type, function underscore name, open parenthesis, parameter underscore list, close parenthesis, semicolon. Names of parameters are optional in the declaration. The default return type for C functions is int. A function with void return type returns nothing. Empty parentheses after a function name in a declaration specify that the function does not accept any parameters. Definition of a function. A function definition specifies how to perform the specified task, how to accept passed parameters, how to process parameters or execute instructions to produce the required result, that is, the return value. A function definition is a self-contained block of instructions that is executed when the function is called. Syntax. Return underscore type, function underscore name, open parenthesis, parameter list, close parenthesis. Open curly brace. Local declarations, semicolon. Executable statements, semicolon. Close curly brace. Example. Int maximum, open parenthesis, int a comma, int b, close parenthesis. Open curly brace. If, open parenthesis, a greater than b, close parenthesis. Return a semicolon. Else, Return B, semicolon. Close curly brace. Function call. A function call specifies where to execute the function, when to execute the function. Note, if the function definition is provided before its use, that is, before the function call, the declaration is optional. The following example describes the control flow during a function call. Void hello, open parenthesis, close parenthesis, semicolon. / declaration. Void main, open parenthesis, close parenthesis. Open curly brace. Printf, open parenthesis, double quote, \n function, double quote, close parenthesis, semicolon. Hello, open parenthesis, close parenthesis, semicolon. Printf, open parenthesis, double quote, \n main after call to hello, double quote, close parenthesis, semicolon. Close curly brace. Void hello, open parenthesis, close parenthesis. / definition. Open curly brace. Printf, open parenthesis, double quote, \n function hello, double quote, close parenthesis, semicolon. Return, semicolon. Close curly brace. A return statement has two important uses. It first causes an immediate exit from the function. Second, it may be used to return a value. If a function does not return any value, then the return statement is optional. Recursion. In general, programmers use two approaches to write repetitive algorithms. One approach uses loops, and the other uses recursion. Recursive functions typically implement recurrence relations, in which the desired expression or function involving a positive integer n is described in terms of the function applied to corresponding values for integers less than n. A function written in terms of itself is called a recursive case. The recursive case must call the function with a decreasing value of n. Recursion in computer programming is exemplified when a function is defined in terms of itself. Recursion is a repetitive process in which a function calls itself. Note, a recursive function must have an if condition to force the function to return without making a recursive call. If there is no such condition, the function execution falls into an infinite loop. Rules for designing a recursive function. Determine the base case. Determine the general case. Combine the base case and the general case into a function. Example 5. Recursive factorial function. Int factorial, open parenthesis, int n, close parenthesis. Open curly brace. If open parenthesis, n equals 0, close parenthesis. Return 1, semicolon. Else. Return, open parenthesis, n multiplied by factorial, open parenthesis, n minus 1, close parenthesis, semicolon. Close curly brace. The statement if, open parenthesis, n equals 0, close parenthesis is the base condition, which stops the recursive call of the function. The statement return n multiplied by factorial, open parenthesis, n minus 1, close parenthesis, semicolon reduces the size of the problem by recursively calling the factorial function with n minus 1. Execution sequence for factorial. For factorial of 3. Factorial, open parenthesis, 3, close parenthesis equals 3 multiplied by factorial, open parenthesis, 2, close parenthesis. Factorial, open parenthesis, 2, close parenthesis equals 2 multiplied by factorial, open parenthesis, 1, close parenthesis. Factorial, open parenthesis, 1, close parenthesis equals 1 multiplied by factorial, open parenthesis, 0, close parenthesis. Factorial, open parenthesis, 0, close parenthesis equals 1. Now the recursive calls return. Factorial, open parenthesis, 1, close parenthesis equals 1 multiplied by 1, which is 1. Factorial, open parenthesis, 2, close parenthesis equals 2 multiplied by 1, which is 2. Factorial, open parenthesis, 3, close parenthesis equals 3 multiplied by 2, which is 6. Disadvantages. Recursive programs increase the execution time of a program. Recursive programs typically use a large amount of computer memory, and the greater the recursion, the more memory is used. Recursive programs can be confusing to develop and are extremely complicated to debug. Parameter passing. There are two ways of passing parameters to functions in the C language. Pass by value. Pass by address. Pass by value. When parameters are passed by value, copies are created in the called function. This mechanism is used when we do not want to change the values of the actual parameters. Pass by address. In this case, only the addresses of the parameters are passed to the called function. Therefore, manipulation of the formal parameters affects the actual parameters. Example 6. Void swap 1, open parenthesis, int, comma, int, close parenthesis, semicolon. Slash asterisk, function to swap two numbers by passing values, asterisk slash. Void swap 2, open parenthesis, int asterisk, comma, int asterisk. Close parenthesis, semicolon. Slash asterisk, function to swap two numbers by passing address, asterisk slash. Void main, open parenthesis, close parenthesis. Open curly brace. Int A equals 10, comma, B equals 15, comma, C equals 5, comma, D equals 25, semicolon. Print open parenthesis, double quote, value of A and B before swapping, colon, %D, comma, %D, double quote, comma, A, comma, B, close parenthesis, semicolon. Swap 1, open parenthesis, A, comma, B, close parenthesis, semicolon. Print open parenthesis, double quote, values of A and B after swapping, colon, %D, comma, %D, double quote, comma, A, comma, B, close parenthesis, semicolon. Print open parenthesis, double quote, value of C and D before swapping, colon, %D, comma, %D, double quote, comma, C, comma, D, close parenthesis, semicolon. Swap 2, open parenthesis, ampersand C, comma, ampersand D, close parenthesis, semicolon. Print open parenthesis, double quote, values of C and D after swapping, colon, %D, comma, %D, double quote, comma, C, comma, D, close parenthesis, semicolon. Close curly brace. Function swap 1. Void swap 1, open parenthesis, int X, comma, int Y, close parenthesis. Open curly brace. Int temp, semicolon. Temp equals X, semicolon. Equals Y, semicolon. Y equals temp, semicolon. Close curly brace. Function swap 2. Void swap 2, open parenthesis, int asterisk X, comma, int asterisk Y, close parenthesis. Open curly brace. Int temp, semicolon. Temp equals asterisk X, semicolon. Asterisk equals asterisk Y, semicolon. Asterisk Y equals temp, semicolon. Close curly brace. Output. Value of NB before swapping, 10, 15. Value of NB after swapping, 10, 15. Value of C and D before swapping, 5, 25. Value of C and D after swapping, 25, 5. Table 1. Comparison of pass by value and pass by address. Pass by value, also known as call by value, passes the values of the actual parameters. Formal parameters act as duplicates or copies of the actual parameters. Operations on the formal parameters do not affect the actual parameters. Passing parameters is time-consuming as the data size increases. Actual parameters are secured. Pass by address, also known as call by address or call by reference, passes the addresses of the actual parameters. Formal parameters act as references to the actual parameters. Operations on the formal parameters affect the actual parameters. The size of the parameters does not affect the time required for transferring references. Helps return multiple parameters. Solved examples. Example 1. Consider the following C program. Hash include less than stdio.h greater than. Int fun, open parenthesis, int n, comma, int asterisk fp, close parenthesis. Open curly brace. Int t, comma f semicolon. If, open parenthesis, n less than or equal to 1, close parenthesis. Open curly brace. Asterisk fp equals 1, semicolon. Return 1, semicolon. Close curly brace. T equals fun, open parenthesis, n minus 1, comma, fp, close parenthesis, semicolon. F equals t plus asterisk fp, semicolon. Asterisk fp equals t, semicolon. Return f, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int equals 15, semicolon. Print, open parenthesis, double quote, percentage d backslash n, double quote, comma, fun, open parenthesis, 5, comma, ampersand x, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. What is the output? Option A2. Option B4. Option C8. Option D16. Solution. Option C8. Execution stack. The following execution stack diagrams show the sequence of recursive function calls. Initially, only the main function is present in the execution stack. The main function calls fun, passing the value 5 and the address of x. Next, fun calls itself with the value 4. Then, fun calls itself with the value 3. Each diagram represents a new recursive function call being pushed onto the execution stack, while the previous function calls remain suspended until the recursive call returns. Note, a dash indicates that no memory is allocated to the variable. The letter G indicates a garbage value. Execution stack. The next diagram shows that the recursive call reaches the base case, where fun is called with the value 1. Since the condition n less than or equal to 1 is true, the function assigns 1 to the location pointed to by fp and returns 1. After returning from the base case, the execution stack begins to unwind. The next diagram shows the return from fun, open parenthesis, 2, comma, ampersand x, close parenthesis. The values of t, f, and the variable pointed to by fp are updated according to the function statements. The following diagram shows the return from fun, open parenthesis, 3, comma, ampersand x, close parenthesis. Again, the local variables are updated, and the function returns to its caller. The next diagram shows the return from fun, open parenthesis, 4, comma, ampersand x, close parenthesis. The recursive calls continue to return one by one until control reaches the original function call. The next diagram shows the final return from fun, open parenthesis, 5, comma, ampersand x, close parenthesis. At this stage, t contains 5. F contains 8. N is 5. The value pointed to by fp, that is x, becomes 5. After the function returns, only the main function remains on the execution stack. Finally, x contains 8, so the print statement prints 8. Example 2. What does the following program print? Hash include, less than stdio.h, greater than. Void f, open parenthesis, int asterisk p, comma, int asterisk q, close parenthesis. Open curly brace. P equals q, semicolon. Asterisk p equals 12, semicolon. Close curly brace. Int I equals 0, comma, j equals 1, semicolon. Int main, open parenthesis, close parenthesis. Open curly brace. F, open parenthesis, ampersand I, comma, ampersand j, close parenthesis, semicolon. Print, open parenthesis, double quote, percentage d, space, percentage d backslash n, double quote, comma, I, comma, j, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. What is the output? Option A2, 12. Option B 12, 1. Option C 0, 1. Option D 0, 12. Solution. Option D 0, 12. Initially, the address of I is stored in P, and the address of J is stored in Q. The statement P equals Q makes P point to J. The statement asterisk P equals 12 changes the value of J to 12. The value of I remains unchanged. Therefore, the output is 0, 12. Example 3. What is the value printed by the following program? Hash include less than stdio.h greater than int f open parenthesis int asterisk a comma int n close parenthesis. Read the complete program. Solution. Option C 15. The first function call is f open parenthesis a comma 6 close parenthesis, where it points to the first element of the array. The recursive function processes one array element at a time and moves to the next element in every recursive call. The execution continues until the base condition is reached. As the recursive calls return, the intermediate values are combined according to the function logic. Finally, the function returns 15, which is printed by the printf statement. Scope, lifetime, and binding. Storage classes specify the scope, lifetime, and binding of variables. To fully define a variable, one needs to mention not only its type, but also its storage class. A variable name identifies a physical location within computer memory, where a collection of bits is allocated for storing the value of the variable. Storage class tells us where the variable is stored, either in memory or CPU registers. What the initial value of the variable is, if no value is explicitly initialized. What is the scope of the variable, that is, where it can be accessed? What is the lifetime of the variable? Scope. The scope defines the visibility of an object. It defines where an object can be referenced or accessed. Generally, the scope of a variable is local or global. Variables defined within a block have local scope. They are visible only within the block in which they are defined. Variables defined in the global area are visible from their definition until the end of the program. They are visible everywhere in the program. Lifetime. The lifetime of a variable defines the duration for which the computer allocates memory to it. That is, the duration between memory allocation and deallocation. In C, variables can have automatic, static, or dynamic lifetime. Automatic. Variables with automatic lifetime are created each time their declaration is encountered and are destroyed each time their block is exited. Static. A variable is created when the declaration is executed for the first time and is destroyed when the execution stops or terminates. Dynamic. The variable's memory is allocated and deallocated through memory management functions. Binding. Binding finds the corresponding binding occurrence. That is, the declaration or definition for an applied occurrence or usage of an identifier. For binding, the scope of variables should be known. What is the block structure? In which block is the identifier visible? What happens if we use the same identifier name again? C forbids the use of the same identifier name in the same scope. However, the same name can be used in different scopes. Examples. Example 1. Double F, Y, semicolon. Int F, open parenthesis, close parenthesis. Open curly brace. ... Close curly brace. Double Y, semicolon. This results in an error. Example 2. Double Y, semicolon. Int F, open parenthesis, close parenthesis. Open curly brace. Double F, semicolon. This is legal. Int Y, semicolon. This is illegal. Close curly brace. Storage classes in C. There are 4 storage classes in C. Automatic. Storage area, memory. Default initial value, till the control remains in the block. Lifetime, till the control remains in the block. Scope, local. Keyword, auto. Register. Storage area, CPU register. Default initial value, an unpredictable value, also called a garbage value. Lifetime, till the control remains in the block. Scope, local. Keyword, register. Static. Storage area, memory. Default initial value, 0. Lifetime, the value of the variable persists between function calls. Scope, local. Keyword, static. External. Storage area, memory. Default initial value, an unpredictable value, also called a garbage value. Lifetime, throughout the program execution. Scope, global. Keyword, extern. Note, the default storage class is auto. Example 4. What will be the output of the following program? Read the complete program. Options. Option A, error. Option B, 11, 22, 33. Option C, 11, 22, garbage. Option D, 11, 11, 11. Solution. Option B. The opening curly brace introduces a new block, and therefore a new scope. In the innermost block, I is declared as a const volatile unsigned int, which is a valid declaration. So, the first print prints 11. In the next block, I has the value 22, so the second print prints 22. In the outermost block, I is declared as extern, so the linker resolves it to the global variable I. Since it is the only variable visible in that scope, the final print prints 33. Example 5. Consider the following C program. Read the complete program. Question. What is the value of f, open parenthesis, 5, close parenthesis? Options. Option A, 15. Option B, 17. Option C, 18. Option D, 19. Solution. Option C, 18. Call sequence. The function is first called as f, open parenthesis, 5, close parenthesis. Since n is greater than 3, the function calls f, open parenthesis, 3, close parenthesis, and later adds 2 to its result. The call f, open parenthesis, 3, close parenthesis returns f, open parenthesis, 2, close parenthesis plus the value of the static variable r. Similarly, f, open parenthesis, 2, close parenthesis returns f, open parenthesis, 1, close parenthesis plus r. F, open parenthesis, 1, close parenthesis returns f, open parenthesis, 0, close parenthesis plus r. F, open parenthesis, 0, close parenthesis reaches the base case and returns 1. As the recursive calls return, the results are combined, giving the final value 18. Common data for questions 6 and 7. Consider the following recursive C function that takes 2 arguments, unsigned int n and unsigned int r. Read the complete program. Example 6. What is the return value of the function foo when it is called as foo, open parenthesis, 512, 2, close parenthesis? Options. Option A, 9. Option B, 8. Option C, 2. Option D, 1. Solution. Option D, 1. The recursion repeatedly divides n by r until the base condition is reached. The recursive call sequence is foo, open parenthesis, 512, 2, close parenthesis. Then foo, open parenthesis, 256, 2, close parenthesis. Then foo, open parenthesis, 128, 2, close parenthesis. Then foo, open parenthesis, 64, 2, close parenthesis. Then foo, open parenthesis, 32, 2, close parenthesis. Then foo, open parenthesis, 16, 2, close parenthesis. Then foo, open parenthesis, 8, 2, close parenthesis. Then foo, open parenthesis, 4, 2, close parenthesis. Then foo, open parenthesis, 2, 2, close parenthesis. Then foo, open parenthesis, 1, 2, close parenthesis. Finally, foo, open parenthesis, 0, 2, close parenthesis. The base condition returns 0, and all recursive calls return 1. Therefore, the final answer is 1. Example 7. What is the return value for the function call foo, open parenthesis, 345, 10, close parenthesis? Options. Option A, 345. Option B, 12. Option C, 5. Option D, 3. Solution. Option B, 12. The recursive calls are foo, open parenthesis, 345, 10, close parenthesis. Then foo, open parenthesis, 34, 10, close parenthesis. Then foo, open parenthesis, 3, 10, close parenthesis. Then foo, open parenthesis, 0, 10, close parenthesis. The values contributed during the return are 5 plus 4 plus 3, giving a final result of 12. Exercises. Practice problems 1. Directions for questions 1 to 15. Select the correct alternative from the given choices. Question 1. What will be the output of the following program? Main, open parenthesis, close parenthesis. Open curly brace. Main, open parenthesis, close parenthesis, semicolon. Close curly brace. Options. Option A, overflow error. Option B, syntax error. Option C, returns 0. Option D, returns 1. Question 2. Output of the following program is main, open parenthesis, close parenthesis. Open curly brace. Static int var equals 6, semicolon. Printf, open parenthesis, double quote, %d \t, double quote, comma, var minus minus, close parenthesis, semicolon. If, open parenthesis, var, close parenthesis. Main, open parenthesis, close parenthesis, semicolon. Close curly brace. Options. Option A, 543210. Option B, 666666. Option C, 654321. Option D, error. Question 3. Which of the following will be the output of the program? Main, open parenthesis, close parenthesis. Open curly brace. Char SDR, open square bracket, close square bracket, equals double quote hello double quote, semicolon. Display, open parenthesis, SDR, close parenthesis, semicolon. Close curly brace. Void display, open parenthesis, char asterisk SDR, close parenthesis. Open curly brace. Print, open parenthesis, double quote, %s, double quote, comma, SDR, close parenthesis, semicolon. Close curly brace. Options. Option A, compilation error. Option B, hello. Option C, print null string. Option D, no output. Question 4. Consider the following C function. Read the complete program. What is the value of fun? Open parenthesis, 5, close parenthesis. Options. Option A, 4. Option B, 15. Option C, 18. Option D, 19. Question 5. For the following C function. Void swap, open parenthesis, int I, comma, int B, close parenthesis. Open curly brace. Int T, semicolon. T equals a semicolon. A equals B, semicolon. B equals T, semicolon. Close curly brace. In order to exchange the values of two variables, W and Z. Option A, call swap, open parenthesis, W, comma, Z, close parenthesis. Option B, call swap, open parenthesis and W, comma, and Z, close parenthesis. Option C, swap, open parenthesis, W, comma, Z, close parenthesis cannot be used because it does not return any value. Option D, swap, open parenthesis, W, comma, Z, close parenthesis cannot be used because the parameters are passed by value. Question 6. Choose the correct option to fill question mark and question mark. Why? So that the following program prints an input string in reverse order. Assume that the input string is terminated by a newline character. Read the complete program. Options. Option A, question mark, is getchar, open parenthesis, close parenthesis, not equals \n. Question mark Y is getchar, open parenthesis, A, close parenthesis. Option B, question mark, is open parenthesis A equals getchar, open parenthesis, close parenthesis, not equals \n. Question mark Y is getchar, open parenthesis, A, close parenthesis. Option C, question mark, is open parenthesis A equals \n, close parenthesis. Question mark Y is pachar, open parenthesis, A, close parenthesis. Option D, question mark, is open parenthesis A equals getchar, open parenthesis, close parenthesis, not equals \n. Question mark Y is pachar, open parenthesis, A, close parenthesis. Question 7. Main, open parenthesis, close parenthesis. Open curly brace. Extern int, a semicolon. A equals 30, semicolon. Print, open parenthesis, double quote, %d double quote, comma, a close parenthesis, semicolon. Close curly brace. What will be the output of the above program? Option A, 30. Option B, compiler error. Option C, runtime error. Option D, linker error. Question 8. Which of the following will be the output of the program? Void main, open parenthesis, close parenthesis. Open curly brace. Int n equals ret, open parenthesis, sizeof, open parenthesis, float, close parenthesis, semicolon. Print, open parenthesis, double quote, \n value is %d, double quote, comma, ++n, close parenthesis, semicolon. Close curly brace. Int ret, open parenthesis, int ret, close parenthesis. Ret plus equals 2.5, semicolon. Return, open parenthesis, ret, close parenthesis, semicolon. Options. Option A, value is 6. Option B, value is 6.5. Option C, value is 7. Option D, value is 7.5. Question 9. The following program. Main, open parenthesis, close parenthesis. Open curly brace. PT, open parenthesis, close parenthesis, semicolon. PT, open parenthesis, close parenthesis, semicolon. PT, open parenthesis, close parenthesis, semicolon. Close curly brace. PT, open parenthesis, close parenthesis. Open curly brace. Static int, a semicolon. Print, open parenthesis, double quote, %d double quote, comma, ++ a close parenthesis, semicolon. Close curly brace. Prints. Option A, 0, 1, 2. Option B, 1, 2, 3. Option C, 3 consecutive but unpredictable numbers. Option D, 1, 1, 1. Question 10. What is the output of the following program? Read the complete program. Options. Option A, 0, 2, 4, 6. Option B, 0, 1, 2, 3. Option C, 0, 2, 0, 0. Option D, 1, 3, 5, 7. Question 11. What will be the output of the following code? Hash include, less than stdio.h, greater than. Read the complete program. Options. Option A, hi. Option B, hello. Option C, bye. Option D, garbage value. Question 12. What is the output? Read the complete program. Options. Option A, 5. Option B, 5, 5, 5, 5, 5. Option C, 0, 0, 0, 0. Option D, 1, 1, 1, 1. Question 13. If the following function gets compiled, what error would be raised? Read the complete function. Options. Option A, function should be defined as fun, open parenthesis, int x, comma, double y, close parenthesis. Option B, missing parenthesis in return. Option C, redeclaration of x. Option D, all of these. Question 14. Consider the following function. Read the complete function. What will happen if the function fun is called with the value 16? That is, fun, open parenthesis, 16, close parenthesis. Options. Option A, infinite loop. Option B, random value will be returned. Option C, 11,111. Option D, 10,000. Question 15. What is the output of the following program? Read the complete program. Options. Option A, error. Main cannot be called from main. Option B, infinite loop. Option C, 5, 4, 3, 2, 1. Option D, 0. Practice problems 2. Directions for questions 1 to 15. Select the correct alternative from the given choices. Question 1. An external variable. Option A is globally accessible by all functions. Option B has a declaration extern associated with it when declared within a function. Option C will be initialized to 0, if not initialized. Option D, all of the above. Question 2. The order in which actual arguments are evaluated in a function call is Option A, from the left. Option B, from the right. Option C, unpredictable. Option D, none of the above. Question 3. In the C language, is it necessary to declare the type of a function in the calling program if the function? Option A returns an integer. Option B returns a float. Option C, both A and B. Option D, none of the above. Question 4. What is the output? Void main, open parenthesis, close parenthesis. Open curly brace. Int k equals ret, open parenthesis, sizeof, open parenthesis, int, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d, double quote, comma, plus k, close parenthesis, semicolon. Close curly brace. Int ret, open parenthesis, int ret, close parenthesis. Open curly brace. Ret plus equals 2.5, semicolon. Return, open parenthesis, ret, close parenthesis, semicolon. Close curly brace. Options. Option A, 3.5. Option B, 5. Option C, 4. Option D, logical error. Question 5. When a recursive function is called, all its automatic variables are Option A, maintained in the stack. Option B, retained from the last execution. Option C, initialized during each call of the function. Option D, none of these. Question 6. Consider the following program segment. Int fun, open parenthesis, int x, comma, int y, close parenthesis. Open curly brace. If, open parenthesis, x greater than 0, close parenthesis. Return, open parenthesis, x percentage y, close parenthesis, plus fun, open parenthesis, divided by y, comma, y, close parenthesis, semicolon. Else. Return 0, semicolon. Close curly brace. What will be the output of the program segment if the function is called as fun, open parenthesis, 525, comma, 25, close parenthesis. Options. Option A, 25. Option B, 12. Option C, 21. Option D, 42. Question 7. Consider the following C program segment. Int fun, open parenthesis, int x, close parenthesis. Open curly brace. Static int I equals 0, semicolon. If, open parenthesis, x less than or equal to 0, close parenthesis. Return 1, semicolon. Else if, open parenthesis, x greater than 5, close parenthesis. Open curly brace. I equals x, semicolon. Return fun, open parenthesis, x minus 3, close parenthesis, plus 2, semicolon. Close curly brace. Return fun, open parenthesis, x minus 2, close parenthesis, plus I, semicolon. Close curly brace. What is the value of fun? Open parenthesis, 7, close parenthesis. Options. Option A 17. Option B 10. Option C 11. Option D 9. Question 8. Consider the following C program. Void rearrange, open parenthesis, close parenthesis. Open curly brace. Char ch, semicolon. If, open parenthesis, question mark x, close parenthesis. Rearrange, open parenthesis, close parenthesis, semicolon. Question mark y, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Print f, open parenthesis, double quote, backslash n, enter text to print reverse order, colon, double quote, close parenthesis, semicolon. Rearrange, open parenthesis, close parenthesis, semicolon. Close curly brace. Choose the correct option to fill question mark x and question mark y so that the program prints the entered text in reverse order. Assume that the input text is terminated by a newline. Options. Option A question mark x, open parenthesis, getchar, open parenthesis, ch, close parenthesis, not equals, backslash n, close parenthesis. Question mark y, puchar, open parenthesis, ch, close parenthesis. Option B question mark x, open parenthesis, getchar, open parenthesis, ch, close parenthesis, equals, backslash n, close parenthesis. Question mark y, ch equals puchar, open parenthesis, close parenthesis. Option C question mark x, open parenthesis, ch equals getchar, open parenthesis, close parenthesis, not equals, backslash n, close parenthesis. Question mark y, puchar, open parenthesis, ch, close parenthesis. Option D question mark x, open parenthesis, ch equals getchar, open parenthesis, close parenthesis, equals, backslash n, close parenthesis. Question mark y, puchar, open parenthesis, ch, close parenthesis. Question 9. Consider the following C function. Int f, open parenthesis, int n, close parenthesis. Open curly brace. Static int I equals 1, semicolon. If, open parenthesis, n greater than or equal to 5, close parenthesis. Return n, semicolon. N equals n plus I, semicolon. I plus plus, semicolon. Return f, open parenthesis, n, close parenthesis, semicolon. Close curly brace. The value returned by f, open parenthesis, 1, close parenthesis is Option A 5. Option B 6. Option C 7. Option D 8. Question 10. Consider the following C function. Int inker, open parenthesis, int I, close parenthesis. Open curly brace. Static int count equals 0, semicolon. Count equals count plus I, semicolon. Return, open parenthesis, count, close parenthesis, semicolon. Close curly brace. Main, open parenthesis, close parenthesis. Open curly brace. Int I, comma j, semicolon. For open parenthesis, I equals 0, semicolon, I less than or equal to 4, semicolon, I plus plus, close parenthesis. J equals inker, open parenthesis, I, close parenthesis, semicolon. Close curly brace. The value of j will be Option A 10. Option B 4. Option C 6. Option D 7. Question 11. The following function. Int trial, open parenthesis, int a comma, int b, comma, int c, close parenthesis. Open curly brace. If, open parenthesis, a greater than or equal to b, close parenthesis, ampersand, ampersand, open parenthesis, c less than b, close parenthesis, close parenthesis. Return b, semicolon. Else if, open parenthesis, a greater than or equal to b, close parenthesis. Return trial, open parenthesis, a comma, c, comma, b, close parenthesis, semicolon. Else. Return trial, open parenthesis, b, comma, a comma, c, close parenthesis, semicolon. Close curly brace. Options. Option A finds the maximum of a b, c. Option B finds the middle value of a b, c after sorting. Option C finds the minimum of a b, c. Option D, none of the above. Question 12. Consider the following pseudocode. F, open parenthesis, a comma, b, close parenthesis. Open curly brace. While open parenthesis, b not equals 0, close parenthesis. Open curly brace. T equals b, semicolon. B equals a percentage b, semicolon. A equals t, semicolon. Close curly brace. Return a semicolon. Close curly brace. Options. Option A, the above code computes HCF of 2, numbers are in B. Option B, the above code computes LCM of R and B. Option C, the above code computes GCD of R and B. Option D, none of the above. Question 13. Main, open parenthesis, close parenthesis. Open curly brace. Into equals 10, comma asterisk J, semicolon. Void asterisk K, semicolon. J equals K equals ampersand, semicolon. J plus plus, semicolon. K plus plus, semicolon. Printf, open parenthesis, double quote, backslash and percentage U, comma percentage U double quote, comma J, comma K, close parenthesis, semicolon. Close curly brace. Which of the following is true in reference to the above code? Option A, the above code will compile successfully. Option B, error on line number 6. Option C, error on line number 3. Option D, error on line number 4. Question 14. Aliasing in the context of programming languages refers to Option A, multiple variables having the same memory location. Option B, multiple variables having the same value. Option C, multiple variables having the same identifier. Option D, multiple uses of the same variable. Question 15. Match the following. XC. M equals malloc, open parenthesis, 5, close parenthesis, semicolon. M equals an ULL, semicolon. Y. Free, open parenthesis, N, close parenthesis, semicolon. N value equals 5, semicolon. Z. Char asterisk P, semicolon. Asterisk P equals single quote a single quote, semicolon. Match them with. Using dangling pointers. Using uninitialized pointers. Lost memory. Options. Option A, x equals 1, y equals 3, z equals 2. Option B, x equals 3, y equals 1, z equals 2. Option C, x equals 3, y equals 2, z equals 1. Option D, x equals 2, y equals 1, z equals 3. Previous year's questions. Question 1. In the following C function, let n greater than or equal to m. Int GCD, open parenthesis n, comma m, close parenthesis. Open curly brace. If open parenthesis, n percentage m, equals 0, close parenthesis. Return m, semicolon. N equals n percentage m, semicolon. Return GCD, open parenthesis m, comma n, close parenthesis, semicolon. Close curly brace. How many recursive calls are made by this function? Year, 2007. Options. Option A, theta of log base 2n. Option B, omega of n. Option C, theta of log base 2, log base 2n. Option D, theta of square root n. Question 2. What is the time complexity of the following recursive function? Int do something, open parenthesis, int n, close parenthesis. Open curly brace. If open parenthesis, n less than or equal to 2, close parenthesis. Return 1, semicolon. Else. Return, open parenthesis, do something, open parenthesis, floor, open parenthesis, square root of n, close parenthesis, plus n, close parenthesis, semicolon. Close curly brace. Year, 2007. Options. Option A, theta of n squared. Option B, theta of n log base 2n. Option C, theta of log base 2n. Option D, theta of log base 2, log base 2n. Question 3. Choose the correct option to fill question mark 1 and question mark 2 so that the following program prints an input string in reverse order. Assume that the input string is terminated by a newline character. Void reverse, open parenthesis, void, close parenthesis. Open curly brace. Int c, semicolon. If, open parenthesis, question mark 1, close parenthesis. Reverse, open parenthesis, close parenthesis, semicolon. Question mark 2, semicolon. Close curly brace. Main, open parenthesis, close parenthesis. Open curly brace. Printf, open parenthesis, double quote, enter text, double quote, close parenthesis, semicolon. Printf, open parenthesis, double quote, \n, double quote, close parenthesis, semicolon. Reverse, open parenthesis, close parenthesis, semicolon. Printf, open parenthesis, double quote, \n, double quote, close parenthesis, semicolon. Close curly brace. Year, 2008. Options. Option A, question mark 1. C equals getchar, open parenthesis, close parenthesis, not equals \n. Question mark 2. Getchar, open parenthesis, C, close parenthesis. Option B, question mark 1. Open parenthesis, C equals getchar, open parenthesis, close parenthesis, not equals \n. Question mark 2. Getchar, open parenthesis, C, close parenthesis. Option C, question mark 1. C less than \n. Question mark 2. Pachar, open parenthesis, C, close parenthesis. Option D, question mark 1. Open parenthesis, C equals getchar, open parenthesis, not equals \n, close parenthesis. Question mark 2. Pachar, open parenthesis, C, close parenthesis. Question 4. Consider the program below. Hash include, less than stdio.h, greater than. Int fun, open parenthesis, int n, comma, int asterisk f underscore p, close parenthesis. Open curly brace. Int t, comma f semicolon. If open parenthesis, n less than or equal to 1, close parenthesis. Open curly brace. Asterisk f underscore p equals 1, semicolon. Return 1, semicolon. Close curly brace. T equals fun, open parenthesis, n minus 1, comma, f underscore p, close parenthesis, semicolon. F equals t plus asterisk f underscore p, semicolon. Asterisk f underscore p equals t, semicolon. Return f, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int equals 15, semicolon. Printf, open parenthesis, double quote, %d\n, double quote, comma, fun, open parenthesis, 5, comma, ampersand x, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The value printed is. Year, 2009. Option A 6. Option B 8. Option C 14. Option D 15. Question 5. What is the value printed by the following C program? Hash include, less than stdio.h, greater than. Int f, open parenthesis, int asterisk a comma, int n, close parenthesis. open curly brace. If open parenthesis, n less than or equal to 0, close parenthesis. Return 0, semicolon. Else if, open parenthesis, a percentage 2 equals 0, close parenthesis. Return asterisk a plus f, open parenthesis, a plus 1, comma, n minus 1, close parenthesis, semicolon. Else. Return asterisk a minus f, open parenthesis, a plus 1, comma, n minus 1, close parenthesis, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int a, open square bracket, close square bracket, equals open curly brace 12, 7, 13, 4, 11, 6, close curly brace, semicolon. Print open parenthesis, double quote, percentage d double quote, comma f, open parenthesis, a comma 6, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. Year, 2010. Options. Option A -9. Option B 5. Option C 15. Option D 19. Common data for questions 6 and 7. Consider the following recursive C function that takes two arguments. Unsigned int n and unsigned int r. Int foo, open parenthesis, unsigned int n, comma, unsigned int r, close parenthesis. Open curly brace. If open parenthesis, n greater than 0, close parenthesis. Return open parenthesis, n percentage r, close parenthesis, plus foo, open parenthesis, n divided by r, comma, r, close parenthesis, semicolon. Else. Return 0, semicolon. Close curly brace. Question 6. What is the return value of the function foo when it is called as foo, open parenthesis, 513, 2, close parenthesis. Year, 2011. Options. Option A 9. Option B 8. Option C 5. Option D 2. Question 7. What is the return value of the function foo when it is called as foo, open parenthesis, 345, 10, close parenthesis. Year, 2011. Options. Option A 345. Option B 12. Option C 5. Option D 3. Common data for questions 8 and 9. Consider the following C code segment. Int a, b, c equals 0, semicolon. Void prt fun, open parenthesis, void, close parenthesis, semicolon. Main, open parenthesis, close parenthesis. Open curly brace. Static int a equals 1, semicolon. Prt fun, open parenthesis, close parenthesis, semicolon. A plus equals 1, semicolon. Prt fun, open parenthesis, close parenthesis, semicolon. Print open parenthesis, double quote, \n, percentage d space percentage d double quote, comma a comma b, close parenthesis, semicolon. Close curly brace. Void prt fun, open parenthesis, void, close parenthesis. Open curly brace. Static int a equals 2, semicolon. Int b equals 1, semicolon. A plus equals plus b, semicolon. Print open parenthesis, double quote, \n, percentage d space percentage d double quote, comma a comma b, close parenthesis, semicolon. Close curly brace. Question 8. What output will be generated by the given code segment if line 1 is replaced by auto int a equals 1. Line 2 is replaced by register in a equals 2. Year, 2012. Options. Option A. 3-1. 4-1. 4-2. Option B. 4-2. 6-1. 6-1. Option C. 4-2. 6-2. 2-0. Option D. 4-2. 4-2. 20. Question 9. What output will be generated by the given code segment? Year, 2012. Options. Option A, 31, 41, 42. Option B, 42, 61, 61. Option C, 42, 62, 20. Option D, 31, 52, 52. Question 10. What is the return value of f, open parenthesis, p, comma, p, close parenthesis, if the value of p is initialized to 5 before the call? Note that the first parameter is passed by reference, whereas the second parameter is passed by value. Int f, open parenthesis, int ampersand x, comma, int c, close parenthesis. Open curly brace. C equals c minus 1, semicolon. If, open parenthesis, c equals 0, close parenthesis. Return 1, semicolon. Equals x plus 1, semicolon. Return f, open parenthesis, x, comma, c, close parenthesis, asterisk x, semicolon. Close curly brace. Year, 2013. Options. Option A, 30,240. Option B, 6,561. Option C, 55,440. Option D, 161,051. Question 11. Consider the following pseudocode. What is the total number of multiplications to be performed? Year, 2014. D equals 2. For I equals 1 to n do. For j equals I to n do. For k equals j plus 1 to n do. D equals d asterisk 3. Options. Option A, half of the product of the 3 consecutive integers. Option B, 1/3 of the product of the 3 consecutive integers. Option C, 1/6 of the product of the 3 consecutive integers. Option D, none of the above. Question 12. Consider the function func shown below. Int func, open parenthesis, int num, close parenthesis. Open curly brace. Int count equals 0, semicolon. While, open parenthesis, num, close parenthesis. Open curly brace. Count plus plus, semicolon. Num right shift equals 1, semicolon. Close curly brace. Return, open parenthesis, count, close parenthesis, semicolon. Close curly brace. The value returned by func, open parenthesis, 435, close parenthesis is. Year, 2014. Question 13. Consider the following function. Double f, open parenthesis, double x, close parenthesis. Open curly brace. If, open parenthesis, absolute value of open parenthesis, x asterisk x minus 3, close parenthesis, less than 0.01, close parenthesis. Return x, semicolon. Else. Return f, open parenthesis, divided by 2 plus 1.5 divided by x, close parenthesis, semicolon. Close curly brace. Give a value of q to 2 decimal places, such that f, open parenthesis, q, close parenthesis will return q. Year, 2014. Question 14. Consider the following pseudocode, where x and y are positive integers. Begin. Q colon equals 0. R colon equals x. While r greater than or equal to y do. Begin. R colon equals r minus y. Q colon equals q plus 1. And the post condition that needs to be satisfied after the program terminates is. Year, 2015. Options. Option A, open curly brace, r equals q multiplied by y plus r, and r less than y, close curly brace. Option B, open curly brace, x equals q multiplied by y plus r, and r less than y, close curly brace. Option C, open curly brace, y equals q multiplied by x plus r, and 0 less than r less than y, close curly brace. Option D, open curly brace. Q plus 1 less than r minus y greater than 0, close curly brace. Question 15. Consider the following C function. Int fun, open parenthesis, int n, close parenthesis. Open curly brace. Int equals 1, comma k, semicolon. If, open parenthesis, n equals 1, close parenthesis. Return x, semicolon. For open parenthesis, k equals 1, semicolon, k less than n, semicolon, plus k, close parenthesis. Equals x plus fun, open parenthesis, k, close parenthesis, asterisk fun, open parenthesis, n minus k, close parenthesis, semicolon. Return x, semicolon. Close curly brace. The return value of fun, open parenthesis, 5, close parenthesis is year, 2015. Question 16. Consider the following recursive C function. Void get, open parenthesis, int n, close parenthesis. Open curly brace. If, open parenthesis, n less than 1, close parenthesis. Return, semicolon. Get, open parenthesis, n minus 1, close parenthesis, semicolon. Get, open parenthesis, n minus 3, close parenthesis, semicolon. Print, open parenthesis, double quote, percentage d double quote, comma n, close parenthesis, semicolon. Close curly brace. If get, open parenthesis, 6, close parenthesis is called in main, then how many times will the function get be invoked before returning to main? Year, 2015. Options. Option A, 15. Option B, 25. Option C, 35. Option D, 45. Question 17. Consider the following C program. Hash include, less than stdio.h, greater than. Int f1, open parenthesis, void, close parenthesis, semicolon. Int f2, open parenthesis, void, close parenthesis, semicolon. Int f3, open parenthesis, void, close parenthesis, semicolon. Int equals 10, semicolon. Int main, open parenthesis, close parenthesis. Open curly brace. Int equals 1, semicolon. X plus equals f1, open parenthesis, close parenthesis, plus f2, open parenthesis, close parenthesis, plus f3, open parenthesis, close parenthesis, plus f2, open parenthesis, close parenthesis, semicolon. Print, open parenthesis, double quote, percentage d double quote, comma x, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. Int f1, open parenthesis, close parenthesis. Open curly brace. Int equals 25, semicolon. X plus plus, semicolon. Return x, semicolon. Close curly brace. Int f2, open parenthesis, close parenthesis. Open curly brace. Static int x equals 50, semicolon. X plus plus, semicolon. Return x, semicolon. Close curly brace. Int f3, open parenthesis, close parenthesis. Open curly brace. X asterisk equals 10, semicolon. Return x, semicolon. Close curly brace. The output of the program is year, 2015. Question 18. Suppose C equals less than open square bracket 0 close square bracket. That is, C points to an array of length k, where all the entries are from the set open curly brace, 0, 1, close curly brace. For any positive integers a and n, consider the following pseudocode. DOSOMIT change, open parenthesis, C, a comma, n, close parenthesis. Z less than -1. For I equals 0 to k minus 1. Do Z equals Z squared mod n. If C open square bracket, I close square bracket equals 1. Then Z equals open parenthesis, Z multiplied by a close parenthesis mod n. Return Z. If k equals 4, C equals less than 0. 1, 0, 1 greater than a equals 2, and n equals 8, then the output of DOSOMETHING, open parenthesis, C, comma, a comma, n close parenthesis is. Year, 2015. Question 19. What will be the output of the following C program? Void count, open parenthesis, int n, close parenthesis. Open curly brace. Static int d equals 1, semicolon. Printf, open parenthesis, double quote, percentage d space, double quote, comma, n, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d space, double quote, comma, d, close parenthesis, semicolon. D++, semicolon. If, open parenthesis, n greater than 1, close parenthesis. Count, open parenthesis, n minus 1, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d space, double quote, comma, d, close parenthesis, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Count, open parenthesis, 3, close parenthesis, semicolon. Close curly brace. Year, 2016. Options. Option A 3, 1221344. Option B 3, 1211122. Option C 3, 122134. Option D 3, 121112. Question 20. The following function computes x raised to the power y for positive integers, x and y. Int x, open parenthesis, int x, comma, int y, close parenthesis. Open curly brace. Int raise equals 1, comma, a equals x, comma, b equals y, semicolon. While open parenthesis, b not equals 0, close parenthesis. Open curly brace. If, open parenthesis, b percentage 2 equals 0, close parenthesis. Open curly brace. A equals a multiplied by a, semicolon. b equals b divided by 2, semicolon. Close curly brace. Else. Open curly brace. Raise equals raise multiplied by, semicolon. b equals b minus 1, semicolon. Close curly brace. Close curly brace. Return raise, semicolon. Close curly brace. Which one of the following conditions is true before every iteration of the loop? Year, 2016. Options. Option A, x raised to the power y equals a raise to the power. Option B, open parenthesis, raise multiplied by a close parenthesis raised to the power y equals open parenthesis, raise multiplied by x, close parenthesis raised to the power. Option C, x raised to the power y equals raise multiplied by a raise to the power. Option D, x raised to the power y equals open parenthesis, raise multiplied by a close parenthesis raised to the power. Question 21. Consider the following two functions. Void fun1, open parenthesis, int n, close parenthesis. Open curly brace. If, open parenthesis, n equals 0, close parenthesis. Return, semicolon. Printf, open parenthesis, double quote, percentage d double quote, comma n, close parenthesis, semicolon. Fun2, open parenthesis, n minus 2, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d double quote, comma n, close parenthesis, semicolon. Close curly brace. Void fun2, open parenthesis, int n, close parenthesis. Open curly brace. If, open parenthesis, n equals 0, close parenthesis. Return, semicolon. Printf, open parenthesis, double quote, percentage d double quote, comma n, close parenthesis, semicolon. Fun1, open parenthesis, plus n, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d double quote, comma n, close parenthesis, semicolon. Close curly brace. The output printed when fun1, open parenthesis, 5, close parenthesis is called is. Year, 2017. Options. Option A 5432, 312233445. Option B, 534231201122333. Option C, 5342312132435. Option D, 534231202132243. Question 22. Consider the C functions foo and bar given below. Int foo, open parenthesis, int val, close parenthesis. Open curly brace. Int equals 0, semicolon. While open parenthesis, val greater than 0, close parenthesis. Open curly brace. Equals x plus foo, open parenthesis, val minus minus, close parenthesis, semicolon. Close curly brace. Return val, semicolon. Close curly brace. Int bar, open parenthesis, int val, close parenthesis. Open curly brace. Int equals 0, semicolon. While open parenthesis, val greater than 0, close parenthesis. Open curly brace. X equals x plus bar, open parenthesis, val minus 1, close parenthesis, semicolon. Close curly brace. Return val, semicolon. Close curly brace. Invocations of foo, open parenthesis, 3, close parenthesis and bar, open parenthesis, 3, close parenthesis will result in. Year, 2017. Options. Option A returns 6 and 6 respectively. Option B, infinite loop, and abnormal termination respectively. Option C, abnormal termination, and infinite loop respectively. Option D, both terminating abnormally. Question 23. The output of executing the following C program is hash include, less than stdio.h, greater than. Int total, open parenthesis, int v, close parenthesis. Open curly brace. Static int count equals 0, semicolon. While, open parenthesis, v, close parenthesis. Open curly brace. Count plus equals v ampersand 1, semicolon. V right shift equals 1, semicolon. Close curly brace. Return count, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Static int equals 0, semicolon. Int I equals 5, semicolon. For open parenthesis, semicolon, I greater than 0, semicolon, I minus minus, close parenthesis. Open curly brace. X equals x plus total, open parenthesis, I, close parenthesis, semicolon. Close curly brace. Printf, open parenthesis, double quote, percentage d backslash n, double quote, comma, x, close parenthesis, semicolon. Close curly brace. Year, 2017. Question 24. Consider the following C program. Hash include, less than stdio.h, greater than. Int counter equals 0, semicolon. Int calc, open parenthesis, int a comma, int b, close parenthesis. Open curly brace. Int c, semicolon. Counter plus plus, semicolon. If, open parenthesis, b equals 3, close parenthesis. Return, open parenthesis, a multiplied by a close parenthesis, semicolon. Else. Open curly brace. C equals calc, open parenthesis, a comma, b divided by 3, close parenthesis, semicolon. Return, open parenthesis, c multiplied by c, close parenthesis, semicolon. Close curly brace. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Calc, open parenthesis, 4, 81, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage d, double quote, comma, counter, close parenthesis, semicolon. Close curly brace. The output of this program is year, 2018. Question 25. Consider the following program, written in pseudocode. Assume that x and y are integers. Count, open parenthesis, x, comma, y, close parenthesis, open curly brace. If open parenthesis, y not equals 1, close parenthesis, open curly brace. If open parenthesis, x not equals 1, close parenthesis, open curly brace. Print open parenthesis, double quote, asterisk, double quote, close parenthesis, semicolon. Count open parenthesis, divided by 2, comma, y, close parenthesis, semicolon. Close curly brace. Else, open curly brace, y equals y minus 1, semicolon. Count open parenthesis, 1024, comma, y, close parenthesis, semicolon. Close curly brace. Close curly brace. Close curly brace. The number of times the print statement is executed by the call count, open parenthesis, 1024, comma, 1024, close parenthesis is. Year, 2018. Chapter 3. Arrays, pointers and structures. Arrays. In C, we have the following derived data types. Arrays. Pointers. Structures. Unions. Imagine a problem that requires us to read, process, and print 10 integers. We can declare 10 different variables, each with a different name. However, having 10 different variable names creates a problem. We would need 10 input statements and 10 output statements, one for each variable. Definition. An array is a collection of elements of the same data type. An array is a sequential collection. We refer to the elements of an array as the 0th element, first element, second element, and so on, until the last element. Each array element is individually addressed using its subscript, or index, along with the array name. The subscript is written inside square brackets, followed by the array name. This notation is called indexing. A loop makes array processing much easier. Whether there are 1, 10, 100, or 1,000 elements, the same logic can be used. We can also use a variable as the index. As the value of the variable changes, it refers to different elements of the array. Syntax of array declaration. Syntax. Data underscore type, array underscore name, open square bracket, size, close square bracket, semicolon. Here, data type specifies the type of elements stored in the array. Array name is the name given to the collection. Size specifies the number of elements in the array. Example. Int marks, open square bracket, 6, close square bracket, semicolon. Here, int specifies the data type. Marks is the name of the array. 6 specifies the size of the array. The square brackets indicate that marks is an array. Accessing array elements. All array elements are numbered starting from 0. Therefore, marks open square bracket 3 close square bracket refers to the 4th element, not the 3rd. Examples. Marks open square bracket 2 close square bracket refers to the 3rd element. Marks open square bracket 0 close square bracket refers to the 1st element. We can also use a variable as the index. For example, marks open square bracket, I close square bracket refers to the ith element. As the value of I changes, it refers to different elements in the array. Summary about arrays. An array is a collection of similar elements. The first element has index 0. The last element has an index equal to array size minus 1. An array is also known as a subscripted variable. Before using an array, its data type and size must be declared. Array elements are stored in contiguous memory locations. Individual elements are accessed using their index. The index of an array must be an integer. Array initialization. Syntax. Data underscore type, array underscore name, open square bracket, size, close square bracket, equals, open curly brace, values, close curly brace, semicolon. Example. Int n, open square bracket, 6, close square bracket, equals, open curly brace, 2, 4, 8, 12, 20, 25, close curly brace, semicolon. Array, initialized with a list of values. Int num, open square bracket, 10, close square bracket, equals, open curly brace, 2, 4, 12, 20, 35, close curly brace, semicolon. The remaining 5 elements are automatically initialized with 0. Int b, open square bracket, 10, close square bracket, equals, open curly brace, 0, close curly brace, semicolon. The entire array is initialized with 0. Note: until array elements are assigned specific values, they contain garbage values. If the number of values used during initialization is less than the size of the array, the remaining elements are initialized with 0. If all elements are initialized, mentioning the array size is optional. Array elements in memory. Consider the declaration. Int num, open square bracket, 5, close square bracket, semicolon. What happens in memory when this declaration is made? Memory for 5 integers is allocated, that is, 10 bytes if each integer occupies 2 bytes. Since the array is not initialized, all elements contain garbage values. If the array is declared as static, all elements are initialized with 0. Note: in C, the compiler checks whether the subscript used for an array exceeds its size. However, if a subscript beyond the array size is used, the data is placed in memory outside the array, and generally no warning or error is generated. Passing array elements to a function. Array elements can be passed to a function by value or by reference. Example, passing an array by value. Void main, open parenthesis, close parenthesis. Open curly brace. Void display, open parenthesis, int open square bracket, close parenthesis, semicolon. This is the function declaration. Int marks, open square bracket, close square bracket, equals, open curly brace, 10, 15, 20, 25, 30, close curly brace, semicolon. Display, open parenthesis, marks, close parenthesis, semicolon. This is the function call. Close curly brace. Void display, open parenthesis, int n, open square bracket, close parenthesis. This is the function definition. Open curly brace. Int I, semicolon. For open parenthesis, I equals 0, semicolon, I less than 5, semicolon, I plus plus, close parenthesis. Printf, open parenthesis, double quote, %d space, double quote, comma, n open square bracket, I close square bracket, close parenthesis, semicolon. Close curly brace. Output 10, 15, 20, 25, 30. Here, the entire array is passed by its name. Since the formal parameter is declared as an array, it receives all the array elements. To pass only a single element, use the array index. For example, display, open parenthesis, marks open square bracket, I close square bracket, close parenthesis. This passes only the ith element. Example, passing an array by reference. Void main, open parenthesis, close parenthesis. Open curly brace. Void display, open parenthesis, int asterisk, close parenthesis, semicolon. Int marks, open square bracket, close square bracket, equals, open curly brace, 5, 10, 15, 20, 25, close curly brace, semicolon. Display, open parenthesis, ampersand marks open square bracket, 0, close square bracket, close parenthesis, semicolon. Close curly brace. Void display, open parenthesis, int asterisk p, close parenthesis. Open curly brace. Int I, semicolon. For open parenthesis, I equals 0, semicolon, I less than 5, semicolon, I plus plus, close parenthesis. Printf, open parenthesis, double quote, Percentage D space, double quote, comma, asterisk open parenthesis, P plus plus, close parenthesis, semicolon. Close curly brace. Output 5, 10, 15, 20, 25. Here, the address of the first element of the array is passed. The pointer variable p stores this address. By incrementing the pointer, all array elements can be accessed. Note: array elements are stored in contiguous memory locations. Passing the address of the first element allows access to the entire array. Two-dimensional arrays. A two-dimensional array is an array of arrays. It is a collection of one-dimensional arrays. Example: int x, open square bracket, 4, close square bracket, open square bracket, 2, close square bracket, semicolon. By convention, the first dimension specifies the number of rows. The second dimension specifies the number of columns in each row. In memory, whether it is a one-dimensional or two-dimensional array, the elements are stored in one continuous block of memory. Memory layout of a two-dimensional array. The arrangement of array elements of a two-dimensional array in memory is shown below. The elements are stored in contiguous memory locations. X open square bracket, 0 close square bracket, open square bracket, 0 close square bracket at address 6000. X open square bracket, 0 close square bracket, open square bracket, 1 close square bracket, at address 6002. X open square bracket, 1 close square bracket, open square bracket, 0 close square bracket, at address 6004. X open square bracket, 1 close square bracket, open square bracket, 1 close square bracket, at address 6006. X open square bracket, 2 close square bracket, open square bracket, 0 close square bracket, at address 6008. X open square bracket, 2 close square bracket, open square bracket, 1 close square bracket, at address 6010. X open square bracket, 3 close square bracket, open square bracket, 0 close square bracket, at address 6012. X open square bracket, 3 close square bracket, open square bracket, 1 close square bracket, at address 6014. Initialization. A two-dimensional array can be initialized in the following way. Int a, open square bracket, 4 close square bracket, open square bracket, 2 close square bracket, equals, open curly brace, 0, 1, 2, 3, 4, 5, 6, 7, close curly brace, semicolon. The nested braces can also be used to show the exact structure of the array. Int a, open square bracket, 4 close square bracket, open square bracket, 2 close square bracket, equals, open curly brace. Open curly brace, 0, 1, close curly brace, comma. Open curly brace, 2, 3, close curly brace, comma. Open curly brace, 4, 5, close curly brace, comma. Open curly brace, 6, 7, close curly brace. Close curly brace, semicolon. Here, each row is defined as a one-dimensional array of two elements enclosed within braces. Note: if the array is completely initialized with values, the size of the first dimension can be omitted. To access elements of a multi-dimensional array, multiple subscripts must be used. Nested loops are generally used to process multi-dimensional arrays. Multi-dimensional arrays. C allows arrays of 2 or more dimensions. The maximum number of dimensions depends on the compiler. Generally, a one-dimensional array is called a 1D array. A two-dimensional array is called a 2D array. A three-dimensional array is called a 3D array, and so on. Syntax. Type array underscore name, open square bracket D1 close square bracket, open square bracket D2 close square bracket, open square bracket D3 close square bracket, open square bracket DN close square bracket, semicolon. Here, DN specifies the size of the last dimension. Examples. Int table, open square bracket 5 close square bracket, open square bracket 5 close square bracket, open square bracket 20 close square bracket, semicolon. Float r, open square bracket 5 close square bracket, open square bracket 6 close square bracket, open square bracket 5 close square bracket, open square bracket 6 close square bracket, semicolon. An array named table is a three-dimensional array. A three-dimensional array is an array of arrays. Declaration and initialization of a three-dimensional array. A three-dimensional array can be viewed as an array of two-dimensional arrays. Similarly, a two-dimensional array is an array of one-dimensional arrays. The diagram illustrates this relationship. Example: void main, open parenthesis, close parenthesis, open curly brace, int I, comma j, comma k, semicolon, int r, open square bracket 3 close square bracket, open square bracket 3 close square bracket, open square bracket 3 close square bracket, equals, open curly brace, open curly brace, open curly brace, 11, 12, 13, close curly brace, comma, open curly brace, 14, 15, 16, close curly brace, comma, open curly brace, 17, 18, 19, close curly brace, comma, open curly brace, 21, 22, 23, close curly brace, comma, open curly brace, 24, 25, 26, close curly brace, comma, open curly brace, 27, 28, 29, close curly brace, comma, open curly brace, 31, 32, 33, close curly brace, comma, open curly brace, 34, 35, 36, close curly brace, comma, open curly brace, 37, 38, 39, close curly brace, close curly brace, semicolon. Printf, open parenthesis, double quote, 3D array elements, \n, double quote, close parenthesis, semicolon. For open parenthesis, I equals 0, semicolon, I less than 3, semicolon, I plus plus, close parenthesis. Open curly brace. For open parenthesis, j equals 0, semicolon, j less than 3, semicolon, j plus plus, close parenthesis. Open curly brace. For open parenthesis, k equals 0, semicolon, k less than 3, semicolon, k plus plus, close parenthesis. Open curly brace. Printf, open parenthesis, double quote, %d \t, double quote, comma, r open square bracket I close square bracket open square bracket j close square bracket open square bracket k close square bracket, close parenthesis, semicolon. Close curly brace. Printf, open parenthesis, double quote, \n, double quote, close parenthesis, semicolon. Close curly brace. Printf, open parenthesis, double quote, \n, double quote, close parenthesis, semicolon. Close curly brace. Close curly brace. Output. 3D array elements. 11, 12, 13. 14, 15, 16. 17, 18, 19. 21, 22, 23. 24, 25, 26. 27, 28, 29. 31, 32, 33. 34, 35, 36. 37, 38, 39. Syntax for three-dimensional array declaration. Data underscore type, array underscore name, open square bracket table close square bracket, open square bracket row close square bracket, open square bracket column close square bracket, semicolon. To store a value in a three-dimensional array, first specify the table number, then the row number, and finally the column number. Pointers. A pointer is a variable that stores the address of another variable. Because of pointers, C is considered a very powerful programming language. Consider the declaration. Int I equals 3, semicolon. This declaration tells the compiler to Reserve memory to store an integer value. Associate the variable name I with that memory location. Store the value 3 in that location. Memory map. Variable name I. Value stored 3. Memory address 2568. The actual memory address may differ from one execution to another. The expression &I returns the address of variable I. Example: P equals &I, semicolon. This stores the address of I in pointer variable P. The declaration int asterisk P, semicolon, tells the compiler that P is a pointer to an integer. Memory map of pointer. Variable P. Value stored, 2568 address of I. Address of P, 2720. Variable I. Value stored, 3. Address, 2568. Now pointer P refers to variable I. The value of I can be accessed in two ways. By using the variable name I. By using the pointer variable P. The asterisk operator is called the indirection operator or dereference operator. Example: int x, asterisk P, semicolon. P equals &x, semicolon. Here contains a value. P contains the address of x. If asterisk P equals 4, semicolon, then the value stored in becomes 4. Therefore, P means the address stored in P. Asterisk P means the value stored at the address contained in P. Example: int asterisk P, semicolon. Float asterisk x, semicolon. Char asterisk ch, semicolon. Here, P is a pointer to an integer. Is a pointer to a floating point value. Ch is a pointer to a character. Pointers always store addresses, and addresses are whole numbers. For example, if the declaration is float x, semicolon, then pointer stores the address of a floating point variable. Similarly, pointer ch stores the address of a character variable. Pointer to pointer. A pointer can also store the address of another pointer. Such a pointer is called a pointer to pointer. Example: void main, open parenthesis, close parenthesis. Open curly brace. Int I equals 3, asterisk P, double asterisk Q, semicolon. P equals &I, semicolon. Q equals &P, semicolon. Print open parenthesis, double quote, \n address of I equals %U, double quote, &I, close parenthesis, semicolon. Print open parenthesis, double quote, \n address of I equals %U, double quote, P, close parenthesis, semicolon. Print open parenthesis, double quote, \n address of I equals %U, double quote, asterisk Q, close parenthesis, semicolon. Print open parenthesis, double quote, \n address of P equals %U, double quote, &P, close parenthesis, semicolon. Print open parenthesis, double quote, \n address of P equals %U, double quote, Q, close parenthesis, semicolon. Print open parenthesis, double quote, \n address of Q equals %U, double quote, &Q, close parenthesis, semicolon. Print open parenthesis, double quote, \n value of I equals %D, double quote, I, close parenthesis, semicolon. Print open parenthesis, double quote, \n value of I equals %D, double quote, asterisk P, close parenthesis, semicolon. Print open parenthesis, double quote, \n value of I equals %D, double quote, double asterisk Q, close parenthesis, semicolon. Close curly brace. Memory map. I. Value, 3. Address, 2000. P. Value, 2000. Address, 2010. Q. Value, 2010. Address, 2050. Output. Address of I equals 2000. Address of I equals 2000. Address of I equals 2000. Address of P equals 2010. Address of P equals 2010. Address of Q equals 2050. Value of I equals 3. Value of I equals 3. Value of I equals 3. Note: a pointer can point to another pointer. There is no practical limit to how many levels of pointer indirection can be created. Pointers for interfunction communication. Functions can communicate in two ways. Call by value. Call by reference. If the actual parameter should not change inside the called function, use call by value. If the value of an actual parameter should change inside the called function, use call by reference. If a function has to return more than one value, return those values indirectly using call by reference. Example: the following program demonstrates how to return multiple values. Void main, open parenthesis, close parenthesis. Open curly brace. Void array, open parenthesis, int, comma, int asterisk, close parenthesis, semicolon. Int r, semicolon. Float a, comma, p, semicolon. Printf, open parenthesis, double quote, enter radius of a circle, double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote, %d, double quote, comma, ampersand r, close parenthesis, semicolon. Area peri, open parenthesis, r, comma, ampersand a, comma, ampersand p, close parenthesis, semicolon. Printf, open parenthesis, double quote, area equals %f, double quote, comma, a close parenthesis, semicolon. Printf, open parenthesis, double quote, backslash and perimeter equals %f, double quote, comma, p, close parenthesis, semicolon. Close curly brace. Void area peri, open parenthesis, int x, comma, int asterisk p, comma, int asterisk q, close parenthesis. Open curly brace. Asterisk p equals 3.14 multiplied by x, semicolon. Asterisk q equals 2 multiplied by 3.14 multiplied by x, semicolon. Close curly brace. Output. Enter radius of circle, 5. Area equals 78.5. Perimeter equals 31.4. Compatibility. Pointers have an associated data type. They are not just pointer variables, but pointers to a specific type. The size of all pointers is generally the same. Each pointer stores the address of one memory location, but the type of data it points to can be different. Pointer to void, generic pointer. A void pointer is a generic pointer. It can point to any data type. However, the data pointed to by a void pointer cannot be accessed directly. Since a void pointer has no associated data type, its size is unknown until it is typecast. Example: void main, open parenthesis, close parenthesis. Open curly brace. Int equals 10, semicolon. Float equals 5.7, semicolon. Void asterisk p, semicolon. P equals ampersand a, semicolon. Printf, open parenthesis, double quote, backslash and value of a equals %d, double quote, comma, asterisk open parenthesis in asterisk close parenthesis p close parenthesis, semicolon. P equals ampersand x, semicolon. Printf, open parenthesis, double quote, backslash and value of x equals %f, double quote, comma, asterisk open parenthesis, float asterisk close parenthesis p close parenthesis, semicolon. Close curly brace. Output. Value of equals 10. Value of equals 5.7. Operations that can be performed on pointers. 1. Addition of a number to a pointer. Example: int I equals 4, comma, asterisk j, comma, asterisk k, semicolon. J equals ampersand I, semicolon. J equals j plus 1, semicolon. K equals j plus 5, semicolon. 2. Subtraction of a number from a pointer. Example. Int I equals 4, comma, asterisk j, comma, asterisk k, semicolon. J equals ampersand I, semicolon. J equals j minus 1, semicolon. K equals j minus 3, semicolon. 3. Subtraction of one pointer from another. One pointer can be subtracted from another only if both point to elements of the same array. The result represents the number of array elements between the two pointers. Example. Void main, open parenthesis, close parenthesis. Open curly brace. Int a open square bracket, close square bracket, equals open curly brace 5, 10, 15, 20, 25, close curly brace, semicolon. Int asterisk I, asterisk j, semicolon. I equals ampersand a open square bracket 0 close square bracket, semicolon. J equals ampersand a open square bracket 4 close square bracket, semicolon. Printf open parenthesis, double quote, %d, % d double quote, j minus I, asterisk j minus asterisk I, close parenthesis, semicolon. Close curly brace. Output. 420. Here, j minus I equals 4, because the pointers are 4 array elements apart. Asterisk j minus asterisk I equals 20, because 25 minus 5 equals 20. 4. Comparison of two pointers. Two pointers can be compared only if they point to the same data type. Operations not allowed on pointers. Addition of two pointers. Multiplication of a pointer with another pointer or with a number. Division of a pointer by another pointer or by a number. Important points about pointer arithmetic. When a pointer is incremented, it points to the next memory location. When a pointer is decremented, it points to the previous element in memory. Notice the difference. Expression 1. Open parenthesis, asterisk p, close parenthesis plus plus. Here, the value pointed to by p is increased by 1. The pointer p itself is not modified. Expression 2. Asterisk p plus plus equals asterisk q plus plus, semicolon. Since the plus plus operator has higher precedence than the asterisk operator, both p and q are incremented. Because plus plus is used as a postfix operator, the current values pointed to by p and q are used first. After the assignment, both pointers are incremented. This is equivalent to asterisk p equals asterisk q, semicolon. Plus p, semicolon. Plus q, semicolon. Implementation of arrays in C. The array name is a pointer to the first element of the array. The following example shows how pointers are used with arrays. Int n open square bracket, close square bracket, equals open curly brace, 10, 20, 30, 40, 50, close curly brace, semicolon. The array n contains 10, 20, 30, 40, 50. Important points. The array name stores the base address of the array. Example. Int asterisk p equals n, semicolon. Now p points to the first element of array n. The 0th element of the array can be accessed using asterisk array underscore name. Example. Int equals asterisk n, semicolon. This stores the first element of array n into X. The following expressions are equivalent. Array underscore name. Open parenthesis, array underscore name, plus 0 close parenthesis. More generally, num open square bracket, I close square bracket, is equivalent to asterisk open parenthesis, num plus I close parenthesis, and also equivalent to asterisk open parenthesis, I plus num close parenthesis. Here, num is the array, I is the index, Array of pointers. Just as there can be an array of integers or floating point numbers, there can also be an array of pointers. An array of pointers stores addresses. Pointers in such an array may point to isolated variables or to array elements. Example 1. Array of pointers pointing to isolated variables. Int I equals 5, j equals 10, k equals 15, semicolon. Int asterisk app, open square bracket 3 close square bracket, semicolon. App open square bracket 0 close square bracket equals ampersand I, semicolon. App open square bracket 1 close square bracket equals ampersand j, semicolon. App open square bracket 2 close square bracket equals ampersand k, semicolon. Example 2. Array of pointers pointing to elements of an array. Int a open square bracket, close square bracket equals open curly brace 0, 20, 45, 50, 70, close curly brace, semicolon. Int asterisk p, open square bracket 5 close square bracket, I, semicolon. For open parenthesis, I equals 0, semicolon, I less than 5, semicolon, I plus plus, close parenthesis. P open square bracket, I close square bracket, equals ampersand a open square bracket, I close square bracket, semicolon. Example 3. Array of pointers pointing to different arrays. Int a open square bracket, close square bracket, equals open curly brace 5, 10, 20, 25, close curly brace, semicolon. Int b open square bracket, close square bracket equals open curly brace 0, 100, 200, 300, 400, close curly brace, semicolon. Int c open square bracket, close square bracket equals open curly brace 50, 150, 250, 350, 450, close curly brace, semicolon. Int asterisk p, open square bracket 3 close square bracket, semicolon. P open square bracket 0 close square bracket equals a semicolon. P open square bracket 1 close square bracket equals b, semicolon. P open square bracket 2 close square bracket equals c, semicolon. Example 4. Array of pointers pointing to the 0th element of each row of a two-dimensional array. Int a open square bracket 3 close square bracket, open square bracket 2 close square bracket equals open curly brace. Open curly brace 1, 2, close curly brace, open curly brace 3, 4, close curly brace, open curly brace 5, 6, close curly brace, semicolon. Int asterisk p, open square bracket 3 close square bracket, semicolon. P open square bracket 0 close square bracket equals a open square bracket 0 close square bracket, semicolon. P open square bracket 1 close square bracket equals a open square bracket 1 close square bracket, semicolon. P open square bracket 2 close square bracket equals a open square bracket 2 close square bracket, semicolon. Pointer to function. A function is stored in memory. The function name represents the base address of the function. This address can be stored in a function pointer. Syntax. Return underscore type, open parenthesis, asterisk function underscore pointer, close parenthesis, open parenthesis, parameter underscore list, close parenthesis, semicolon. Example. Int open parenthesis asterisk fp close parenthesis, open parenthesis float, char, close parenthesis, semicolon. Example, pointer to function. Hash include, less than iostream greater than. Using namespace std, semicolon. Int addition, open parenthesis, int a, int b, close parenthesis. Open curly brace. Return open parenthesis a plus b close parenthesis, semicolon. Close curly brace. Int subtraction, open parenthesis, int a, int b, close parenthesis. Open curly brace. Return open parenthesis a minus b close parenthesis, semicolon. Close curly brace. Int operation, open parenthesis, int x, comma, int y, comma, int open parenthesis asterisk func to call close parenthesis, open parenthesis int, comma, int, close parenthesis, close parenthesis. Open curly brace. Int g, semicolon. G equals open parenthesis asterisk func to call close parenthesis, open parenthesis x, comma, y, close parenthesis, semicolon. Return g, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int m, comma n, semicolon. Int open parenthesis asterisk minus close parenthesis, open parenthesis int, comma, int, close parenthesis, equals subtraction, semicolon. M equals operation, open parenthesis 7, comma, 5, comma, addition, close parenthesis, semicolon. N equals operation, open parenthesis 20, comma, m, comma, minus, close parenthesis, semicolon. Count less than n, semicolon. Return 0, semicolon. Close curly brace. In this example, minus is a function pointer that points to the subtraction function. Example. Program to demonstrate a function pointer. Int add, open parenthesis, int, comma, int, close parenthesis, semicolon. Int sub, open parenthesis, int, comma, int, close parenthesis, semicolon. Void main, open parenthesis, close parenthesis. Open curly brace. Int open parenthesis asterisk fp close parenthesis, open parenthesis int, comma, int, close parenthesis, semicolon. Fp equals add, semicolon. Printf, open parenthesis, double quote, backslash n4 plus 5 equals percentage d, double quote, comma, fp, open parenthesis, 4, comma, 5, close parenthesis, semicolon. Fp equals sub, semicolon. Printf, open parenthesis, double quote, backslash n4 minus 5 equals percentage d, double quote, comma, fp, open parenthesis, 4, comma, 5, close parenthesis, semicolon. Close curly brace. Int add, open parenthesis, int x, comma, int y, close parenthesis. Open curly brace. Return x plus y, semicolon. Close curly brace. Int sub, open parenthesis, int x, comma, int y, close parenthesis. Open curly brace. Return x minus y, semicolon. Close curly brace. Output. 4 plus 5 equals 9. 4 minus 5 equals minus 1. Pointer to structure. A pointer to a structure is mainly used to pass a structure to a function using call by reference. Another important use is in creating linked lists and other dynamic data structures. Consider the declaration. Struct employee. Open curly brace. Char name, open square bracket 20 close square bracket, semicolon. Int age, semicolon. Float salary, semicolon. Close curly brace, semicolon. Struct employee asterisk p, semicolon. Structure members can be accessed using either dot operator, arrow operator. Examples. Open parenthesis asterisk p close parenthesis dot age equals 20, semicolon. Or p arrow age equals 20, semicolon. Similarly, open parenthesis asterisk p close parenthesis dot salary equals 40,231.0, semicolon. Or p arrow salary equals 40,231.0, semicolon. Dynamic memory management. Memory can be allocated in two ways. Static memory allocation. Dynamic memory allocation. Static memory allocation requires memory size to be specified during program writing and cannot be changed during execution. Dynamic memory allocation uses predefined library functions to allocate and deallocate memory during program execution. Dynamically allocated memory is accessed only through pointers. Memory allocation functions. Static memory allocation uses stack memory. Dynamic memory allocation uses heap memory. The following memory management functions are available in alloc.h and stdlib.h. 1. Malloc, block memory allocation. Malloc allocates a block of memory of the specified size. It returns a pointer to the first byte of the allocated memory. The allocated memory is not initialized. If allocation fails, it returns null. Declaration. Void asterisk malloc, open parenthesis, size underscore t size, close parenthesis, semicolon. Syntax. Pointer equals open parenthesis, type asterisk, close parenthesis malloc, open parenthesis, size, close parenthesis, semicolon. 2. Calloc, contiguous memory allocation. Calloc is mainly used to allocate memory for arrays. It initializes all allocated memory with null characters or 0. Declaration. Void asterisk calloc, open parenthesis, size underscore t element underscore count, comma, size underscore t element underscore size, close parenthesis, semicolon. Syntax. PTR equals open parenthesis, type asterisk, close parenthesis calloc, open parenthesis, element underscore count, comma, element underscore size, close parenthesis, semicolon. 3. Realloc, reallocation of memory. Realloc changes the size of a previously allocated memory block. If the memory block cannot be extended in its current location, a new block is allocated, the old contents are copied, and the old block is released. Declaration. Void asterisk realloc, open parenthesis, void asterisk PTR, comma, size underscore t new underscore size, close parenthesis, semicolon. Syntax. PTR equals open parenthesis, type asterisk, close parenthesis realloc, open parenthesis, PTR, comma, new underscore size, close parenthesis, semicolon. 4. Free, releasing memory. Memory allocated using malloc, calloc, or realloc should be released using free when it is no longer needed. Declaration. Void free, open parenthesis, void asterisk PTR, close parenthesis, semicolon. Syntax. Free, open parenthesis, PTR, close parenthesis, semicolon. The free function releases the entire memory block referenced by the pointer. A part of the memory block cannot be deallocated separately. Structures. Arrays are useful for storing many values of the same data type. When data items of different data types need to be grouped together, we use a structure. A structure is a method of combining data of different types. A structure provides a convenient way to handle a group of related data items of different data types. Syntax for structure declaration. Struct structure underscore name. Open curly brace. Data underscore type underscore 1, variable 1, semicolon. Data underscore type underscore 2, variable 2, semicolon. ... Data underscore type underscore n, variable n, semicolon. Close curly brace, semicolon. Example. Struct lib underscore books. Open curly brace. Char title, open square bracket 20 close square bracket, semicolon. Char author. Open square bracket 15 close square bracket, semicolon. Int pages, semicolon. Float price, semicolon. Close curly brace, semicolon. The keyword struct declares a structure named lib underscore books. It contains 4 members. Title, author, pages, price, declaring structure variables. Example. Struct lib underscore books book 1, comma, book 2, comma, book 3, semicolon. This declaration creates 3 structure variables. Book 1, book 2, book 3. Each contains the 4 members of lib underscore books. Memory map of book 1. Title occupies 20 bytes. Author occupies 15 bytes. Pages occupies 2 bytes. Price occupies 4 bytes. Notes. Memory is not allocated when a structure is declared. Memory is allocated only when a structure variable is created. Accessing structure members. Members are accessed using the dot operator. Example. Book1.author. Syntax. Structure underscore variable dot member underscore name, semicolon. Structures can also be initialized during declaration. Example. Struct lib underscore books book 4 equals open curly brace double quote, let us see double quote, comma double quote Yashwant double quote, comma 450, comma 200.95 close curly brace, semicolon. Note. Values must be supplied in the same order as the members are declared. One structure variable can be assigned to another structure variable. Structure variables cannot be compared. Example program. Hash include, less than stdio.h, greater than. Void main, open parenthesis, close parenthesis. Open curly brace. Struct student. Open curly brace. Int id underscore no, semicolon. Char name, open square bracket 20 close square bracket, semicolon. Char address, open square bracket 20 close square bracket, semicolon. Char combination, open square bracket 3 close square bracket, semicolon. Int age, semicolon. Close curly brace, new student, semicolon. Printf, open parenthesis, double quote enter student information double quote, close parenthesis, semicolon. Printf, open parenthesis, double quote enter student id underscore no double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote percentage d double quote, comma, ampersand new student dot id underscore no, close parenthesis, semicolon. Printf, open parenthesis, double quote enter the name of the student double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote percentage s double quote, comma, new student dot name, close parenthesis, semicolon. Printf, open parenthesis, double quote enter the address of the student double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote percentage s double quote, comma, new student dot address, close parenthesis, semicolon. Printf, open parenthesis, double quote enter the combination of the student double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote percentage s double quote, comma, new student dot combination, close parenthesis, semicolon. Printf, open parenthesis, double quote enter the age of student double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote percentage d double quote, comma, ampersand new student dot age, close parenthesis, semicolon. Printf, open parenthesis, double quote student information double quote, close parenthesis, semicolon. Printf, open parenthesis, double quote student id underscore no equals percentage d double quote, comma, new student dot id underscore no, close parenthesis, semicolon. Printf, open parenthesis, double quote student name equals percentage s double quote, comma, new student dot name, close parenthesis, semicolon. Printf, open parenthesis, double quote student address equals percentage s double quote, comma, new student dot address, close parenthesis, semicolon. Printf, open parenthesis, double quote student combination equals percentage s double quote, comma, new student dot combination, close parenthesis, semicolon. Printf, open parenthesis, double quote age of student equals percentage d double quote, comma, new student dot age, close parenthesis, semicolon. Close curly brace. Nesting of structures. Structures can be nested in two ways. A structure variable can be a member of another structure. An entire structure can be declared inside another structure. Example. Struct date. Open curly brace. Int day, semicolon. Int month, semicolon. Int year, semicolon. Close curly brace, semicolon. Struct student, open curly brace. Int id underscore no, semicolon. Char name, open square bracket 20 close square bracket, semicolon. Char address, open square bracket 20 close square bracket, semicolon. Int age, semicolon. Struct date DOA, semicolon. Close curly brace, old student, comma, new student, semicolon. The structure student contains another structure date as one of its members. To access the day of the date of admission, write oldstudent.doa.day. Example. Struct outer, open curly brace. Int 01, semicolon. Float 02, semicolon. Struct inner, open curly brace. Int I1, semicolon. Float I2, semicolon. Close curly brace, semicolon. Close curly brace, out 1, comma, out 2, semicolon. The innermost members of a nested structure can be accessed by chaining the structure variables from the outermost level to the innermost level. Example. To access I1 of out1, write out1.inner.I1. Array of structures. An array of structures can be declared just like an array of any other data type. For example, if information about 100 students is to be stored, using an array of structures is more convenient than declaring 100 separate variables. Example. Structure information. Open curly brace. Int id underscore no, semicolon. Char name, open square bracket 20 close square bracket, semicolon. Char address, open square bracket 20 close square bracket, semicolon. Char combination, open square bracket 3 close square bracket, semicolon. Int age, semicolon. Close curly brace. Student, open square bracket 100 close square bracket, semicolon. Example program. Hash include, less than stdio.h, greater than. Struct info. Open curly brace. Int id underscore no, semicolon. Char name, open square bracket 20 close square bracket, semicolon. Char address, open square bracket 20 close square bracket, semicolon. Char combination, open square bracket 3 close square bracket, semicolon. Int age, semicolon. Close curly brace, semicolon. Struct info std, open square bracket 100 close square bracket, semicolon. Int I, comma n, semicolon. Printf, open parenthesis, double quote, enter the number of students, double quote, close parenthesis, semicolon. Scanf, open parenthesis, double quote, percentage %d, double quote, comma, ampersand n, close parenthesis, semicolon. Printf, open parenthesis, double quote, enter id number, name, address, combination, and age, double quote, close parenthesis, semicolon. For open parenthesis, I equals 0, semicolon, I less than n, semicolon, I plus plus, close parenthesis. Scanf, open parenthesis, double quote, percentage %d, percentage %s, percentage %s, percentage %s, percentage %d, double quote, comma, ampersand std open square bracket I close square bracket dot id underscore no, comma, std open square bracket I close square bracket dot name, comma, std open square bracket I close square bracket dot address, comma, std open square bracket I close square bracket dot combination, comma. Ampersand std open square bracket I close square bracket dot age, close parenthesis, semicolon. Printf, open parenthesis, double quote, student information, double quote, close parenthesis, semicolon. For open parenthesis, I equals 0, semicolon, I less than n, semicolon, I plus plus, close parenthesis. Printf, open parenthesis, double quote, percentage %d, percentage %s, percentage %s, percentage %s, percentage %d, double quote, comma, std open square bracket I close square bracket dot id underscore no, comma, std open square bracket I close square bracket dot name, comma, std open square bracket I close square bracket dot address, comma, std open square bracket I close square bracket dot combination, comma. std open square bracket I close square bracket dot age, close parenthesis, semicolon. Structures and functions. A complete structure can be passed to a function just like any other variable. A function can also return a structure variable. Example: hash include less than stdio.h greater than. Struct employee. Open curly brace. Int emp underscore id, semicolon. Char name, open square bracket 25 close square bracket, semicolon. Char department, open square bracket 10 close square bracket, semicolon. Float salary, semicolon. Close curly brace, semicolon. Void main, open parenthesis, close parenthesis. Open curly brace. Static struct employee emp1 equals open curly brace, 12, comma, double quote Shyam double quote. Comma, double quote computer double quote, comma, 7500.0, close curly brace, semicolon. Display, open parenthesis, emp1, close parenthesis, semicolon. Close curly brace. Display, open parenthesis, emp, close parenthesis. Struct employee emp, semicolon. Open curly brace. Printf, open parenthesis, double quote, %d, %s, %f, double quote, comma, emp underscore id, comma, emp.name, comma, emp.department, comma, emp.salary, close parenthesis, semicolon. Close curly brace. Union. A union is similar to a structure, but with one important difference. In a structure, every member has its own memory. In a union, all members share the same memory location. Therefore, only one member can store a value at a time. Unions help conserve memory. Declaration. Union item. Open curly brace. Int m, semicolon. Float p, semicolon. Char c, semicolon. Close curly brace, code, semicolon. This declaration creates a union variable named code. The union contains 3 members: m of type int, p of type float, c of type char. Although the union contains multiple members, only one member is active at any given time. Members are accessed using the dot operator. Examples: code.m, code.p, code.c. All of these are valid member references. When accessing a union, ensure that you read the member that currently contains the stored value. Example: union marks. Open curly brace. Float perk, semicolon. Char grade, semicolon. Close curly brace. Main, open parenthesis, close parenthesis. Open curly brace. Union marks student 1, semicolon. Student1.perk equals 98.5, semicolon. Printf, open parenthesis, double quote, marks are %f, address is %16u, double quote, comma, student1.perk, comma, ampersand student1.perk, close parenthesis, semicolon. Student1.grade equals single quote c single quote, semicolon. Printf, open parenthesis, double quote, grade is %c, address is %16u, double quote, comma, student1.grade, comma, ampersand student1.grade, close parenthesis, semicolon. Close curly brace. Since all members of a union share the same memory, both perk and grade have the same memory address. Example: hash include less than stdio.h greater than. Void main, open parenthesis, close parenthesis. Open curly brace. Union u underscore example. Open curly brace. Float dicval, semicolon. Int pnum, semicolon. Double my underscore value, semicolon. Close curly brace, u1, semicolon. u1 dot my underscore value equals 125.5, semicolon. u1 dot pnum equals 10, semicolon. u1 dot dicval equals 1000.5f, semicolon. Printf, open parenthesis, double quote, dicval equals %f, pnum equals %d, my underscore value equals %lf, double quote, comma, u1.dicval, u1.penum, u1.my_value, close parenthesis, semicolon. Printf, open parenthesis, double quote, u1 size equals %d, dicval size equals %d, penum size equals %d, my_value size equals %d, double quote, comma, sizeof open parenthesis u1 close parenthesis, comma, sizeof open parenthesis u1.dicval close parenthesis, comma, sizeof open parenthesis u1.penum close parenthesis, comma, sizeof open parenthesis u1.my_value close parenthesis, semicolon. Close curly brace. Bit fields. Normally, when a variable is declared as an int, it occupies the full integer size. If the variable stores only 0 and 1, then only one bit is actually required, while the remaining bits are wasted. To avoid this wastage, bit fields are used. Bit fields allow several variables with small ranges of values to be packed into a single memory location, improving memory efficiency. Example: struct student, open curly brace, int gender :1, semicolon. Gender can store only 0 or 1. Int marriage :2, semicolon. Marriage uses 2 bits, so it can store 4 values: 0, 1, 2, and 3. Int marks :7, semicolon. Marks use 7 bits, so they can store values from 0 to 127. Close curly brace, semicolon. Exercises. Practice problems 1. Directions. For questions 1 to 15, select the correct alternative. Question 1. Program. Int f, open parenthesis, int x, comma, int asterisk pi, comma, int asterisk asterisk pz, close parenthesis. Open curly brace. Int y, comma z, semicolon. Asterisk asterisk pz plus equals 1, semicolon. Z equals asterisk pz, semicolon. Asterisk pi plus equals 2, semicolon. Y equals asterisk pi, semicolon. X plus equals 3, semicolon. Return plus y plus z, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Int c, comma, asterisk b, comma, asterisk asterisk a, semicolon. C equals 4, semicolon. B equals ampersand c, semicolon. A equals ampersand b, semicolon. Printf, open parenthesis, double quote %d double quote, comma, f open parenthesis c, comma, b, comma, a close parenthesis, semicolon. Close curly brace. Options: A 30, B 22, C 20, D error. Question 2. Program. Main, open parenthesis, close parenthesis. Open curly brace. Char asterisk ptr, semicolon. Ptr equals double quote hello world double quote, semicolon. Printf, open parenthesis, double quote %c backslash n double quote, comma, asterisk ampersand asterisk ptr, close parenthesis, semicolon. Close curly brace. Output of the above program is A. Garbage value, B. Error, C. A. D. Hello world. Question 3. Program. Hash include, less than stdio.h, greater than. Main, open parenthesis, close parenthesis. Open curly brace. Register a equals 10, semicolon. Char b, open square bracket, close square bracket, equals double quote high double quote, semicolon. Printf, open parenthesis, double quote %s, space, %d, space, double quote, comma, b, comma, a close parenthesis, semicolon. Close curly brace. Output is A. High 10, B. Error, C. High, D. High garbage value. Question 4. Program. Main, open parenthesis, close parenthesis. Open curly brace. int fun, open parenthesis, close parenthesis, semicolon. Open parenthesis, asterisk fun, close parenthesis, open parenthesis, close parenthesis, semicolon. Close curly brace. Int fun, open parenthesis, close parenthesis. Open curly brace. Printf, open parenthesis, double quote hello double quote, close parenthesis, semicolon. Close curly brace. Options. A. Hello. B. Error. C. No output. D. A. Question 5. Let B be a two-dimensional array declared as B. Array, open square bracket 1.10 close square bracket, open square bracket 11.15 close square bracket, of integer. Assume that each integer occupies one memory location. The array is stored in row major order. The first element is stored at address 100. What is the address of B open square bracket, I close square bracket, open square bracket, J close square bracket? Options. A. 15, I plus 10, plus J plus 84. B. 15I plus J minus 16. C. 15I plus J. D. 15IJ plus 84. Question 6. Consider the following C program, which is supposed to compute the transpose of a given 4 times 4 matrix M. There is a Y in the program that represents some missing statements. Choose the correct option to replace Y. Program. Hash include less than stdio.h greater than. Int M open square bracket 4 close square bracket open square bracket 4 close square bracket equals open curly brace 8, comma 10, comma 9, comma 16 close curly brace, comma open curly brace 12, comma 13, comma 11, comma 15 close curly brace, comma open curly brace 14, comma 7, comma 6, comma 3 close curly brace, comma open curly brace 4, comma 2, comma 1, comma 5 close curly brace, semicolon. Main, open parenthesis, close parenthesis. Open curly brace. Int I, comma J, comma temp, semicolon. For open parenthesis, I equals 0, semicolon, I less than 4, semicolon, plus I, close parenthesis. Open curly brace. Y. Close curly brace. For open parenthesis, I equals 0, semicolon, I less than 4, semicolon, plus I, close parenthesis. For open parenthesis, J equals 0, semicolon, J less than 4, semicolon, plus J, close parenthesis. Printf, open parenthesis, double quote percentage D backslash T double quote, comma, M open square bracket I close square bracket open square bracket J close square bracket, close parenthesis, semicolon. Close curly brace. Options. A. For open parenthesis, J equals 0, semicolon, J less than 4, semicolon, plus J, close parenthesis. Open curly brace. M open square bracket, J close square bracket, open square bracket, I close square bracket equals temp, semicolon. Temp equals M open square bracket, I close square bracket, open square bracket J close square bracket, semicolon. M open square bracket, I close square bracket, open square bracket J close square bracket, equals M open square bracket J close square bracket, open square bracket, I close square bracket, semicolon. Close curly brace. B. For open parenthesis, J equals 0, semicolon, J less than 4, semicolon, plus J, close parenthesis. Open curly brace. Temp equals M open square bracket, I close square bracket, open square bracket J close square bracket, semicolon. M open square bracket, I close square bracket, open square bracket J close square bracket, equals M open square bracket J close square bracket, open square bracket, I close square bracket, semicolon. M open square bracket J close square bracket, open square bracket, I close square bracket equals temp, semicolon. Close curly brace. C. For open parenthesis, J equals I, semicolon, J less than 4, semicolon, plus j, close parenthesis. Open curly brace. Temp equals m, open square bracket, I close square bracket, open square bracket, j close square bracket, semicolon. M open square bracket, I close square bracket, open square bracket, j close square bracket, equals m open square bracket, j close square bracket, open square bracket, I close square bracket, semicolon. M open square bracket, j close square bracket, open square bracket, I close square bracket, equals temp, semicolon. Close curly brace. D. For open parenthesis, j equals I, semicolon, j less than 4, semicolon, plus j, close parenthesis. Open curly brace. M open square bracket, I close square bracket, open square bracket, j close square bracket, equals temp, semicolon. Temp equals m open square bracket, j close square bracket, open square bracket, I close square bracket, semicolon. M open square bracket, j close square bracket, open square bracket, I close square bracket, equals m open square bracket, I close square bracket, open square bracket, j close square bracket, semicolon. Close curly brace. Question 7. Program. Hash include, less than stdio.h, greater than. Hash define print, open parenthesis, a close parenthesis, printf, open parenthesis, double quote percentage d double quote, comma, a close parenthesis. Int a semicolon. Void z, open parenthesis, int n, close parenthesis. Open curly brace. N equals n plus, a semicolon. Print, open parenthesis, n, close parenthesis, semicolon. Close curly brace. Void x, open parenthesis, int asterisk p, close parenthesis. Open curly brace. Int a equals asterisk p plus 2, semicolon. Z, open parenthesis, a close parenthesis, semicolon. Asterisk p equals a semicolon. Print, open parenthesis, a close parenthesis, semicolon. Close curly brace. Main, open parenthesis, void, close parenthesis. Open curly brace. A equals 6, semicolon. X, open parenthesis, ampersand, a close parenthesis, semicolon. Print, open parenthesis, a close parenthesis, semicolon. Close curly brace. Output of this program is A. 1486, B. 1666, C. 866, D. 221112. Question 8. Program. Hash include, less than stdio.h, greater than. Int fun, open parenthesis, int n, comma, int asterisk p, close parenthesis. Open curly brace. Int x, comma y, semicolon. If open parenthesis, n less than or equal to 1, close parenthesis. Open curly brace. Asterisk p equals 1, semicolon. Return 1, semicolon. Close curly brace. X equals fun, open parenthesis, n minus 1, comma, p, close parenthesis, semicolon. Y equals x plus asterisk p, semicolon. Asterisk p equals x, semicolon. Return y, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int a equals 15, semicolon. Print open parenthesis, double quote percentage d backslash and double quote, comma, fun, open parenthesis, 5, comma, ampersand a close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The output value is A. 14, B. 15, C. 8, D. 95. Question 9. Program. Char p, open square bracket 20 close square bracket, semicolon. Int I, semicolon. Char asterisk s equals double quote string double quote, semicolon. Int L equals strlen, open parenthesis s, close parenthesis, semicolon. For open parenthesis, I equals 0, semicolon, I less than L, semicolon, I plus plus, close parenthesis. P open square bracket I close square bracket equals S open square bracket L minus I close square bracket, semicolon. Print open parenthesis, double quote percentage S double quote, comma, P, close parenthesis, semicolon. The output of the program is A string, B nert, C nerts, D no output is printed. Question 10. Program. Hash include, less than stdio.h, greater than. Main, open parenthesis, close parenthesis. Open curly brace. Struct A. Open curly brace. Int A equals 5, semicolon. Char name, open square bracket, close square bracket, equals double quote ANU double quote, semicolon. Close curly brace, semicolon. Struct A asterisk P equals malloc, open parenthesis, sizeof, open parenthesis, struct A, close parenthesis, semicolon. Print open parenthesis, double quote percentage D double quote, comma, P arrow A, close parenthesis, semicolon. Print open parenthesis, double quote percentage S double quote, comma, P arrow name, close parenthesis, semicolon. Close curly brace. Output of the program is A. 5 ANU, B. Runtime error, C. Compiler error, D. Linker error. Question 11. The declaration. Union U underscore tag. Open curly brace. Int I value, semicolon. Float F value, semicolon. Char S value, semicolon. Close curly brace U, semicolon. Denotes U as a variable of type U underscore tag. A. U can have a value of int, float, and char simultaneously. B. U can represent either an integer value, float value, or character value at a time. C. U can have a value of float but not integer. D. None of the above. Question 12. If the following program is run from the command line as miprog123, what would be the output? Program. Main open parenthesis, int arg, comma, char asterisk arg, open square bracket, close parenthesis. Open curly brace. Int I, semicolon. I equals argv open square bracket 1 close square bracket, plus argv open square bracket 2 close square bracket, minus argv open square bracket 3 close square bracket, semicolon. Print open parenthesis, double quote percentage D double quote, comma, I, close parenthesis, semicolon. Close curly brace. Options. A. 123. B. 6. C. 0. D. Error. Question 13. The following C program is run from the command line as miprog12. What will be the output? Program. Main open parenthesis, int arg, comma, char asterisk arg, open square bracket, close parenthesis. Open curly brace. Print open parenthesis, double quote percentage C double quote, comma, asterisk plus arg, close parenthesis, semicolon. Close curly brace. Options. A. M. B. O. C. miprog. D. 1. Question 14. Program. Change, open parenthesis, int asterisk, close parenthesis, semicolon. Main, open parenthesis, close parenthesis. Open curly brace. Int equals 4, semicolon. Change, open parenthesis, a close parenthesis, semicolon. Print, open parenthesis, double quote percentage D double quote, comma, a close parenthesis, semicolon. Close curly brace. Change, open parenthesis, a close parenthesis. Int a semicolon. Open curly brace. Print open parenthesis, double quote percentage D double quote, comma, a close parenthesis, semicolon. Close curly brace. Outputs. A. 44. B. 55. C. 34. D. 22. Question 15. Program. Main, open parenthesis, close parenthesis. Open curly brace. Const int equals 10, semicolon. Int asterisk ptrx, semicolon. ptr equals ampersand x, semicolon. Asterisk ptr equals 20, semicolon. Printf, open parenthesis, double quote percentage d double quote, comma, x, close parenthesis, semicolon. Close curly brace. Output. A5. B10. C error. D20. Practice problems 2. Directions. For questions 1 to 11, select the correct alternative. Question 1. The following program segment. Int asterisk I, semicolon. Asterisk I equals 10, semicolon. Options. A. Results in runtime error. B. Is a dangling reference. C. Results in compilation error. D. Assigns 10 to I. Question 2. An M times N matrix is stored in column major order. Which expression accesses the I, J element of the matrix? Options. A. N times J minus 1 plus I. B. M times J minus 1 plus I. C. N times M minus 1 plus I. D. M times N minus 1 plus J. Question 3. If asterisk S is a one-dimensional array of integers, which of the following refers to the third element? Options. A. Asterisk open parenthesis S plus 2 close parenthesis. B. Asterisk open parenthesis S plus 3 close parenthesis. C. S plus 2. D. S plus 3. Question 4. If an array is declared as chara, open square bracket 10 close square bracket, open square bracket 12 close square bracket, semicolon. What does a open square bracket 5 close square bracket refer to? Options. A. Pointer to third row. B. Pointer to fourth row. C. Pointer to fifth row. D. Pointer to sixth row. Question 5. The following code is run from the command line as miprog123. Program. Main open parenthesis, int arg, comma, char asterisk argv, open square bracket close parenthesis. Open curly brace. Int I, comma, j equals 0, semicolon. For open parenthesis, I equals 1, semicolon, I less than arg, semicolon, I plus plus, close parenthesis. J equals j plus add I, open parenthesis argv open square bracket I close square bracket, close parenthesis, semicolon. Printf open parenthesis, double quote percentage d double quote, comma, j, close parenthesis, semicolon. Close curly brace. Options. A. 123. B. 6. C. Error. D. 123. Question 6. What will the following C program output? Program. Main open parenthesis, int arg, comma, char asterisk argv, open square bracket close square bracket, comma, char asterisk env, open square bracket close parenthesis. Open curly brace. Int I, semicolon. For open parenthesis, I equals 1, semicolon, I less than arg, semicolon, I plus plus, close parenthesis. Printf open parenthesis, double quote percentage S double quote, comma, env open square bracket I close square bracket, close parenthesis, semicolon. Close curly brace. Options. A. List of all arguments. B. List of all path parameters. C. Error. D. List of environment variables. Question 7. The declaration. Enum colors. Open curly brace. Red. Blue. Yellow equals 1. Green. Close curly brace, semicolon. Assigns the value 1 to A. Red and yellow. B. Blue. C. Red and blue. D. Blue and yellow. Question 8. What will be the output of the following program? Program. Sum equals 0, semicolon. For open parenthesis, I equals -10, semicolon, I less than 0, semicolon, I plus plus, close parenthesis. Sum equals sum plus abs, open parenthesis I close parenthesis, semicolon. Printf, open parenthesis, double quote percentage d double quote, comma, sum, close parenthesis, semicolon. Options. A, 100. B, -505. C, 55. D, -55. Question 9. An integer occupies 2 bytes, a float occupies 4 bytes, and a character occupies 1 byte. A structure is defined as struct tab, open curly brace, char semicolon, int b, semicolon, float c, semicolon, close curly brace table, open square bracket 10 close square bracket, semicolon. The total memory requirement, in bytes, is A, 14, B, 70, C, 40, D, 100. Question 10. What are the values of U1 and U2? Program. Int U1, comma U2, semicolon. Int equals 2, semicolon. Int asterisk PTR, semicolon. U1 equals 2 times open parenthesis x plus 10 close parenthesis, semicolon. PTR equals ampersand x, semicolon. U2 equals 2 times open parenthesis asterisk PTR plus 10 close parenthesis, semicolon. Options. A, U1 equals 8, U2, 16. B, U1 equals 23, U2 equals 24. C, U1 equals 24, U2 equals 24. D, none of the above. Question 11. What is the output? Program. Func, open parenthesis, a comma, b, close parenthesis. Int a, comma, b, semicolon. Open curly brace. Return, open parenthesis, a equals open parenthesis, a equals b close parenthesis, semicolon. Close curly brace. Main, open parenthesis, close parenthesis. Open curly brace. Int process, open parenthesis, close parenthesis, comma, func, open parenthesis, close parenthesis, semicolon. Print, open parenthesis, double quote the value of process is percentage d double quote, comma, process, open parenthesis, func, comma, 3, comma, 6, close parenthesis, semicolon. Close curly brace. Process, open parenthesis, pf, comma, val1, comma, val2, close parenthesis. Int open parenthesis asterisk pf close parenthesis, open parenthesis, close parenthesis, semicolon. Int val1, comma, val2, semicolon. Open curly brace. Return, open parenthesis asterisk pf close parenthesis, open parenthesis val1, comma, val2, close parenthesis, semicolon. Close curly brace. Options. A, the value of process is 0. B, the value of process is 3. C, the value of process is 6. D, logical error. Previous year's questions. Question 1, 2014. Consider the following C program. Hash include, less than stdio.h, greater than. Main, open parenthesis, close parenthesis. Open curly brace. Int I, semicolon. Int asterisk pi equals ampersand I, semicolon. Scanf, open parenthesis, double quote percentage d double quote, comma, pi, close parenthesis, semicolon. Printf, open parenthesis, double quote percentage d backslash n double quote, comma, I plus 5, close parenthesis, semicolon. Close curly brace. Which one of the following statements is true? A, compilation fails. B, execution results in a runtime error. C, on execution, the value printed is 5 more than the address of variable I. D, on execution, the value printed is 5 more than the integer value entered. Question 2, 2014. Consider the following C function, where size is the number of elements in the array E. Program int myx, open parenthesis, int asterisk E, comma, unsigned int size, close parenthesis. Open curly brace. Int y equals 0, semicolon. Int z, semicolon. Int I, comma j, comma k, semicolon. For open parenthesis, I equals 0, semicolon, I less than size, semicolon, I plus plus, close parenthesis. Y equals y plus e open square bracket, I close square bracket, semicolon. For open parenthesis, I equals 0, semicolon, I less than size, semicolon, I plus plus, close parenthesis. For open parenthesis, j equals 1, semicolon, j less than size, semicolon, j plus plus, close parenthesis. Open curly brace. Z equals 0, semicolon. For open parenthesis, k equals I, semicolon, k less than or equal to j, semicolon, k plus plus, close parenthesis. Z equals z plus e open square bracket, k close square bracket, semicolon. If, open parenthesis, z greater than y, close parenthesis. Y equals z, semicolon. Close curly brace. Return y, semicolon. Close curly brace. The value returned by myx is A. Maximum possible sum of elements in any subarray of array E. B. Maximum element in any subarray of array E. C. Sum of the maximum elements in all possible subarrays of array E. D. Sum of all the elements in array E. Question 3, 2015. The output of the following C program is program void F1, open parenthesis, int I, comma, int B, close parenthesis. Open curly brace. Int C, semicolon. C equals a, semicolon. A equals B, semicolon. B equals C, semicolon. Close curly brace. Void F2, open parenthesis, int asterisk a, comma, int asterisk B, close parenthesis. Open curly brace. Int C, semicolon. C equals asterisk a, semicolon. Asterisk a equals asterisk B, semicolon. Asterisk B equals C, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int A equals 4, comma, B equals 5, comma, C equals 6, semicolon. F1, open parenthesis, a comma, B, close parenthesis, semicolon. F2, open parenthesis, ampersand B, comma, ampersand C, close parenthesis, semicolon. Printf, open parenthesis, double quote percentage D double quote, comma, C minus A minus B, close parenthesis, semicolon. Close curly brace. Question 4, 2015. What is the output of the following C code? Assume the address of X is 2000, decimal. An integer occupies 4 bytes. Program int main, open parenthesis, close parenthesis. Open curly brace. Unsigned int X, open square bracket 4 close square bracket, open square bracket 3 close square bracket, equals. Open curly brace. Open curly brace 1, comma 2, comma 3 close curly brace. Open curly brace 4, comma 5, comma 6 close curly brace. Open curly brace 7, comma 8, comma 9 close curly brace. Open curly brace 10, comma 11, comma 12 close curly brace. Close curly brace, semicolon. Printf, open parenthesis, double quote percentage U, double quote, comma. X plus 3. Asterisk open parenthesis X plus 3 close parenthesis. Asterisk open parenthesis X plus 2 close parenthesis plus 3. Close parenthesis, semicolon. Close curly brace. Options. A. 2036, 2036, 2036. B. 2012, 4, 2204. C. 2036, 10, 10. D. 2012, 4, 6. Question 5, 2015. Consider the following function, written in the C programming language. Program. Void foo, open parenthesis, chara asterisk, a close parenthesis. Open curly brace. If, open parenthesis, asterisk a ampersand asterisk a not equal to \0, close parenthesis. Open curly brace. Foo, open parenthesis, a +1, close parenthesis, semicolon. Puchar, open parenthesis, asterisk a close parenthesis, semicolon. Close curly brace. Close curly brace. The output of the above function on input A, B, C, D, E, F, G, H is A, B, C, D, E, F, G, H, B, A, B, C, D, C, H, G, F, E, D, C, B, A, D, D, C, B, A. Question 6, 2015. Consider the following C program segment. Hash include, less than stdio.h, greater than. Int main, open parenthesis, close parenthesis. Open curly brace. Char S1, open square bracket 7 close square bracket, equals double quote 1 2 3 4 double quote, comma, asterisk P, semicolon. P equals S1 plus 2, semicolon. Asterisk P equals \0, semicolon. Printf, open parenthesis, double quote percentage S double quote, comma, S1, close parenthesis, semicolon. What will be printed by the program? A, 12. B, 120,400. C, 1204. D, 1034. Question 7, 2015. Program. Hash include, less than stdio.h, greater than. Int main, open parenthesis, close parenthesis. Open curly brace. Static int a, open square bracket, close square bracket, equals open curly brace 10, 20, 30, 40, 50 close curly brace, semicolon. Static int asterisk P, open square bracket, close square bracket, equals open curly brace a, +3, a +4, a +1, a +2 close curly brace, semicolon. Int asterisk PTR equals P, semicolon. PTR++, semicolon. Printf, open parenthesis, double quote percentage D double quote, comma, PTR minus P, comma, asterisk PTR, close parenthesis, semicolon. Close curly brace. Question 8, 2016. Consider the following C program. Program. Void F, open parenthesis, int, comma, short, close parenthesis, semicolon. Void main, open parenthesis, close parenthesis. Open curly brace. Int I equals 100, semicolon. Short S equals 12, semicolon. Short asterisk P equals ampersand S, semicolon. Blank semicolon, called a function F. Close curly brace. Which of the following expressions, when placed in the blank, will not result in a type checking error? A, F, open parenthesis S, comma, asterisk S, close parenthesis. B, I equals F, open parenthesis I, comma, S, close parenthesis. C, F, open parenthesis I, comma, asterisk S, close parenthesis. D, F, open parenthesis I, comma, asterisk P, close parenthesis. Question 9, 2016. Program. Hash include, less than stdio.h, greater than. Void mystery, open parenthesis, int asterisk a, comma, int asterisk B, close parenthesis. Open curly brace. Int asterisk temp, semicolon. Temp equals B, semicolon. B equals a, semicolon. A equals temp, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int A equals 2016, comma, B equals 0, comma, C equals 4, comma, D equals 42, semicolon. Mystery, open parenthesis, ampersand a, comma, ampersand B, close parenthesis, semicolon. If, open parenthesis, a less than C, close parenthesis. Mystery, open parenthesis, ampersand C, comma, ampersand a, close parenthesis, semicolon. Mystery, open parenthesis, ampersand a, comma, ampersand D, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage D backslash N double quote, comma, a close parenthesis, semicolon. Close curly brace. The output of the program is Question 10, 2016. The following function computes the maximum value contained in an integer array P of size n, where is greater than or equal to 1. Program. Int max, open parenthesis, int asterisk P, comma, int n, close parenthesis. Open curly brace. Int a equals 0, comma, b equals n minus 1, semicolon. While, open parenthesis, blank, close parenthesis. Open curly brace. If, open parenthesis, P open square bracket a close square bracket less than or equal to P open square bracket B close square bracket, close parenthesis. Open curly brace. A equals a plus 1, semicolon. Close curly brace. Else. Open curly brace. B equals B minus 1, semicolon. Close curly brace. Close curly brace. Return P open square bracket a close square bracket, semicolon. Close curly brace. The missing loop condition is A not equal to n. B not equal to 0. C, B greater than open parenthesis a plus 1 close parenthesis. D, B not equal to a. Question 11, 2016. The value printed by the following program is Program. Void F, open parenthesis, int asterisk P, comma, int M, close parenthesis. Open curly brace. M equals M plus 5, semicolon. Asterisk P equals asterisk P plus M, semicolon. Return, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Int I equals 5, comma, J equals 10, semicolon. F, open parenthesis, ampersand I, comma, J, close parenthesis, semicolon. Printf, open parenthesis, double quote, percentage D double quote, comma, I plus J, close parenthesis, semicolon. Close curly brace. Question 12, 2016. Program. Int F, open parenthesis, int asterisk P, comma, int N, close parenthesis. Open curly brace. If, open parenthesis, n less than or equal to 1, close parenthesis. Return 0, semicolon. Else. Return max, open parenthesis, F, open parenthesis, P plus 1, comma, n minus 1, close parenthesis, comma, P open square bracket 0 close square bracket minus P open square bracket 1 close square bracket, close parenthesis, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int a open square bracket, close square bracket, equals open curly brace 3, comma, 5, comma, 2, comma, 6, comma, 4 close curly brace, semicolon. Printf, open parenthesis, double quote, percentage D double quote, comma, F, open parenthesis, a comma, 5, close parenthesis, semicolon. Close curly brace. Note, max x, y returns the maximum of x and y. The value printed by this program is Question 13, 2017. Consider the following C code. Program. Hash include, less than stdio.h, greater than. Int asterisk assignable, open parenthesis, int asterisk x, comma, int val, close parenthesis. Open curly brace. Asterisk equals val, semicolon. Return x, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Int asterisk x equals malloc, open parenthesis, sizeof, open parenthesis, int, close parenthesis, semicolon. If open parenthesis, null equals x, close parenthesis, return, semicolon. Equals assignable, open parenthesis, x, comma, 0, close parenthesis, semicolon. If open parenthesis, x, close parenthesis. Open curly brace. equals open parenthesis in asterisk close parenthesis malloc, open parenthesis, Sysioff, open parenthesis in close parenthesis, semicolon. If open parenthesis, null equals x, close parenthesis, return, semicolon. Equals assignable, open parenthesis, x, comma, 10, close parenthesis, semicolon. Close curly brace. Print, open parenthesis, double quote percentage d backslash n double quote, comma, asterisk x, close parenthesis, semicolon. Free, open parenthesis, x, close parenthesis, semicolon. Close curly brace. The code suffers from which one of the following problems? A. Compiler error, because the return value of malloc is not typecast appropriately. B. Compiler error, because the comparison should be equals null. C. Compiles successfully, but execution may result in a dangling pointer. D. Compiles successfully, but execution may result in a memory leak. Question 14, 2017. Consider the following program. Program. Hash include, less than stdio.h, greater than. Hash include, less than string.h, greater than. Void print length, open parenthesis, char asterisk s, comma, char asterisk t, close parenthesis. Open curly brace. Unsigned int c equals 0, semicolon. Int len equals open parenthesis str len, open parenthesis s, close parenthesis equals str len, open parenthesis t, close parenthesis question mark str len, open parenthesis s, close parenthesis colon str len, open parenthesis t, close parenthesis, semicolon. Print, open parenthesis, double quote percentage d backslash n double quote, comma, len, close parenthesis, semicolon. Close curly brace. Void main, open parenthesis, close parenthesis. Open curly brace. Char asterisk equals double quote ABC double quote, semicolon. Char asterisk y equals double quote def double quote, semicolon. Print length, open parenthesis, x, comma, y, close parenthesis, semicolon. Close curly brace. Recall that strlen is defined in string.h as returning a value of type size underscore t, which is an unsigned integer. The output of the program is Question 15, 2017. Given the following binary number in 32-bit single precision, format 00111100 110 110 1000000000000000000. The decimal value closest to this floating point number is A. 1.45 times 10 to the power 1. B. 1.45 times 10 to the power minus 1. C. 2.27 times 10 to the power minus 1. D. 2.27 times 10 to the power 1. Question 16, 2017. Match the following. Left column. P. Static char var. Q. M equals malloc, open parenthesis 10 close parenthesis, M equals null. R. Char asterisk PTR, open square bracket 10 close square bracket. S. Register int var. Right column. I. Sequence of memory locations to store addresses. Roman 2. A variable located in the data section of memory. Roman 3. Request to allocate a CPU register to store data. Roman 4. A lost memory block that cannot be freed. Options. A. P to Roman 2, Q to Roman 4, R to I, S to Roman 3. B. P to Roman 2, Q to I, R to Roman 4, S to Roman 3. C. P to Roman 3, Q to Roman 4, R to Roman 2, S to I. D. P to Roman 3, Q to Roman 4, R to I, S to Roman 2. Question 17, 2017. Consider the following function, implemented in C. Program. Void printc, open parenthesis, int x, comma, int y, close parenthesis. Open curly brace. Int asterisk ptr, semicolon. Equals 0, semicolon. PTR equals ampersand X, semicolon. Y equals asterisk PTR, semicolon. Asterisk PTR equals 1, semicolon. Printf, open parenthesis, double quote percentage D double quote, comma, X, comma, Y, close parenthesis, semicolon. Close curly brace. The output of invoking. Printxi, open parenthesis, 1, comma, 1, close parenthesis, is A0, 0, B0, 1, C1, 0, D1, 1. Question 18, 2017. Consider the following C program. Assume that swap, open parenthesis, ampersand X, comma, ampersand Y, close parenthesis, exchanges the contents of X and Y. Program. Int main, open parenthesis, close parenthesis, open curly brace. Int array, open square bracket, close square bracket, equals open curly brace 3, 5, 1, 4, 6, 2 close curly brace, semicolon. Int done equals 0, semicolon. Int I, semicolon. While open parenthesis, done equals 0, close parenthesis, open curly brace. Done equals 1, semicolon. For open parenthesis, I equals 0, semicolon, I less than or equal to 4, semicolon, I plus plus, close parenthesis, open curly brace. If open parenthesis, array open square bracket I close square bracket less than array open square bracket I plus 1 close square bracket, close parenthesis, open curly brace. Swap, open parenthesis, ampersand array open square bracket, I close square bracket, comma, ampersand array open square bracket I plus 1 close square bracket, close parenthesis, semicolon. Done equals 0, semicolon. Close curly brace. Close curly brace. For open parenthesis, I equals 5, semicolon, I greater than or equal to 1, semicolon, I minus minus, close parenthesis, open curly brace. If open parenthesis, array open square bracket I close square bracket greater than array open square bracket I minus 1 close square bracket, close parenthesis, open curly brace. Swap, open parenthesis, ampersand array open square bracket I close square bracket, comma, ampersand array open square bracket I minus 1 close square bracket, close parenthesis, semicolon. Done equals 0, semicolon. Close curly brace. Close curly brace. Close curly brace. Printf, open parenthesis, double quote percentage D double quote, comma, array open square bracket 3 close square bracket, close parenthesis, semicolon. The output of the program is Question 19, 2017. Consider the following C program. Program. Hash include, less than stdio.h, greater than. Hash include, less than string.h, greater than. Int main, open parenthesis, close parenthesis, open curly brace. Char asterisk C equals double quote, GATCSIT 2017 double quote, semicolon. Char asterisk P equals C, semicolon. Printf, open parenthesis, double quote percentage D double quote, comma, open parenthesis int close parenthesis strlen, open parenthesis C plus 2, open square bracket P close square bracket minus 6, open square bracket P close square bracket minus 1, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The output of the program is Question 20, 2018. Consider the following C program. Program. Hash include, less than stdio.h, greater than. Struct ernode. Open curly brace. Char x, y, z, semicolon. Close curly brace, semicolon. Int main, open parenthesis, close parenthesis, open curly brace. Struct ernode p equals open curly brace single quote 1, single quote, comma, backslash 0, comma, single quote a plus 2 single quote close curly brace, semicolon. Struct node asterisk q equals ampersand p, semicolon. Printf open parenthesis, double quote %c, comma, %c double quote, comma. Asterisk open parenthesis char asterisk close parenthesis, q, +1 close parenthesis. Comma. Asterisk open parenthesis char asterisk close parenthesis, q, +2 close parenthesis. Close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The output of this program is A0C. B0 a +2. C \0 a +2. D \0C. Question 21, 2018. Consider the following C program. Program. Hash include, less than stdio.h, greater than. Void fun1, open parenthesis, char asterisk s1, comma, char asterisk s2, close parenthesis. Open curly brace. Char asterisk tmp, semicolon. tmp equals s1, semicolon. s1 equals s2, semicolon. s2 equals tmp, semicolon. Close curly brace. Void fun2, open parenthesis, char double asterisk s1, comma, char double asterisk s2, close parenthesis. Open curly brace. Char asterisk tmp, semicolon. tmp equals asterisk s1, semicolon. Asterisk s1 equals asterisk s2, semicolon. Asterisk s2 equals tmp, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Char asterisk sdr1 equals double quote high double quote, comma, asterisk sdr2 equals double quote by double quote, semicolon. Fun1, open parenthesis, sdr1, comma, sdr2, close parenthesis, semicolon. Printf, open parenthesis, double quote %s space %s \n double quote, comma, sdr1, comma, sdr2, close parenthesis, semicolon. Fun2, open parenthesis, ampersand sdr1, comma, ampersand sdr2, close parenthesis, semicolon. Printf, open parenthesis, double quote %s space %s double quote, comma, sdr1, comma, sdr2, close parenthesis, semicolon. Return 0, semicolon. Close curly brace. The output of the program above is A, high by followed by high. B, high by followed by high by. C, by high followed by high by. D, by high followed by high. Chapter 4. Linked lists, stacks and queues. Data structure. Data structure represents the logical arrangement of data in computer memory for easily accessing and maintenance. Linked list. A linked list is a data structure that consists of a sequence of nodes. Each node contains a data field and a reference, that is, a link, to the next node in the sequence. Generally, a node of linked list is represented as a self-referential structure. The linked list elements are accessed with special pointers called head and tail. The principal benefit of a linked list over a conventional array is that the list elements can easily be added or removed without reallocation or reorganization of the entire structure, because data items need not be stored contiguously in memory or on disk. Linked lists allow insertion and removal of nodes at any point in the list. Finding a node that contains a given data item, or locating the place where a new node should be inserted, may require scanning most or all of the list elements. The list elements do not have to occupy contiguous memory. Adding, inserting, or deleting list elements can be accomplished with minimal disruption of neighboring nodes. Single linked list. A single linked list is a list in which each node contains only one link field. Node structure. Struct. Open curly brace. Intele, semicolon. Struct node asterisk next, semicolon. Close curly brace, semicolon. Typedef struct node, semicolon. creating a linked list with two nodes of type list node. Struct node. Open curly brace. Int ale, semicolon. Struct node asterisk next, semicolon. Close curly brace, semicolon. Typedef struct node, semicolon. Node asterisk ptr1, comma, asterisk ptr2, semicolon. ptr1 equals get node, open parenthesis, close parenthesis, semicolon. ptr2 equals get node, open parenthesis, close parenthesis, semicolon. If, open parenthesis, exclamation mark, open parenthesis, ptr1, close parenthesis, ampersand ampersand, exclamation mark, open parenthesis, ptr2, close parenthesis, open curly brace. Printf, open parenthesis, double quote no memory double quote, close parenthesis, semicolon. Exit, open parenthesis, 1, close parenthesis, semicolon. Close curly brace. ptr1, arrow ale equals 10, semicolon. ptr1, arrow next, equals ptr2, semicolon. ptr2, arrow ale, equals 20, semicolon. ptr2, arrow next, equals null, semicolon. Head equals ptr1, semicolon. The diagram below shows the linked list after these statements execute. The head pointer points to the first node containing 10. That node links to the second node containing 20. The second node points to null, indicating the end of the list. Operations on single linked list. Insert at head. Insert at tail. Insert in middle. Delete head. Delete tail. Delete middle. Search. Display. Declare two special pointers called head and tail as follows. Node asterisk head equals tail, semicolon. Head equals tail equals null, semicolon. If head or tail is null, it represents that the list is empty. Steps for insertion. Step 1, allocate memory. Step 2, read data. Step 3, adjust references. Insert head element. Void ins underscore head, open parenthesis, int x, close parenthesis. Open curly brace. Node asterisk temp, semicolon. Temp equals open parenthesis node asterisk close parenthesis malloc, open parenthesis sizeoff, open parenthesis node close parenthesis, semicolon. Temp arrow ale equals x, semicolon. Temp arrow next equals head, semicolon. Head equals temp, semicolon. If open parenthesis, tail equals null, close parenthesis. Tail equals head, semicolon. Close curly brace. Explanation. Step 4, allocates memory for a new node. Step 5, stores the value of x into the data field. Steps 6 through 9, adjust the links, so the new node becomes the first node of the list. The if condition checks whether this is the first insertion into an empty list. Insert tail element. Void ins underscore tail, open parenthesis, int x, close parenthesis. Open curly brace. Node asterisk temp, semicolon. Temp equals open parenthesis node asterisk close parenthesis malloc, open parenthesis sizeoff, open parenthesis node close parenthesis, semicolon. Temp arrow ale equals x, semicolon. Temp arrow next equals null, semicolon. Tail arrow next equals temp, semicolon. If open parenthesis, head equals null, close parenthesis. Head equals tail, semicolon. Close curly brace. Explanation. Step 4 allocates memory. Step 5 stores the data. Steps 6 through 9 adjust the references so the new node is inserted at the end of the list. The if condition handles insertion into an empty list. Insert in middle or random position of list. Void ins underscore mid, open parenthesis, int n, comma, int pose, close parenthesis. Open curly brace. Int I equals 1, semicolon. Node asterisk temp, comma n, comma p, semicolon. double slash, N and P represent the next and previous nodes. If, open parenthesis, head equals NULL, close parenthesis. Open curly brace. Ins underscore head, open parenthesis, N, close parenthesis, semicolon. Return, semicolon. Close curly brace. Temp equals open parenthesis node asterisk close parenthesis malloc, open parenthesis sizeoff, open parenthesis node close parenthesis, semicolon. Temp arrow ele equals N semicolon. P equals head, semicolon. While, open parenthesis, I less than pose -1, close parenthesis. Open curly brace. P equals P, arrow next semicolon. I plus plus, semicolon. Close curly brace. N equals P, arrow next semicolon. Temp, arrow next, equals N semicolon. P, arrow next, equals temp semicolon. Close curly brace. Explanation. Step 4 checks whether the insertion is into an empty list. If the list is empty, it calls ins underscore head. If the list is not empty, Step 9 allocates memory. Step 10 stores the data. Steps 11 through 14 locate the previous node and the next node. Steps 15 and 16 connect the new node between those two nodes. Example 1. Head equals tail equals NULL. N equals 5, P equals NULL semicolon. The diagram shows an empty linked list. Both head and tail point to NULL, meaning no nodes exist in the list. Example 2. The diagram shows a linked list containing 3 nodes with values 5, 10, and 15. Head points to the first node, and tail points to the last node. Insert element, open parenthesis, N, close parenthesis, at position 3. Currently, 5 is the first element, 10 is the second element, and 15 is the third element. To insert a new node at position 3, the new node is placed between the nodes containing 10 and 15. Since the condition in step 4 is false, execution continues from step 9, where memory is allocated for the new node. On completion of step 10, the diagram shows a new node named temp has been created, but its data field is still empty. After step 11, the value 20 is stored in the temp node. The next diagram shows the current linked list. Head points to the node containing 5, followed by 10, and then 15. Tail points to the last node containing 15. Steps 12 and 13. While, open parenthesis, I less than pose -1, close parenthesis. Open curly brace. P equals P, arrow next semicolon. I plus plus, semicolon. Close curly brace. Initially, I equals 1. 1 is less than 2, so the condition is true. Pointer P moves from the first node, containing 5 to the second node containing 10. Now I becomes 2. 2 is less than 2 is false, so the loop terminates. Step 14. N equals P, arrow next semicolon. The diagram shows that pointer P points to the node containing 10, and pointer N points to the node containing 15. Steps 15 and 16. Temp, arrow next, equals N semicolon. P, arrow next, equals temp semicolon. The diagram shows the new node containing 20 inserted between the nodes containing 10 and 15. The next pointer of the node containing 10 now points to the new node. The next pointer of the new node points to the node containing 15. The tail pointer continues to point to the last node containing 15. The element 20 now becomes the third element in the linked list. Deletion. Deletion involves 4 main steps. Step 1. Identify the node. Step 2. Adjust the links so that deleting the node does not disconnect the remaining list. Step 3. Return or display the deleted element. Step 4. Deallocate the memory occupied by the deleted node. Delete head element. Void del underscore head, open parenthesis, close parenthesis. Open curly brace. Int x semicolon. Node asterisk temp, semicolon. If, open parenthesis, head equals NULL, close parenthesis. Open curly brace. Print F, open parenthesis, double quote list empty double quote, close parenthesis, semicolon. Return, semicolon. Close curly brace. Equals head, arrow ls semicolon. Temp equals head, semicolon. If, open parenthesis, head equals tail, close parenthesis. Head equals tail equals NULL, semicolon. Else. Head equals head, arrow next semicolon. Print F, open parenthesis, double quote deleted element percentage D double quote, comma, X, close parenthesis, semicolon. Free, open parenthesis, temp, close parenthesis, semicolon. Close curly brace. Explanation. Step 4 checks whether the list is empty. Step 9 reads the element to be deleted. Step 10 makes temp point to the current head node. Step 11 checks whether the list contains only one node. Step 14 moves the head pointer to the next node in the list. Step 15 displays the deleted element. Step 16 deallocates the memory occupied by the deleted node. Delete tail element. Void del underscore tail, open parenthesis, close parenthesis. Open curly brace. Int x semicolon. Node asterisk temp, semicolon. If, open parenthesis, head equals NULL, close parenthesis. Open curly brace. Print F, open parenthesis, \n, list empty, close parenthesis, semicolon. Return, semicolon. Close curly brace. Temp equals head, semicolon. While, open parenthesis, temp arrow next, not equals tail, close parenthesis. Temp equals temp, arrow next, semicolon. Equals tail, arrow ls semicolon. Tail equals temp, semicolon. Temp equals temp, arrow next, semicolon. Tail arrow next, equals NULL, semicolon. Print F, open parenthesis, \n, deleted element colon, percentage D double quote, comma, X, close parenthesis, semicolon. Free, open parenthesis, temp, close parenthesis, semicolon. Close curly brace. Explanation. Step 4 checks whether the list is empty. Steps 10, 11, and 12 move the temp pointer until it reaches the node just before the tail node. Step 13 reads the value stored in the tail node. Step 14 moves the tail pointer to the previous node. Step 15 moves temp to the old tail node. Step 16 removes the link to the old tail node, so the new tail becomes the last node in the list. Step 17 displays the deleted element. Step 18 deallocates the memory occupied by the deleted node. Delete middle element. Void del underscore mid, open parenthesis, int pose, close parenthesis. Open curly brace. Int I equals 1, comma x, semicolon. Node asterisk temp, comma p, comma n, semicolon. If, open parenthesis, head equals NULL, close parenthesis. Open curly brace. Print F, open parenthesis, \n, list empty, close parenthesis, semicolon. Return, semicolon. Close curly brace. P equals head, semicolon. While, open parenthesis, I less than pose -1, close parenthesis. Open curly brace. P equals P, arrow next, semicolon. I plus plus, semicolon. Close curly brace. Temp equals P, arrow next, semicolon. N equals temp, arrow next, semicolon. P arrow next equals N semicolon. Equals temp, arrow ls semicolon. Print F, open parenthesis, \n, element to delete, percentage D double quote, comma, X, close parenthesis, semicolon. Free, open parenthesis, temp, close parenthesis, semicolon. Close curly brace. Explanation. Step 5 checks whether the list is empty. Steps 10, 11, and 12 move pointer P to the node just before the node to be deleted. Step 13 makes temp point to the node that will be deleted. Step 14 makes pointer n point to the next node after temp. Step 15 changes the link so pointer p points directly to pointer n, bypassing the deleted node. Steps 16, 17, and 18 read the deleted value, display it, and deallocate the memory occupied by the deleted node. Diagram explanation. The first diagram shows 3 linked nodes containing A, B, and C. Pointer P refers to the node before the node to be deleted. Pointer temp refers to the node containing B, and pointer N refers to the node containing C. The second diagram shows the link from node A changed to point directly to node C. Node B is disconnected from the list and can now be safely deallocated. Linked list using dynamic variables. In a linked list, each node contains a data field and a link field that points to the next node. Since nodes are created during program execution, memory is allocated dynamically. For this purpose, a function named getNode is used. Function definition. Struct node. Open curly brace. Int ale, semicolon. Struct node asterisk next, semicolon. Close curly brace, semicolon. Typedef struct node, semicolon. Node get node, open parenthesis, close parenthesis. Open curly brace. Node ptr, semicolon. ptr equals open parenthesis node asterisk close parenthesis malloc, open parenthesis, size of, open parenthesis, struct node, close parenthesis, semicolon. Return, open parenthesis, ptr, close parenthesis, semicolon. Close curly brace. Explanation. If pointer ptr returns null, an underflow condition occurs because memory could not be allocated. Otherwise, it returns the starting address of the newly allocated memory block. Search an element. Void search, open parenthesis, int x, close parenthesis. Open curly brace. Node asterisk temp equals head, semicolon. Int c equals 1, semicolon. While, open parenthesis, temp not equals null, close parenthesis. Open curly brace. If, open parenthesis, temp arrow ale, equals x, close parenthesis. Open curly brace. Printf, open parenthesis, \n, element found at %d double quote, comma, c, close parenthesis, semicolon. Break, semicolon. Close curly brace. C++, semicolon. Temp equals temp, arrow next, semicolon. Close curly brace. If, open parenthesis, temp equals null, close parenthesis. Printf, open parenthesis, \n, search unsuccessful, double quote, close parenthesis, semicolon. Close curly brace. Explanation. Step 7 compares the value stored in the current node with the search element. This process repeats until the element is found or the last node is reached. Step 9 displays the position of the element if it is found. Steps 14 and 15 indicate that the searched element does not exist in the list. Display. Void display, open parenthesis, close parenthesis. Open curly brace. Node asterisk temp equals head, semicolon. Printf, open parenthesis, \n, list elements colon, double quote, close parenthesis, semicolon. While, open parenthesis, temp not equals null, close parenthesis. Open curly brace. Printf, open parenthesis, %d double quote, comma, temp, arrow, ale, close parenthesis, semicolon. Temp equals temp, arrow next, semicolon. Close curly brace. Close curly brace. Explanation. Step 7 displays the value stored in the current node. Step 8 moves pointer temp to the next node. Algorithm to reverse the direction of all links of a singly linked list. Consider a linked list L with head pointing to the first node. Each node contains a data element named ale and a pointer named next that points to the next node. The reverse operation changes the direction of every link in the list. 3 pointers are used, P, Q, and R. Initially, pointer P points to the first node, pointer Q points to NULL, and pointer R is used to temporarily store the next node during the reversal process. Step 1. Start. Step 2. If open parenthesis, P equals NULL, close parenthesis. Printf, open parenthesis, double quote list is null double quote, close parenthesis, semicolon. Exit. Step 3. While open parenthesis, P close parenthesis. Step 4. R equals Q semicolon. Step 5. Q equals P semicolon. Step 6. P equals P arrow next semicolon. Step 7. Q arrow next equals R semicolon. Step 8. End while. Step 9. Head equals Q semicolon. Step 10. Stop. Explanation. Initially, pointer P points to the first node, pointer Q points to NULL, and pointer R is used as a temporary pointer. During each iteration, pointer R stores the previous node, pointer Q moves to the current node, pointer P advances to the next node, and the next link of pointer Q is reversed to point to pointer R. After the loop completes, head is updated to pointer Q, which becomes the new first node of the reversed linked list. Double linked list, abbreviated as DLL. A double linked list is a linked list in which each node contains one data field and 2 link fields. Node structure. Struct D node. Open curly brace. Struct D node asterisk prev, semicolon. Intele, semicolon. Struct D node asterisk next, semicolon. Close curly brace, semicolon. Important points. Pointer prev points to the previous node in the list. Pointer next points to the next node in the list. The operations that can be performed on a singly linked list can also be performed on a double linked list. The major difference is that both forward and backward references must be maintained. A double linked list can be traversed in both forward and reverse directions. Diagram explanation. The diagram shows 3 nodes containing A, B, and C. Head points to the first node, containing A. Tail points to the last node, containing C. Each node has 2 links. One link points to the previous node, and the other link points to the next node, allowing traversal in both directions. Circular linked list, abbreviated as CLL. A circular linked list is similar to a singly linked list, except that the last node, called the tail, points back to the first node, called the head. Therefore, insertion and deletion at the head and tail are slightly different from those in a singly linked list. Double circular linked list, abbreviated as DCL. A double circular linked list is similar to a double linked list, except that the last node's next pointer points to the first node, and the first node's previous pointer points to the last node. Therefore, insertion and deletion at the head and tail require slightly different reference adjustments compared with a double linked list. Storing ordered table as a linked list. The table is stored as a linked list. It is retrieved and stored using 2 pointers. One pointer points to the node containing the smallest key, while the other pointer is used for searching. Stack. A stack is a last in, first out, or LIFO, abstract data type and data structure. A stack can have any abstract data type as an element, but it is characterized by only 2 fundamental operations. Push. Pop. The push operation adds an item to the top of the stack. This may involve inserting a new element or initializing the stack if it is empty. The pop operation removes an item from the top of the stack and returns the removed value to the caller. Elements are removed from the stack in the reverse order in which they were inserted. Therefore, the lower elements are those that have remained in the stack for the longest time. Diagram explanation. The diagram illustrates a stack. The push operation inserts a new element at the top of the stack. The pop operation removes the element currently at the top. Only the top element is accessible at any time. Implementation. A stack can be implemented using either an array or a linked list. The user can only perform push and pop operations on the array or linked list. Array implementation. An array implementation creates a stack where the first inserted element is stored at index 0 and is removed last. The program maintains a variable named top, which always indicates the current top element of the stack. Operations. Initially, top equals -1, which indicates that the stack is empty. Push operation. Push, open parenthesis, s, n, top, x, close parenthesis. Open curly brace. If, open parenthesis, top equals n-1, close parenthesis. Print f, open parenthesis, double quote, overflow double quote, close parenthesis, semicolon. Else. Top equals top plus 1, semicolon. S, open square bracket, top close square bracket, equals x, semicolon. Close curly brace. Explanation. If top reaches n-1, the stack is full and an overflow condition occurs. Otherwise, top is incremented, and the new element x is placed at the top of the stack. Pop operation. Pop, open parenthesis, s, n, top, x, close parenthesis. Open curly brace. If, open parenthesis, top equals -1, close parenthesis. Print f, open parenthesis, double quote, underflow double quote, close parenthesis, semicolon. Else. Equals s, open square bracket, top close square bracket, semicolon. Top equals top -1, semicolon. Return x, semicolon. Close curly brace. Explanation. If top equals -1, the stack is empty and an underflow condition occurs. Otherwise, the element at the top of the stack is copied into x, top is decremented, and the removed element is returned. Dynamic implementation of stack. The array implementation is called a static implementation because the size of the stack is fixed. The linked list implementation is called a dynamic implementation because the size of the stack can grow and shrink as elements are added to or removed from the stack. The push operation on a linked stack is the same as inserting a node at the head in a singly linked list. The pop operation on a linked stack is the same as deleting the head node in a singly linked list. Algorithm to add and delete in a linked stack and linked queue. Linked stack. Diagram explanation. The diagram shows a linked stack with 2 pointers, head and top. Head points to the beginning of the linked stack. Top points to the topmost element of the stack, which is the first node in the linked list. Each node contains a data field and a link to the next node. Push operation. Push open parenthesis item close parenthesis. Steps. Step 1. PTR equals get node, open parenthesis, node, close parenthesis, semicolon. Step 2. PTR dot data equals item, semicolon. Step 3. PTR dot next equals top, semicolon. Step 4. Top equals PTR, semicolon. Step 5. Head dot next equals top, semicolon. Step 6. Stop. Explanation. A new node is created. The item is stored in the new node. The new node is linked to the current top node. Top is updated to point to the new node. Head is updated to point to the new top node. Pop operation. Pop open parenthesis close parenthesis. Steps. Step 1. If open parenthesis top equals null, close parenthesis. Print open parenthesis, double quote, stack is empty, double quote, close parenthesis, semicolon. Exit. Else. PTR equals top, comma next, semicolon. Item equals top, dot, data, semicolon. Head dot, next equals PTR, semicolon. Top equals PTR, semicolon. End if. Stop. Explanation. If top is null, the stack is empty and no deletion is possible. Otherwise, the first node is removed, its data is stored in item, and both head and top are updated to the next node. Linked queue representation. Diagram explanation. The diagram shows a linked queue with two special pointers named front and rear. Front points to the first node in the queue. Rear points to the last node in the queue. New elements are inserted at the rear. Elements are deleted from the front. In queue operation, in queue open parenthesis item close parenthesis. Steps. Step 1. PTR equals get node, open parenthesis, node, close parenthesis, semicolon. Step 2. PTR dot data equals item, semicolon. Step 3. PTR dot next equals NULL, semicolon. Step 4. If open parenthesis, front equals NULL, close parenthesis. Front equals PTR, semicolon. Else. Rear dot, next equals PTR, semicolon. End if. Step 6. Rear equals PTR, semicolon. Step 7. Stop. Explanation. A new node is created, and the item is stored in it. The new node becomes the last node in the queue. If the queue is empty, both front and rear point to the new node. Otherwise, the current rear node is linked to the new node, and rear is updated. Dequeue operation. Dequeue open parenthesis close parenthesis. Steps. Step 1. If open parenthesis, front equals NULL, close parenthesis. Print, open parenthesis, double quote, underflow, double quote, close parenthesis, semicolon. Exit. Step 2. PTR equals front, semicolon. Step 3. Front equals PTR dot next, semicolon. Step 4. Head dot next equals front, semicolon. Step 5. Item equals PTR dot data, semicolon. Step 6. Free, open parenthesis, PTR, close parenthesis, semicolon. Step 7. End. Explanation. If the queue is empty, an underflow condition occurs. Otherwise, the first node is removed, its value is saved, front is moved to the next node, and the deleted node is deallocated. Uses of stack. Function calls. During a function call, local variables and the return address are stored on the system stack. Recursion. Recursive function calls use the stack to store activation records. Revering a list. Parsing. Compilers use stacks to check the syntax of programs. Expression evaluation. Expression notations. Infix expression. In an infix expression, the operator appears between the operands. Example, a plus b. Postfix expression. In a postfix expression, the operator appears after both operands. Example, a b plus. Prefix expression. In a prefix expression, the operator appears before both operands. Example, plus a b. Infix to postfix conversion. Rules. If the symbol is an operand, write it directly into the postfix expression. If the symbol is an operator, push it onto the stack. If an opening parenthesis is encountered, push it onto the stack. When a closing parenthesis is encountered, repeatedly pop operators from the stack and write them into the postfix expression until the matching opening parenthesis is removed. Example, open parenthesis a plus, open parenthesis b minus c, close parenthesis star d. The example demonstrates the conversion of an infix expression into a postfix expression using a stack. Initial state. Input symbol, open parenthesis. Postfix notation, empty. Stack, open parenthesis. Step 2. Input symbol, A. Postfix notation, A. Stack, open parenthesis. Step 3. Input symbol, plus. Postfix notation, A. Stack, open parenthesis plus. Step 4. Input symbol, open parenthesis. Postfix notation, A. Stack, open parenthesis plus, open parenthesis. Step 5. Input symbol, B. Postfix notation, a B. Stack, open parenthesis plus, open parenthesis. Step 6. Input symbol, minus. Postfix notation, a B. Stack, open parenthesis plus, open parenthesis minus. Step 7. Input symbol, C. Postfix notation, a BC. Stack, open parenthesis plus, open parenthesis minus. Step 8. Input symbol, close parenthesis. Postfix notation, a BC minus. Stack, open parenthesis plus. Explanation. Pop the minus operator and discard the matching opening parenthesis. Step 9. Input symbol, close parenthesis. Postfix notation, a BC minus plus. Stack empty. Explanation. Pop the plus operator and discard the remaining opening parenthesis. Step 10. Input symbol, star. Postfix notation, a BC minus plus. Stack star. Step 11. Input symbol, D. Postfix notation, a BC minus plus D. Stack star. Final step. The input expression has been completely scanned. Pop the remaining operator from the stack. Final postfix notation is a BC minus plus D star. Evaluation of postfix expression. We use an operand stack to evaluate a postfix expression. While scanning the postfix expression, whenever an operand is encountered, push it onto the operand stack. Whenever an operator is encountered, pop the top two operands from the stack. Perform the required operation. Push the result back onto the operand stack. After the complete expression is scanned, the stack contains only one value, which is the final result. Example. The postfix expression is 623 plus minus 382 divide plus star 23 plus. Operand stack evaluation table. Symbol 6. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 6. Symbol 2. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 6 2. Symbol 3. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 6 2 3. Symbol plus. Operand 1, 2. Operand 2, 3. Value 5. Operand stack 6 5. Symbol minus. Operand 1, 6. Operand 2, 5. Value 1. Operand stack 1. Symbol 3. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 1 3. Symbol 8. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 1 3 8. Symbol 2. Operand 1, empty. Operand 2, empty. Value, empty. Operand stack 1 3 8 2. Symbol divide. Operand 1, 8. Operand 2, 2. Value 4. Operand stack 1 3 4. Symbol plus. Operand 1, 3. Operand 2, 4. Value 7. Operand stack 1 7. Symbol star. Operand 1, 1. Operand 2, 7. Value 7. Operand stack 7. Symbol 2. Operand 1, empty. Operand 2, empty. Value empty. Operand stack 7 2. Symbol 3. Operand 1, empty. Operand 2, empty. Value empty. Operand stack 7 2 3. Symbol plus. Operand 1, 2. Operand 2, 3. Value, 5. Operand stack, 7, 5. Final operation. Operand 1, 7. Operand 2, 5. Value, 17. Operand stack, 17. Result is 17. Performing add and delete operations on stack, multiple stack. Let us consider an array whose size is max, with multiple stacks A and B having top A and top B respectively. The push and pop operations on one stack A are given below. Algorithm for push A, open parenthesis, X, close parenthesis. Initially, a open square bracket, max close square bracket. Top A equals -1. Top B equals max. Step 1. If, open parenthesis. Top A equals top B -1. Close parenthesis. Print, open parenthesis. Double quote. Overflow. Double quote. Close parenthesis. Semicolon. Exit. Step 2. Top A equals top A plus 1. Step 3. A open square bracket, top A close square bracket equals X. Step 4. Stop. Algorithm for pop A, open parenthesis, X, close parenthesis. Step 1. If top A equals -1. Print. Underflow. And exit. Step 2. Y equals a open square bracket top, a close square bracket semicolon. Step 3. Top A equals top A -1 semicolon. Step 4. Return Y semicolon. Step 5. Stop. Algorithm for push B, open parenthesis, X, close parenthesis. Step 1. If top B -1 equals top A. Print. Overflow. And exit. Step 2. Top B equals top B -1 semicolon. Step 3. A open square bracket, top B close square bracket, equals X semicolon. Step 4. Stop. Algorithm for pop B, open parenthesis, X, close parenthesis. Step 1. If top B equals max. Print. Underflow. And exit. Step 2. Y equals a open square bracket, top B close square bracket semicolon. Step 3. Top B equals top B plus 1 semicolon. Step 4. Return Y semicolon. Step 5. Stop. Queue. A queue is an ordered collection of items. Items are deleted from one end, called the front of the queue. Items are inserted at the other end, called the rear of the queue. A queue is a linear data structure that follows the first in, first out, or FIFO principle. Implementation. A queue can be implemented in the following ways. 1. Array static implementation. The queue size is fixed and cannot be extended beyond the declared array size. 2. Linked list dynamic implementation. The queue size increases as elements are inserted into the queue. The queue size decreases as elements are deleted from the queue. Array implementation of queue. Constant int size equals 10, semicolon. Int q, open square bracket size close square bracket, semicolon. Int f equals -1, comma, r equals -1, semicolon. Comment, f equals r equals -1 represents an empty queue. Diagram explanation. The diagram shows a queue implemented using an array. The front pointer indicates the position from where elements are removed. The rear pointer indicates the position where new elements are inserted. Initially, both front and rear are -1, which means the queue is empty. Insertion. Void insert, open parenthesis, int x, close parenthesis. Open curly brace. If, open parenthesis, r equals size -1, close parenthesis. Open curly brace. Print f, open parenthesis, double quote, q full, double quote, close parenthesis, semicolon. Return, semicolon. Close curly brace. R++, semicolon. Q, open square bracket R close square bracket, equals X, semicolon. If, open parenthesis, F equals -1, close parenthesis. F equals R, semicolon. Close curly brace. Explanation. Step 3 checks whether the Q is full. Step 8 increments the rear pointer. Step 9 inserts the value into the Q. Step 10 checks whether this is the first insertion. Step 11 updates front to rear if the first element has been inserted. Deletion. Void deletion, open parenthesis, close parenthesis. Open curly brace. Int X, semicolon. If, open parenthesis, F equals -1, close parenthesis. Open curly brace. Print F, open parenthesis, \n, Q empty, close parenthesis, semicolon. Return, semicolon. Close curly brace. Equals Q, open square bracket F close square bracket, semicolon. If, open parenthesis, F equals R, close parenthesis. F equals R equals -1, semicolon. Else. F++, semicolon. Print F, open parenthesis, \n, deleted element %d, double quote, comma, X, close parenthesis, semicolon. Close curly brace. Explanation. Step 4 checks whether the Q is empty. Step 9 deletes the element at the front of the Q. Step 10 checks whether only one element is present in the Q. Step 11 sets both front and rear to -1 when the last element is deleted. Step 13 moves the front pointer to the next element when more than one element exists. Step 14 displays the deleted element. Display. Void display, open parenthesis, close parenthesis. Open curly brace. Int I equals F, semicolon. If, open parenthesis, F equals -1, close parenthesis. Open curly brace. Print F, open parenthesis, double quote, Q empty, double quote, close parenthesis, semicolon. Return, semicolon. Close curly brace. Print F, open parenthesis, double quote. Q elements, double quote, close parenthesis, semicolon. For open parenthesis, I equals F, semicolon, I less than or equals R, semicolon, I++, close parenthesis. Print F, open parenthesis, %d, double quote, comma, Q, open square bracket I close square bracket, close parenthesis, semicolon. Close curly brace. Explanation. Step 4 checks whether the Q is empty. Steps 10 and 11 display all elements of the Q from front to rear. Double-ended Q. A double-ended Q, also called a deck, is an abstract data structure that implements a queue in which elements can be inserted or removed from both the front, also called the head, and the rear, also called the tail. Diagram explanation. The diagram shows a queue where insertion and deletion are possible from both the front and the rear. Unlike a normal queue, both ends are open for operations. Linked list implementation of double-ended queue. Insert at the front is the same as insert at the head in a linked list. Insert at the rear is the same as insert at the tail in a linked list. Delete at the front is the same as delete at the head in a linked list. Delete at the rear is the same as delete at the tail in a linked list. Circular queue. As elements are deleted from a linear queue, the space occupied by those elements becomes unused. These unused positions remain empty, even though they could be reused. A circular queue solves this problem by connecting the last position of the queue back to the first position. Unlike a linear queue, a circular queue has no fixed beginning or end. Diagram explanation. The figure shows a circular queue with positions numbered from 0 to 9. The last position is connected back to the first position, forming a circle. When the rear reaches the last position, it wraps around to the first available position instead of stopping. This allows efficient reuse of memory that becomes free after deletions. Advantage of circular queue. The main advantage of a circular queue over a linear queue is the efficient utilization of memory. Algorithm to implement addition and deletion from circular queue. Circular queue insertion. To insert an element X into a queue of size n with front and rear pointers F and R, the insertion operation insert, open parenthesis, X, close parenthesis, is performed. Initially, F equals R equals 0. Circular queue insertion. To add an element, we implement the algorithm insert, open parenthesis, X, close parenthesis. Initially, front equals rear equals 0. Steps. Step 1. If open parenthesis, R equals n, close parenthesis, and open parenthesis, F equals 1, close parenthesis, or open parenthesis, R plus 1, close parenthesis, equals F, close parenthesis. Print, open parenthesis, double quote, overflow, double quote, close parenthesis, semicolon. Exit. Explanation. This step checks whether the circular queue is full. If it is full, an overflow condition occurs. Step 2. If open parenthesis, R equals n, close parenthesis, then R equals 0, semicolon. Else, R equals R plus 1, semicolon. Explanation. If rear has reached the last position of the array, it wraps around to position 0. Otherwise, rear moves to the next position. Step 3. Q, open square bracket, R close square bracket, equals X, semicolon. Explanation. The new element X is inserted at the rear position. Step 4. If open parenthesis, F equals 0, close parenthesis, F equals 1, semicolon. Explanation. If this is the first insertion, front is initialized to 1. Step 5. Stop. Circular queue deletion. To delete an element, we implement the algorithm delete, open parenthesis, close parenthesis. Variable y stores the deleted element. Steps. Step 1. If open parenthesis, F equals 0, close parenthesis. Print, open parenthesis, double quote, underflow, double quote, close parenthesis, semicolon. Exit. Explanation. If front is 0, the queue is empty and an underflow condition occurs. Step 2. Y equals Q, open square bracket, F close square bracket, semicolon. Explanation. The element at the front of the queue is copied into variable y. Step 3. If open parenthesis, F equals R, close parenthesis, F equals R equals 0, semicolon. Else, if open parenthesis, F equals n, close parenthesis, F equals 1, semicolon. Else, F equals F plus 1, semicolon. Explanation. If there was only one element in the queue, both front and rear are reset to 0. Otherwise, if front reaches the last position, it wraps around to 1. If neither condition is true, front simply moves to the next position. Step 4. Return y. Step 5. Stop. Priority queue. In a priority queue, the intrinsic ordering of elements determines the result of the queue operations. There are two types of priority queues. Ascending priority queue. An ascending priority queue is a collection of items in which elements may be inserted in any order, but only the smallest element can be removed. Descending priority queue. A descending priority queue is similar, except that only the largest element can be removed. Array implementation of priority queue. The insertion operation first determines the correct position for the new element. If necessary, the existing elements are shifted to create an empty position. The new element is then placed in its correct location. The deletion operation simply removes the element at the front of the queue. Linked list implementation of priority queue. The insertion operation creates a new node. The element is stored in the new node. The correct insertion position is located. The node is inserted by adjusting the links or references. The deletion operation removes the head node and makes the next node the new head. Linked list implementation of priority queue. Insertion into the priority queue is the same as inserting at the tail of a linked queue. Deletion from the priority queue is the same as deleting the head node of a linked queue. Exercises. Practice problems 1. Directions for questions 1 to 16. Select the correct alternative from the given choices. Question 1. If the array representation of a circular queue contains only one element, then Option A, front equals rear. Option B, front equals rear plus 1. Option C, front equals rear minus 1. Option D, front equals rear equals NULL. Question 2. The 5 items P, Q, R, S, and T are pushed into a stack one after another, starting from P. The stack is popped 4 times, and each popped element is inserted into a queue. 2 elements are then deleted from the queue and pushed back onto the stack. Now 1 element is popped from the stack. The popped element is Option A, P. Option B, Q. Option C, R. Option D, S. Question 3. What are the contents of the stack, assuming the stack is initially empty after performing the following operations? Push, open parenthesis, A, close parenthesis, semicolon. Push, open parenthesis, B, close parenthesis, semicolon. Push, open parenthesis, C, close parenthesis, semicolon. Pop, semicolon. Push, open parenthesis, D, close parenthesis, semicolon. Pop, semicolon. Pop, semicolon. Push, open parenthesis, E, close parenthesis, semicolon. Push, open parenthesis, F, close parenthesis, semicolon. Pop, semicolon. Option A, B, E. Option B, A, E. Option C, A. Option D, A, B, C, E. Question 4. Consider the following code, which deletes a node from the beginning of a linked list. Void delete front, open parenthesis, close parenthesis. Open curly brace. If open parenthesis, head equals NULL, close parenthesis. Return, semicolon. Else. Open curly brace. Dot dot dot. Dot dot dot. Dot dot dot. Close curly brace. Close curly brace. Question. Which lines will correctly implement the else part of the above code? Option A. If open parenthesis, head, arrow, next equals NULL, close parenthesis. Head equals head, arrow next, semicolon. Option B. If open parenthesis, head equals tail, close parenthesis. Head equals tail equals NULL, semicolon. Else. Head equals head, arrow next, semicolon. Option C. If open parenthesis, head equals tail equals NULL, close parenthesis. Head equals head, arrow next, semicolon. Option D. Head equals head, arrow next, semicolon. Question 5. When a new element is inserted in the middle of a linked list, then the references of blank are to be adjusted or updated. Option A, those nodes that appear after the new node. Option B, those nodes that appear before the new node. Option C, head and tail nodes. Option D, those nodes that appear just before and after the new node. Question 6. The following function takes a doubly linked list as an argument. It modifies the list by moving the head, that is, the first element to the tail of the list. Code. Typedef struct node. Open curly brace. Struct node asterisk P, semicolon. Int data, semicolon. Struct node asterisk N, semicolon. Close curly brace. Node, semicolon. node asterisk move underscore to underscore last, open parenthesis, node asterisk head, close parenthesis. Open curly brace. Node asterisk temp, comma, asterisk prev, comma, asterisk next, semicolon. If open parenthesis, head equals null, close parenthesis, vertical bar, open parenthesis, head, arrow, n equals null, close parenthesis. Return head, semicolon. Temp equals head, semicolon. Prev equals head, semicolon. Head equals head, arrow n, semicolon. While open parenthesis, prev, arrow, and not equals null, close parenthesis. Open curly brace. X semicolon. Close curly brace. Y semicolon. Return head, semicolon. Close curly brace. Options. Option A. X colon, prev equals prev, arrow n, semicolon. Y colon. Temp, arrow, n equals temp, semicolon. Temp, arrow, p equals prev, semicolon. Temp, arrow, n equals null, semicolon. Head, arrow, p equals null, semicolon. Option B. X colon, next equals prev, arrow n, semicolon. Y colon. Temp, arrow, p equals temp, semicolon. Temp, arrow, n equals null, semicolon. Option C. X colon, prev equals prev, arrow n, semicolon. Y colon. Prev, arrow, n equals temp, semicolon. Temp, arrow, n equals null, semicolon. Head, arrow, p equals null, semicolon. Option D. X colon, next equals prev, arrow n, semicolon. Prev equals prev, arrow n, semicolon. Y colon. Temp, arrow, n equals next, semicolon. Question 7. Which of the following program segments correctly inserts an element at the front of the linked list? Assume that node represents a linked list node structure, and value is the element to be inserted. Option A. Temp equals, open parenthesis, node asterisk, close parenthesis, malloc, open parenthesis, size of open parenthesis, node, close parenthesis, semicolon. Temp, arrow, data equals value, semicolon. Temp, arrow, next equals head, semicolon. Head equals temp, semicolon. Option B. Temp equals, open parenthesis, node asterisk, close parenthesis, malloc, open parenthesis, size of open parenthesis, node asterisk, close parenthesis, semicolon. Temp, arrow, data equals value, semicolon. Temp, arrow, next equals head, semicolon. Head equals temp, semicolon. Option C. Temp equals, open parenthesis, node asterisk, close parenthesis, malloc, open parenthesis, size of open parenthesis, node, close parenthesis, semicolon. Head equals temp, semicolon. Temp, arrow, next equals head, semicolon. Temp, arrow, data equals value, semicolon. Option D. Temp equals, open parenthesis, node asterisk, close parenthesis, malloc, open parenthesis, size of open parenthesis, node asterisk, close parenthesis, semicolon. Temp, arrow, data equals value, semicolon. Head equals temp, semicolon. Temp, arrow, next equals head, semicolon. Question 8. Consider the following program segment. Code. Struct element. Open curly brace. Int x, semicolon. Struct element asterisk link, semicolon. Close curly brace. Void shuffle, open parenthesis, struct element asterisk head, close parenthesis. Open curly brace. Struct asterisk p, comma asterisk q, semicolon. Int t, semicolon. If open parenthesis, exclamation mark head, vertical bar, exclamation mark head, arrow, link, close parenthesis, return, semicolon. P equals head, semicolon. Q equals head, arrow link, semicolon. while open parenthesis, q, close parenthesis, open curly brace, t equals p, arrow x semicolon, p arrow, x equals q arrow x semicolon, q arrow, x equals t semicolon, p equals q, arrow link semicolon, q equals p question mark p, colon 0, semicolon, close curly brace, close curly brace. The function is called with a linked list containing the values 10, 15, 20, 25, 30, 35, and 40, in that order. What will be the order of the elements after executing the function shuffle? Option A 10, 15, 20, 25, 30, 35, 40. Option B 40, 35, 30, 25, 20, 15, 10. Option C 20, 15, 10, 25, 40, 35, 30. Option D 15, 10, 25, 20, 35, 30, 40. Question 9. Primary ADTs are: Option A linked list only, Option B stack only, Option C queue only, Option D all of these. Question 10. Linked list uses NULL pointers to signal: Option A end of list, Option B start of list, Option C either Option A or Option B, Option D neither Option A nor Option B. Question 11. Which of the following is essential for converting an infix expression to postfix form efficiently? Option A operator stack, Option B operand stack, Option C both Option A and Option B, Option D parse tree. Question 12. Stacks cannot be used to: Option A evaluate postfix expression, Option B implement recursion, Option C convert infix to postfix, Option D allocate resource like CPU by the operating system. Question 13. Linked list can be sorted by: Option A swapping data only, Option B swapping address only, Option C both Option A and Option B, Option D none of these. Question 14. Linked list are not suitable for implementing: Option A insertion sort, Option B binary search, Option C radix sort, Option D polynomial manipulation. Question 15. Insertion of a node in a doubly linked list requires how many changes to previous, open parenthesis, prev, close parenthesis, and next pointers? Option A no changes, Option B 2 next and 2 previous, Option C 1 next and 1 previous, Option D 3 next and 3 previous. Question 16. Minimum number of stacks required to implement a queue is: Option A 1, Option B 2, Option C 3, Option D 4. Practice problems 2. Directions for questions 1 to 11. Select the correct alternative from the given choices. Question 1. Stack is useful for implementing: Option A radix sort, Option B breadth first search, Option C quick sort, Option D recursion. Question 2. Which is true about linked list? Option A linked list is a dynamic data structure. Option B a linked list is a static structure. Option C a stack cannot be implemented by a linear linked list. Option D none of the above. Question 3. The process of accessing the data stored in a tape is similar to manipulating data in a: Option A stack, Option B list, Option C queue, Option D heap. Question 4. Which of the following is used to aid in evaluating a prefix expression? Option A queue, Option B heap, Option C stack, Option D hash. Question 5. Select the statement which best completes the sentence. Abstract data type is: Option A a data type which is abstract in nature, Option B a kind of data type, Option C data structure, Option D a mathematical model together with a set of operations defined on it. Question 6. Which of the following data structures may give an overflow error, even though the current number of elements in it is less than its size? Option A, simple queue. Option B, circular queue. Option C, stack. Option D, none of these. Question 7. In a circular linked list, insertion of a record involves the modification of blank. Option A, no pointer. Option B, 4 pointers. Option C, 2 pointers. Option D, all of the above. Question 8. Among the following, which one is not the right operation on a stack? Option A, remove the item that is inserted latest into the stack. Option B, add an item to the stack. Option C, remove the first item that is inserted into the stack without deleting other elements. Option D, none of the above. Question 9. Among the following, which one is not the right operation on a DQ? Option A, inserting an element in the middle of a DQ. Option B, inserting an element at the front of a DQ. Option C, inserting an element at the rear of a DQ. Option D, none of the above. Question 10. A linear list in which elements can be added or removed at either end, but not in the middle, is blank. Option A, queue. Option B, DQ. Option C, array. Option D, tree. Question 11. The postfix notation of a /b *c plus d equals e minus a *c is. Option A, a bc */de* plus a c *minus. Option B, a bc */de/ plus a c plus minus. Option C, a bc */de* a c plus minus. Option D, a bc */de* plus a c plus minus. Previous year's questions. Question 1, year 2005. An abstract data type. Open parenthesis a DT, close parenthesis, is. Option A, same as an abstract class. Option B, a data type that cannot be instantiated. Option C, a data type for which only the operations are defined. Option D, all of the above. Question 2, year 2006. An implementation of a queue, using two stacks, S1 and S2, is given below. Code. Void insert, open parenthesis, q, comma, x, close parenthesis. Open curly brace. Push, open parenthesis, S1, comma, x, close parenthesis, semicolon. Close curly brace. Void delete, open parenthesis, q, close parenthesis. Open curly brace. If, open parenthesis, stack empty, open parenthesis, S2, close parenthesis, close parenthesis. Open curly brace. If, open parenthesis, stack empty, open parenthesis, S1, close parenthesis, close parenthesis. Open curly brace. Print, open parenthesis, double quote, Q is empty, double quote, close parenthesis, semicolon. Return, semicolon. Close curly brace. Else. While, open parenthesis, exclamation mark, open parenthesis, stack empty, open parenthesis, S1, close parenthesis, close parenthesis, close parenthesis. Open curly brace. X equals pop, open parenthesis, S1, close parenthesis, semicolon. Push, open parenthesis, S2, comma, X, close parenthesis, semicolon. Close curly brace. Close curly brace. X equals pop, open parenthesis, S2, close parenthesis, semicolon. Close curly brace. Question. Let n insert operations and m, open parenthesis, greater than or equal to n, close parenthesis, delete operations be performed in an arbitrary order on an empty QQ. Let x and y be the number of push and pop operations respectively performed on the stacks during the process. Which one of the following is true for all n and m? Option A, n plus m less than or equal to x less than or equal to 2n, and 2m less than or equal to y less than or equal to n plus m. Option B, n plus m less than or equal to x less than 2n, and 2m equals y equals 2n. Option C, 2m less than x less than 2n, and 2m equals y equals n plus m. Option D, 2m less than x less than 2n, and 2m equals y less than 2n. Question 3, year 2007. The following postfix expression, with single-digit operands, is evaluated using a stack. 823/2 asterisk plus 51 asterisk minus. Note that caret represents the exponentiation operator. The top two elements of the stack, after the first asterisk, is evaluated are Option A 6 and 1, Option B 5 and 7, Option C 3 and 2, Option D 1 and 5. Question 4, year 2008. The following C function takes a singly linked list of integers as a parameter and rearranges the elements of the list. The function is called with the list containing the integers 1, 2, 3, 4, 5, 6, and 7, in that order. What will be the contents of the list after the function completes execution? Structure. Struct node. Open curly brace. Int value, semicolon. Struct node asterisk next, semicolon. Close curly brace. Function. Void rearrange, open parenthesis, struct node asterisk list, close parenthesis. Open curly brace. Struct node asterisk p, comma asterisk q, semicolon. Int temp, semicolon. If open parenthesis, exclamation mark list, vertical bar, exclamation mark list, arrow next, close parenthesis, return, semicolon. P equals list, semicolon. Q equals list, arrow next, semicolon. While, open parenthesis, Q, close parenthesis. Open curly brace. Temp equals P, arrow value, semicolon. P arrow, value equals Q arrow value, semicolon. Q arrow, value equals temp, semicolon. P equals Q, arrow next, semicolon. Q equals P question mark P, arrow next, colon 0, semicolon. Close curly brace. Close curly brace. Option A 1, 2, 3, 4, 5, 6, 7. Option B 2, 1, 4, 3, 6, 5, 7. Option C 1, 3, 2, 5, 4, 7, 6. Option D 2, 3, 4, 5, 6, 7, 1. Question 5, year 2012. Suppose a circular queue of capacity, open parenthesis n-1, close parenthesis, elements is implemented with an array of n elements. Assume that the insertion and deletion operations are carried out using rear and front as array index variables respectively. Initially, rear equals front equals 0. The conditions to detect Q full and Q empty are Option A. Full, open parenthesis rear plus 1 close parenthesis mod n equals front. Empty, rear equals front. Option B. Full, open parenthesis rear plus 1 close parenthesis mod n equals front. Empty, open parenthesis front plus 1 close parenthesis mod n equals rear. Option C. Full, rear equals front. Empty, open parenthesis rear plus 1 close parenthesis mod n equals front. Option D. Full, open parenthesis front plus 1 close parenthesis mod n equals rear. Empty, rear equals front. Question 6, year 2015. Consider the C program below. Code. Include stdio.h. Int asterisk a, comma SDK top, semicolon. Int SDK func, open parenthesis, int opcode, comma, int val, close parenthesis. Open curly brace. Static int size equals 0, comma, SDK top equals 0, semicolon. Switch, open parenthesis, opcode, close parenthesis. Open curly brace. Case -1, colon. Size equals val, semicolon. Break, semicolon. Case 0, colon. If, open parenthesis, SDK top less than size, close parenthesis. A open square bracket, SDK top plus plus, close square bracket, equals val, semicolon. Break, semicolon. Default colon. If, open parenthesis, SDK top, close parenthesis, return a, open square bracket, minus SDK top, close square bracket, semicolon. Close curly brace. Return -1, semicolon. Close curly brace. Int main, open parenthesis, close parenthesis. Open curly brace. Int b, open square bracket 20 close square bracket, semicolon. A equals b, semicolon. SDK top equals -1, semicolon. SDK func, open parenthesis, -1, 10, close parenthesis, semicolon. SDK func, open parenthesis, 0, 5, close parenthesis, semicolon. SDK func, open parenthesis, 0, 10, close parenthesis, semicolon. Printf, open parenthesis, %d, \n, comma, SDK func, open parenthesis, 1, 0, close parenthesis, plus, SDK func, open parenthesis, 1, 0, close parenthesis, semicolon. Close curly brace. Question. The value printed by the above program is blank. Question 7, year 2015. The result of evaluating the following postfix expression is 10, 5 plus 606 slash asterisk 8 minus. Option A 284. Option B 213. Option C 142. Option D 71. Question 8, year 2016. Let Q denote a queue containing 16 numbers, and let S be an empty stack. Head of Q returns the element at the head of the queue Q without removing it from Q. Similarly, top of S returns the element at the top of stack S without removing it from S. Algorithm. While Q is not empty, do. If S is empty, or top of S is less than or equal to head of Q, then equals DQ, open parenthesis, Q, close parenthesis, semicolon. Push, open parenthesis, S, X, close parenthesis, semicolon. Else equals pop, open parenthesis, S, close parenthesis, semicolon. In Q, open parenthesis, Q, X, close parenthesis, semicolon. End if. End while. Question. The maximum possible number of iterations of the while loop in the algorithm is blank. Question 9, year 2016. The attributes of 3 arithmetic operators in some programming language are given below. Operator table. Operator plus. Precedence, high. Associativity, left. Arity, binary. Operator minus. Precedence, medium. Associativity, right. Arity, binary. Operator asterisk. Precedence, low. Associativity, left. Arity, binary. Question. The value of the expression 2 minus 5 plus 1 minus 7 asterisk 3 in this language is blank. Question 10, year 2017. A circular queue has been implemented using a singly linked list, where each node consists of a value and a single pointer pointing to the next node. We maintain exactly 2 external pointers, front and rear, pointing to the front node and the rear node of the queue, respectively. Which of the following statements is or are correct for such a circular queue, so that insertion and deletion operations can be performed in order one time? Statement 1. The next pointer of the front node points to the rear node. Statement 2. The next pointer of the rear node points to the front node. Option A, statement 1 only. Option B, statement 2 only. Option C. Both statement 1 and statement 2. Option D, neither statement 1 nor statement 2. Chapter 5, Trees. Tree. A tree is a non-linear data structure designated at a special node called the root, and elements are arranged in levels without containing cycles. Or, a tree has the following properties. It is rooted at one vertex. It contains no cycles. There is a sequence of edges from any vertex to any other. Any number of elements may connect to any node, including the root. There is a unique path from the root to every node. A tree stores data in a hierarchical manner. The elements are arranged in layers. Example: the diagram represents a tree with root node A. Node A is connected to 3 child nodes, B, C, and D. Node B has 1 child, E. Node C has 1 child, F. Node D has no children. Nodes E and F are leaf nodes. Observations: root node is A. Children of A are B, C, and D. E, F, and D are leaf nodes. B and C are intermediate nodes. O is the parent of B, C, and D. B is the parent of E. C is the parent of F. The number of children of a node is called the degree of the node. Two-tree. A two-tree is a tree in which every node contains either 0 or 2 children. Binary tree. A binary tree is a special type of tree in which every node contains either 0, 1, or 2 children. Or, a binary tree is either empty, or it consists of a root with 2 binary trees called the left subtree and right subtree of the root. The left subtree, the right subtree, or both may be empty. Properties of binary tree. A binary tree is partitioned into 3 parts. The first part contains the root of the tree. The second part is called the left subtree. The third part is called the right subtree. Each subtree is itself a binary tree. The degree of any node can be 0, 1, or 2. The maximum number of nodes in a binary tree of height h is 2 raised to the power h plus 1, minus 1. The maximum number of nodes at level I is 2 raised to the power I minus 1. For any non-empty binary tree, if n2 is the number of nodes having degree 2, then the number of terminal or leaf nodes is n2 plus 1. The maximum number of nodes in a tree of depth d is 2 raised to the power d, minus 1. Types of binary tree. Complete binary tree. A complete binary tree is a binary tree in which every level, except possibly the last level, is completely filled, and all nodes in the last level are as far left as possible. Example: the table shows the relationship between level, height, and depth. Level 1, height 3, depth 1. Level 2, height 2, depth 2. Level 3, height 1, depth 3. Level 4, height 0, depth 4. Diagram explanation. The diagram shows a complete binary tree. Root node is A. A has 2 children, B and C. B has children D and E. C has children F and G. D has children H and I. E has 1 child J. The last level is filled from the left side without gaps, making it a complete binary tree. For the given tree, the tree has 4 levels. The height of the tree is 3. The depth of the tree is 4. The numbers beside each node represent the level order index, abbreviated as LOI. The level order index is assigned according to the level order traversal. The root node has level order index equal to 1. For a node X, if is the left child of its parent, level order index of X equals 2 multiplied by the level order index of the parent. If is the right child of its parent, level order index of X equals 2 multiplied by the level order index of the parent, plus 1. A complete binary tree can therefore be represented as a binary tree whose nodes have continuous level order index values without any gaps. Full binary tree. A full binary tree is a binary tree in which all leaf nodes are at the same level. Every intermediate node has exactly 2 children. Or, a tree with depth k contains exactly 2 raised to the power k, minus 1 nodes. Strictly binary tree. A strictly binary tree is a binary tree in which every node has either 0 or 2 children. Skewed binary tree. A skewed binary tree is a binary tree in which nodes are inserted in only one direction. Diagram explanation. Left skewed tree. Root node is A. A has child B. B has child C. C has child D. Every node extends only towards the left. Right skewed tree. Root node is A. A has child B. B has child C. C has child D. Every node extends only towards the right. Application of binary tree. A binary tree is a useful data structure whenever two-way decisions are made at each stage of a process. Binary tree representation. A binary tree can be represented in two ways. Using an array. Using a linked list. Array representation. The elements of a binary tree are stored in an array using the level order index of each element. Diagram explanation. If the level order index of the root is 0, left child index equals 2 multiplied by I plus 1. Right child index equals 2 multiplied by I plus 2, where I is the index of the parent node. Example 1. Diagram explanation. The binary tree contains root A at index 0, B at index 1, C at index 2, D at index 3, E at index 4, F at index 5, G at index 6, H at index 7, I at index 8. The array representation shown below the tree stores a B, C, D, E, F, G, H, I at indices 0, 1, 2, 3, 4, 5, 6, 7, and 8 respectively. Example 2. Diagram explanation. The binary tree is sparse. Root A is at index 0. B is at index 1. C is at index 2. D is at index 5. E is at index 12. The remaining array locations are empty because there are no corresponding nodes. Linked list representation. In the linked list representation, every node contains one data field. Every node contains two link fields. The left link points to the left child. The right link points to the right child. If a child does not exist, the corresponding link contains NULL. Diagram explanation. The example shows root node A has left child B and right child C. The node corresponding to it contains a data field storing a left pointer pointing to node B, a right pointer pointing to node C. Nodes without children have their left and right pointers set to NULL. Trade-offs between array and linked list representations. Array representation is simpler. It ensures that elements are stored at their proper positions in the array. Linked list representation stores pointers to the left child and the right child. Array representation saves memory for almost complete binary trees. Linked list representation allocates memory only for the nodes that actually exist in the tree. Array representation is not efficient for skewed binary trees. Array representation limits the size of the binary tree to the array size. In linked list representation, the tree can grow dynamically by adding new elements and shrink dynamically by deleting elements. Binary search tree. A binary search tree, or BST, is a special type of binary tree that satisfies the following properties. Every element in the left subtree of the root is smaller than the root. Every element in the right subtree of the root is greater than the root. These two properties are satisfied recursively for every subtree. Example. Diagram explanation. The binary search tree shown contains root node 6. Left child of 6 is 3. Right child of 6 is 9. 3 has children 1 and 4. 9 has children 8 and 11. This satisfies the binary search tree property because every left child is smaller than its parent, and every right child is greater than its parent. The binary search tree node contains 3 fields. Left child pointer. Data field. Right child pointer. The left child pointer stores the address of the predecessor node. The right child pointer stores the address of the successor node. Structure declaration. Struct node. Open curly brace. Struct node asterisk left underscore child, semicolon. Int data, semicolon. Struct node asterisk right underscore child, semicolon. Close curly brace. Insertion. If the value to be inserted is smaller than the root, move to the left subtree. If the value is larger than the root, move to the right subtree. Repeat this process recursively until you reach a node where the required subtree does not exist. Insert the new value at that position. Insertion example. Diagram explanation. The diagram shows a binary search tree. Root node is 6. Left child is 3. Right child is 9. 3 has children 1 and 4. 9 has children 8 and 11. Node 1 has no right child, but has a left child 2 to be inserted. Since 2 is greater than 1 and less than 3, it becomes the right child of 1. Deletion. There are 3 cases for deletion in a binary search tree. Case 1, node has no children. Delete the leaf node. The remaining tree, still a valid binary search tree. Case 2, node has 1 subtree. Example. The tree shown has node 3 with only 1 subtree. Diagram explanation. Root node is 6. Left child is 3. Right child is 9. 3 has only 1 child, 1. 1 has children 0 and 2. 9 has children 8 and 11. To delete node 3, connect its parent directly to its only child. After deletion, the new tree becomes root node 6. Left child 1. 1 has children 0 and 2. Right child remains 9. 9 still has children 8 and 11. This operation is called linking past the deleted node. Case 3, node has 2 subtrees. Example. Delete node 6. Diagram explanation. The root node 6 is removed temporarily. The empty position is marked with X. To replace X, choose a value that satisfies the binary search tree property. The replacement value must satisfy both conditions. Every value in the left subtree must be smaller than X. Every value in the right subtree must be greater than X. A suitable replacement is chosen from either the largest value in the left subtree, called the in-order predecessor, or the smallest value in the right subtree, called the in-order successor. The replacement node becomes the new root, and the binary search tree property is preserved. When deleting a node that has 2 subtrees, we must choose a replacement node X. We choose X to be the largest value in the left subtree. In the example shown, 3 is the largest value in the left subtree. Therefore, node 6 is replaced by node 3. Diagram explanation. The new binary search tree is root node is 3. Left child of 3 is 1. Right child of 3 is 9. 1 has children 0 and 2. 9 has children 8 and 11. The binary search tree property is still maintained. Note: we can also replace the deleted node using the smallest value in the right subtree. Both methods produce a valid binary search tree. Important notes: the largest element in the left subtree is the rightmost element. The smallest element in the right subtree is the leftmost element. Binary tree traversing methods. A binary tree contains 3 parts. V represents the root. L represents the left subtree. R represents the right subtree. Preorder traversal. Order, VLR. Steps. Visit the root node. Traverse the left subtree in preorder. Traverse the right subtree in preorder. In-order traversal. Order, LVR. Steps. Traverse the left subtree in order. Visit the root node. Traverse the right subtree in order. Post-order traversal. Order, LRV. Steps. Traverse the left subtree in post-order. Traverse the right subtree in post-order. Visit the root node. Example 1. Diagram explanation. The tree consists of root node A, left child B and right child C. B has children D and E. D has left child F. C has children G and H. G has left child I. H has right child J. Traversals. Preorder traversal. A B D, F E C G I H J. In order traversal. F D B, E A I G C H J. Post-order traversal. F D, E B I G J H C A. These three traversals uniquely identify the tree. Example 2. Diagram explanation. The binary search tree contains root node 6, left child 3, right child 9. 3 has children 1 and 4. 1 has right child 2. 9 has children 8 and 11. Traversals. Preorder traversal. 6 3 1 2 4 9 8 11. In order traversal. 1 2 3 4 6 8 9 11. Post-order traversal. 2 1 4 3 8 11 9 6. Points to remember. In pre-order traversal, the root is visited first. In post-order traversal, the root is visited last. For a binary search tree, in-order traversal always produces the elements in sorted order. A unique binary tree can be reconstructed if in-order traversal is given along with either pre-order traversal or post-order traversal. If only pre-order traversal or only post-order traversal is given, the binary search tree cannot be reconstructed uniquely. Applications of binary trees. 1. Expression trees. Binary trees can be used to represent arithmetic expressions. In an infix expression, every operator becomes a parent node, and its operands become the child nodes. Example. Consider the expression open parenthesis 3 plus open parenthesis 7 multiplied by 2 close parenthesis minus 1. Diagram explanation. The root node is the minus operator. Its left child is the plus operator. Its right child is the operand 1. The plus operator has left operand 3. Its right child is the multiply operator. The multiply operator has operands 7 and 2. Every operand is a leaf node, and every operator is an internal node. 2. Evaluating an expression tree. To evaluate an expression tree, take any two leaf nodes. Apply their parent operator. Replace the operator with the computed value of the subexpression. Repeat until only one value remains. Diagram explanation. The first subtree evaluates 2 plus 4, giving 6. The next subtree evaluates 6 multiplied by 3, giving 18. The final value of the expression is 18. 3. Huffman coding tree. Binary trees are used in the famous file compression algorithm called the Huffman coding tree. Diagram explanation. Each character is stored in a leaf node. A code is generated by moving from the root to the required leaf. Moving to the left child represents 0. Moving to the right child represents 1. In the example, character F has code 00. Character has code 01. Character E has code 1. A VL tree. And a VL tree is a self-balancing binary search tree. In an AVL tree, the heights of the left and right subtrees of every node differ by at most 1. During insertion or deletion, the tree may need 1 or more rotations to restore balance. Balance factor. The balance factor of a node is height of the left subtree minus height of the right subtree. Some books define it in the opposite order. A node is balanced when its balance factor is -1, 0, or +1. Any other value indicates that the tree is unbalanced and requires rebalancing. The balance factor may either be stored directly in each node or computed from the heights of the left and right subtrees. Insertion operation in an AVL tree. Step 1. Insert the new node exactly as in a binary search tree. Step 2. Examine every node along the insertion path to determine whether a pivot node exists. Cases that may occur. Case 1. There is no pivot node. No adjustment is required. Case 2. A pivot node exists, but the subtree where the new node is inserted has a smaller height. No adjustment is required. Case 3. A pivot node exists, and the subtree where the new node is inserted has greater height. The tree must be adjusted by performing rotations. Example 1. Diagram explanation. The tree contains root node 20, left child 10, right child 30. The balance factor of every node is 0, so the tree is balanced. Example 2. Diagram explanation. A new node 25 is inserted. Root node 20 has balance factor -1. Node 30 has balance factor +1. Node 25 becomes the left child of 30. The tree is still in a VL tree because every balance factor is between -1 and +1. Example 3. Diagram explanation. Another node, 5, is inserted. Now the tree becomes root node 20 with balance factor +2. Left subtree contains 10. 10 is left child 5. Right subtree contains 25. Root also has right child 40, which has right child 45. The root node now has balance factor +2. Therefore, this is no longer in a VL tree. Rotations in an AVL tree. And a VL tree becomes height balanced using 4 rotation cases. 1. Left-left case. This occurs when insertion happens in the left subtree of the left child of the pivot node. Diagram explanation. Initially, root node A, left child G, right child B. G has left child P. A new node X is inserted as the left child of P. Here, G becomes the pivot node. Solution. Perform a left-left rotation. Diagram explanation after rotation. P becomes the root of the subtree. X remains the left child of P. G becomes the right child of P. A remains the parent of the rotated subtree. B remains the right child of A. Important points. After a left-left rotation, the intermediate node P becomes the root of the subtree. The old root, G, becomes the right child of P. The newly inserted node X remains the left child of P. 2. Left-right case. The left-right case occurs when insertion happens in the right subtree of the left child of the pivot node. Example 1. Insert node X as the right child of P. Diagram explanation. Initially, root node A, left child G, right child B. G has left child P. P has right child X. The balance factor of node A becomes +2. The tree is not in a VL tree because node G becomes height unbalanced. Solution. Perform a left-right rotation. Diagram explanation after rotation. X becomes the new root of the subtree. P becomes the left child of X. G becomes the right child of X. A remains balanced with left child X and right child B. Important points. After a left-right rotation, the new node X becomes the root of the subtree. The old pivot node G becomes the right child of X. The intermediate node P becomes the left child of X. Right-right case. This case occurs when insertion happens in the right subtree of the right child of the pivot node. Example. Insert node X as the right child of P. Diagram explanation. Initially, root node A, left child B, right child G. G has right child P. P has right child X. The balance factor of node A becomes -2. The tree is not in a VL tree because node G becomes height unbalanced. Solution. Perform a right-right rotation. Diagram explanation after rotation. P becomes the root of the subtree. G becomes the left child of P. X remains the right child of P. A becomes balanced with left child B and right child P. Important points. After a right-right rotation, the intermediate node P becomes the root of the subtree. The old pivot node G becomes the left child of P. The inserted node X remains the right child of P. Right-left case. This case occurs when insertion happens in the left subtree of the right child of the pivot node. Example. Insert node X as the left child of P. Diagram explanation. Initially, root node A, left child B, right child G. G has right child P. P has left child X. The balance factor of node A becomes -2. The tree is not in a VL tree because node G becomes height unbalanced. Solution. Perform a right-left rotation. Diagram explanation after rotation. X becomes the new root of the subtree. G becomes the left child of X. P becomes the right child of X. A remains balanced with left child B and right child X. Important points. After a right-left rotation, the new node X becomes the root of the subtree. The old pivot node G becomes the left child of X. The intermediate node P becomes the right child of X. Note: left-right rotation and right-left rotation are called double rotations because each consists of two single rotations performed one after another. Binary heap. A binary heap is a heap data structure created using a binary tree. It can be seen as a binary tree with two additional constraints. Shape property. The tree is a complete binary tree. That is, all levels of the tree, except possibly the last one, are completely filled. If the last, or deepest, level of the tree is not complete, then the nodes of that level are filled from left to right. Max heap. A heap in which each node is greater than or equal to its children is called a max heap. A max heap is generally used for heap sort. Min heap. A heap in which each node is smaller than or equal to its children is called a min heap. A min heap is generally used to implement a priority queue. Note: by default, the term heap represents a max heap. Diagram explanation. The initial max heap shown contains root node 11, left child 5, right child 8. Node 5 has left child 3 and right child 4. This satisfies the max heap property because every parent node is greater than its children. Insert 15. Diagram explanation. Insert node 15 at the next available position. Node 15 becomes the left child of 8. The tree is still a complete binary tree. However, it does not satisfy the heap property because 15 is greater than its parent 8. Therefore, perform the heapify operation. Heapify. First interchange 8 and 15. Now 15 becomes the right child of 11. Again, compare 15 with its parent 11. Since 15 is greater than 11, interchange them. Diagram explanation after heapify. The final heap becomes root node 15, left child 5, right child 11. Node 5 has children 3 and 4. Node 11 has left child 8. The heap property is restored. Delete 5. Deletion of a node from a heap always deletes a leaf node. Therefore, first interchange the value of the last leaf node with node 5. Diagram explanation. Interchange 5 and 8. Now, root node is 15. Left child is 8. Right child is 11. Node 8 has children 3 and 4. Node 11 has left child 5. Now delete node 5. Diagram explanation. After deleting node 5, the heap contains root node 15, left child 8, right child 11. Node 8 has children 3 and 4. The heap satisfies the heap property. Delete 15. Interchange 4 and 15. Diagram explanation. Node 4 becomes the root. Node 15 moves to the last leaf position. Now delete node 15. Diagram explanation. The heap now contains root node 4, left child 8, right child 11. Node 8 has left child 3. This does not satisfy the heap property. Therefore, perform the heapify operation. Heapify. Compare node 4 with its children. The larger child is 11. Interchange 4 and 11. Diagram explanation after heapify. The final heap becomes root node 11, left child 8, right child 4. Node 8 has left child 3. The heap property is restored. Note: insertion or deletion operation on a heap may require the heapify process. Expression tree. The expressions can also be represented by using a binary tree called an expression tree. An expression tree contains operators are intermediate nodes. Operands are leaf nodes, or children of operator nodes. The operator at the lowest level will have the highest priority. Example: expression a plus b multiplied by c. Diagram explanation. The root node contains the plus operator. The left child is operand a. The right child is the multiply operator. The multiply operator has left child b and right child c. This correctly represents the expression a plus b multiplied by c. Traversing. Preorder. Plus a multiply b c. In order. A plus b multiplied by c. Postorder. A bc multiply plus. Note: in order traversal of an expression tree generates the infix expression. Similarly, preorder traversal generates the prefix expression. Postorder traversal generates the postfix expression, respectively. Exercises. Practice problems 1. Directions for questions 1 to 15. Select the correct alternative from the given choices. Question 1. A binary tree T has n leaf nodes. The number of nodes of degree 2 in T is option A n, option B n minus 1, option C log n, option D n plus 1. Question 2. How many numbers of binary tree can be created with 3 nodes which, when traversed in post order, gives the sequence C, B, A? Option A 3, option B 5, option C 8, option D 15. Question 3. A binary search tree contains the values 3, 6, 10, 22, 25, 30, 60, 75. The tree is traversed in preorder, and the values are printed. Which of the following sequence is a valid output? Option A. 25, 6, 3, 10, 22, 60, 30, 75. Option B. 25, 6, 10, 3, 22, 75, 30, 60. Option C. 25, 6, 75, 60, 30, 3, 10, 22. Option D. 75, 30, 60, 22, 10, 3, 6, 25. Question 4. Figure shows a balanced tree. How many nodes will become unbalanced when a node is inserted as the child of node G? Diagram explanation. The tree consists of root node A, left child B and right child E. B has children C and D. C has left child G. E has left child F. You need to determine how many nodes become unbalanced after inserting a child under node G. Option A 7. Option B 2. Option C 3. Option D 8. Question 5. A full binary tree with n non-leaf nodes contains option A 2n nodes, option B log base 2n nodes, option C n plus 1 nodes, option D 2n plus 1 nodes, Question 6. Which of the following list of nodes corresponds to a post-order traversal of the binary tree shown below? Diagram explanation. The tree contains root node A, left child B and right child C. B has children D and E. E has left child H. C has children F and G. F is left child I. G has right child J. Choose the correct post-order traversal. Option A. A B C D E F G H I J. Option B. J I H G F E D C B A. Option C. D H E B I F J G C A. Option D. D E H F I G J B C A. Question 7. Which of the following sequence of array elements forms a heap? Option A. Open brace. 23, 17, 14, 6, 13, 10, 1, 12, 7, 5. Close brace. Option B. Open brace. 23, 17, 14, 6, 13, 10, 1, 5, 7, 12. Close brace. Option C. Open brace. 23, 17, 14, 7, 13, 10, 1, 5, 6, 12. Close brace. Option D. Open brace. 23, 17, 14, 7, 13, 10, 1, 12, 5, 6. Close brace. Question 8. What is the maximum height of any of VL tree with 7 nodes? Assume that the height of a tree with a single node is 0. Option A 2. Option B 3. Option C 4. Option D 5. Question 9. A binary search tree is generated by inserting, in order, the following integers: 55, 15, 65, 5, 25, 59, 92, 7, 35, 60, 23. The number of nodes in the left subtree and right subtree of the root, respectively, are: Option A 8, 3. Option B 7, 4. Option C 3, 8. Option D 4, 7. Question 10. In a complete binary tree of n nodes, how far are the most distant 2 nodes? Assume each path in the tree counts as 1. Option A. About log base 2n. Option B. About 2 log base 2n. Option C. About 3 log base 2n. Option D. About 4 log base 2 of n. Question 11. A complete binary tree of level 5 has how many nodes? Option A 20. Option B 63. Option C 30. Option D 73. Common data for questions 12 and 13. A 3-array max heap is like a binary max heap, but instead of 2 children, nodes may have 3 children. A 3-array heap can be represented by an array as follows. The root is stored in the first location, a open square bracket 0 close square bracket. Nodes in the next level from left to right are stored from a open square bracket 1 close square bracket to a open square bracket 3 close square bracket, and so on. An item can be inserted into a 3-array heap containing n items by placing in location a open square bracket n close square bracket and pushing it up the tree to satisfy the heap property. Question 12. Which one of the following is a valid sequence of elements in an array representing a 3-array max heap? Option A. 1, 3, 5, 6, 8, 9. Option B. 9, 6, 3, 1, 8, 5. Option C. 9, 3, 6, 8, 5, 1. Option D. 9, 5, 6, 8, 3, 1. Question 13. Suppose the elements 7, 2, 10, and 4 are inserted, in that order, into the valid 3-array max heap found in the above question. Which one of the following is the sequence of items in the array representing the resultant heap? Option A. 10, 7, 9, 8, 3, 1, 5, 2, 6, 4. Option B. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Option C. 10, 9, 4, 5, 7, 6, 8, 2, 1, 3. Option D. 10, 8, 6, 9, 7, 2, 3, 4, 1, 5. Question 14. Consider the nested representation of binary trees. Open parenthesis. X, Y, Z. Close parenthesis. Here, Y and Z are the left and right subtrees respectively of node X. Y and Z may be null, or may themselves be further nested. Which of the following represents a valid binary tree? Option A. Open parenthesis. 1, 2. Open parenthesis. 4, 5, 6, 7. Close parenthesis. Close parenthesis. Option B. Open parenthesis. Open parenthesis. 1, 2, 3, 4. Close parenthesis. 5. Close parenthesis. 6, 7. Option C. Open parenthesis. Open parenthesis. 1, 2, 3, 4. Close parenthesis. Open parenthesis. 5, 6, 7. Close parenthesis. Close parenthesis. Option D. Open parenthesis. Open parenthesis. 1, 2, 3. Null. Close parenthesis. Open parenthesis. 4, 5. Close parenthesis. Close parenthesis. Question 15. A scheme for storing binary trees in an array X is as follows. Indexing of X starts from 1 instead of 0. The root is stored in X open square bracket 1 close square bracket. For a node stored at X open square bracket, I close square bracket. The left child, if any, is stored in X open square bracket 2 I close square bracket. The right child, if any, is stored in X open square bracket 2 I plus 1 close square bracket. To store any binary tree on n vertices, the minimum size of array X should be Option A 2n, Option B n, Option C 3n, Option D n squared. Practice problems 2. Directions for questions 1 to 15. Select the correct alternative from the given choices. Question 1. A binary search tree contains the values 1, 2, 3, 4, 5, 6, 7, 8. The tree is traversed in preorder, and the values are printed. Which of the following is a valid output? Option A 5, 3, 1, 2, 4, 7, 8, 6. Option B 5, 3, 1, 2, 6, 4, 8, 7. Option C 5, 3, 2, 4, 1, 6, 7, 8. Option D 5, 3, 1, 2, 4, 7, 6, 8. Question 2. A binary search tree is generated by inserting, in order, the following integers: 50, 15, 62, 5, 20, 58, 91, 3, 8, 37, 60, 24. The number of nodes in the left subtree and right subtree of the root, respectively, are Option A 4, 7. Option B 7, 4. Option C 8, 3. Option D 3, 8. Question 3. A full binary tree with root at level 0 of height h has a total number of nodes equal to Option A 2 to the power h. Option B 2 to the power h plus 1, minus 1. Option C 2 to the power h, minus 1. Option D 2 to the power h minus 1, minus 1. Question 4. The number of null pointers of a binary tree of n nodes is Option A n plus 1. Option B n multiplied by open parenthesis n plus 1 close parenthesis. Option C, n squared. Option D, 2n. Question 5. Which of the following is false? Option A. A tree with n nodes has n-1 edges. Option B. A labeled rooted binary tree can be uniquely constructed, given its postorder and in-order traversal results. Option C. The complete binary tree with n internal nodes has n plus 1 leaves. Option D. The maximum number of nodes in a binary tree of height h is 2 to the power h plus 1, minus 1. Question 6. The maximum number of nodes in a binary tree at level I is Option A, 2 to the power I. Option B, 2 to the power I, minus 1. Option C, 2 to the power I plus 1, minus 1. Option D, log base 2 of I plus 1. Question 7. The number of leaf nodes in a rooted tree of n nodes, with each node having 0 or 3 children is Option A, n divided by 3. Option B, open parenthesis n minus 1 close parenthesis divided by 3. Option C, open parenthesis n minus 1 close parenthesis divided by 2. Option D, open parenthesis 2n plus 1 close parenthesis divided by 3. Question 8. A complete NRE tree is one in which every node has either 0 or n children. If is the number of internal nodes of a complete NRE tree, the number of leaves in it is given by Option A, multiplied by open parenthesis n minus 1 close parenthesis plus 1. Option B, xn plus 1. Option C, xn minus 1. Option D, multiplied by open parenthesis n plus 1 close parenthesis minus 1. Common data for questions 9 and 10. Insert the keys into a binary search tree in the order specified. 15, 32, 20, 9, 3, 25, 12, 1. Which one of the following is the binary search tree after insertion of all elements? Question 9. Option A, diagram explanation. Root node is 15. Left child is 9. Right child is 32. 9 has children 3 and 12. 3 has left child 1. 32 has left child 20. 20 has right child 25. Option B, diagram explanation. Root node is 15. Left child is 12. Right child is 32. 12 has left child 9. 9 has left child 3. 3 has left child 1. 32 has left child 20. 20 has right child 25. Option C, diagram explanation. Root node is 15. Left child is 3. Right child is 20. 3 has right child 12. 12 has left child 3. 3 has left child 1. 20 has right child 25. 25 has right child 32. Option D, diagram explanation. Root node is 15. Left child is 1. Right child is 25. 1 has right child 9. 9 has right child 12. 12 has left child 3. 25 has right child 32. 32 has left child 20. 32 has right child 32. Question 10. Which of the following is the binary search tree after deleting 15? Option A, diagram explanation. Root node is 9. Left child is 3. Right child is 32. Node 3 has children 1 and 12. Node 32 has left child 20. Node 20 has right child 25. Option B, diagram explanation. Root node is 20. Left child is 9. Right child is 32. Node 9 has children 3 and 12. Node 3 has left child 1. Node 32 has left child 25. Option C, diagram explanation. Root node is 20. Left child is 9. Right child is 25. Node 9 has children 3 and 12. Node 3 has left child 25. Node 25 has right child 32. Option D, diagram explanation. Root node is 20. Left child is 9. Right child is 25. Node 9 has children 3 and 12. Node 3 has left child 1. Node 25 has right child 32. For questions 11, 12, and 13, use this figure. Diagram explanation. The binary tree consists of root node A, left child B, and right child C. Node B has left child D. Node D has left child G. Node C has left child E and right child F. Node E has left child H and right child I. Question 11. What is the post-order expression? Option A, a BDGCJHIF. Option B, GDBHIEFCA. Option C, DGBAHEICF. Option D, a BHIEFCDG. Question 12. What is the pre-order expression? Option A, a BDGCEHIF. Option B, a BHIEFCDG. Option C, DGBAHEIFC. Option D, GDBHIEFCA. Question 13. What is the in-order expression? Option A, a BDGCEHIF. Option B, GDBHIEFCA. Option C, DGBAHEICF. Option D, a BHIEFCDG. Question 14. In a 3-RE tree, every internal node has exactly 3 children. The number of leaf nodes in such a tree with 6 internal nodes will be Option A 13, Option B 12, Option C 11, Option D 10. Question 15. Minimum number of swaps needed to convert the array. 89, 19, 14, 40, 17, 12, 10, 2, 5, 7, 11, 6, 9, 70. Into a max heap. Option A 2. Option B 3. Option C 1. Option D 0. Previous year's questions. Question 1, 2010. In a binary tree with n nodes, every node has an odd number of descendants. Every node is considered to be its own descendant. What is the number of nodes in the tree that have exactly 1 child? Option A 0. Option B 1. Option C open parenthesis, n-1, close parenthesis divided by 2. Option D n-1. Question 2, 2010. The following C function takes a singly linked list as an input argument. It modifies the list by moving the last element to the front of the list and returns the modified list. Some part of the code is left blank. Type def struct node. Open brace. Integer value semicolon. Struct node pointer next semicolon. Close brace. Node semicolon. Function move underscore to underscore front. Returns node pointer. Parameter node pointer head. Open brace. Declare node pointer p, comma node pointer q semicolon. If open parenthesis. Head equal null. Or head arrow next equal null. Close parenthesis. Return head semicolon. Assign. Q equals null semicolon. Assign. P equals head semicolon. While. Open parenthesis. P arrow next not equal null. Close parenthesis. Open brace. Assign. Q equals P semicolon. Assign. P equals P arrow next semicolon. Close brace. Blank statement. Return head semicolon. Close brace. Choose the correct alternative to replace the blank line. Option A. Q equals null semicolon. P arrow next equals head semicolon. Head equals P semicolon. Option B. Q arrow next equals null semicolon. Head equals P semicolon. P arrow next equals head semicolon. Option C. Head equals P semicolon. P arrow next equals Q semicolon. Q arrow next equals null semicolon. Option D. Q arrow next equals null semicolon. P arrow next equals head semicolon. Head equals P semicolon. Question 3. Consider two binary operators. Up arrow and down arrow. With the precedence of operator down arrow is lower than that of operator up arrow. Operator up arrow is right associative, while operator down arrow is left associative. Which one of the following represents the parse tree for the expression? Open parenthesis, 7 down arrow 3 up arrow 4 up arrow 3 down arrow 2, close parenthesis. Option A, diagram explanation. Root node is down arrow. Left child is 7. Right child is up arrow. That up arrow has left child 3. Its right child is another up arrow. That up arrow has left child 4. Its right child is down arrow. The down arrow has children 3 and 2. Option B, diagram explanation. Root node is down arrow. Left child is another down arrow. The left down arrow has children 7 and up arrow. The up arrow has left child 3. Its right child is another up arrow. That up arrow has children 4 and 3. The right child of the root is 2. Option C, diagram explanation. Root node is down arrow. Left child is 7. Right child is another down arrow. That down arrow has left child up arrow. The up arrow has left child 3. Its right child is another up arrow. That up arrow has children 4 and 3. The right child of the second down arrow is 2. Option D, diagram explanation. Root node is down arrow. Left child is up arrow. The up arrow has left child 3. Its right child is another up arrow. That up arrow has left child 4. Its right child is down arrow. The down arrow has children 7 and 3. The right child of the root is 2. Question 4, 2012. The height of a tree is defined as the number of edges on the longest path in the tree. The function shown in the pseudocode is invoked as height open parenthesis root close parenthesis to compute the height of a binary tree rooted at pointer root. Audiobook reading of the code. Function height. Parameter tree pointer n. If n equal null, return -1. If n arrow left equal null. If n arrow right equal null, return 0. Else return box B1. Else. Assign h1 equals height open parenthesis n arrow left close parenthesis. If n arrow right equal null, return 1 plus h1. Else. Assign h2 equals height open parenthesis n arrow right close parenthesis. Return box B2. The appropriate expressions for box B1 and box B2 are: Option A. Box B1. Open parenthesis. 1 plus height. Open parenthesis. N arrow right. Close parenthesis. Close parenthesis. Box B2. Open parenthesis. 1 plus max. Open parenthesis. H1. Comma. H2. Close parenthesis. Close parenthesis. Option B. Box B1. Height. Open parenthesis. N arrow right. Close parenthesis. Box B2. Open parenthesis. 1 plus max. Open parenthesis. H1. Comma. H2. Close parenthesis. Close parenthesis. Option C. Box B1. Height. Open parenthesis. N arrow right. Close parenthesis. Box B2. Max. Open parenthesis. H1. Comma. H2. Close parenthesis. Option D. Box B1. Open parenthesis. 1 plus height. Open parenthesis. N arrow right. Close parenthesis. Close parenthesis. Box B2. Max. Open parenthesis. H1. Comma. H2. Close parenthesis. Question 5, 2014. Consider the expression tree shown. Each leaf represents a numerical value, which can be either 0 or 1. Over all possible choices of the values at the leaves, the maximum possible value of the expression represented by the tree is. Diagram explanation. The root node is a plus operator. The left subtree starts with a minus operator. The right subtree starts with a plus operator. Each of these nodes further contains plus and minus operators. Every leaf node contains either 0 or 1. You must determine the maximum value obtainable by assigning zeros and ones to the leaf nodes. Question 6, 2014. Consider the pseudocode given below. The function doSomething takes as argument a pointer to the root of an arbitrary tree, represented by the leftmost child, right sibling representation. Each node of the tree is of type tree node. Audiobook reading of the code. Type def. Struct tree node pointer. Tree pointer semicolon. Struct tree node. Open brace. Tree pointer leftmost child semicolon. Tree pointer right sibling semicolon. Close brace, semicolon. Function doSomething. Parameter tree pointer tree. Open brace. Declare integer value equals 0 semicolon. If open parenthesis, tree not equal null, close parenthesis. Open brace. If open parenthesis, tree arrow leftmost child equal null, close parenthesis. Assign value equals 1 semicolon. Else. Assign. Value equals doSomething, open parenthesis, tree arrow leftmost child, close parenthesis semicolon. Assign. Value equals value plus doSomething, open parenthesis, tree arrow right sibling, close parenthesis semicolon. Close brace. Returned value semicolon. Close brace. When the pointer to the root of a tree is passed as the argument to doSomething, the value returned by the function corresponds to the Option A, number of internal nodes in the tree. Option B, height of the tree. Option C, number of nodes, without a right sibling in the tree. Option D, number of leaf nodes in the tree. Question 7, 2015. The height of a tree is the length of the longest root to leaf path in it. The maximum and minimum number of nodes in a binary tree of height 5 are Option A 63 and 6, respectively. Option B 64 and 5, respectively. Option C 32 and 6, respectively. Option D 31 and 5, respectively. Question 8, 2015. Which of the following is or are correct in order traversal sequence of binary search tree? Sequence 1. 3, 5, 7, 8, 15, 19, 25. Sequence 2. 5, 8, 9, 12, 10, 15, 25. Sequence 3. 2, 7, 10, 8, 14, 16, 20. Sequence 4. 4, 6, 7, 9, 18, 20, 25. Option A 1 and 4 only. Option B 2 and 3 only. Option C 1 and 4 only. Option D 2 only. Question 9, 2015. Consider a max heap represented by the array 40, 30, 20, 10, 15, 16, 17, 8, 4. Now consider that a value 35 is inserted into the heap. After insertion, the new heap is Option A. 40, 30, 20, 10, 15, 16, 17, 8, 4, 35. Option B. 40, 35, 20, 10, 30, 16, 17, 8, 4, 15. Option C. 40, 30, 20, 10, 35, 16, 17, 8, 4, 15. Option D. 40, 35, 20, 10, 15, 16, 17, 8, 4, 30. Question 10, 2015. A binary tree T has 20 leaves. The number of nodes in T having 2 children is. Question 11, 2015. Consider a binary tree T that has 200 leaf nodes. Then, the number of nodes in T having exactly 2 children are. Question 12, 2015. While inserting the elements 71, 65, 84, 69, 67, 83. In an empty binary search tree, or BSD, in the sequence shown, the lowest level in the BSD has the element. Option A 65, Option B 67, Option C 69, Option D 83. Question 13, 2016. Consider the following new order strategy for traversing a binary tree. Visit the root. Visit the right subtree using new order. Visit the left subtree using new order. The new order traversal of the expression tree corresponding to the expression 3 multiplied by 5 minus 2 raised to 6 divided by 7 plus 1 minus 1 is given by Option A. Plus, minus, 1, 6, 7, 2, minus, 5, 3. Option B. Plus, 1, 6, 7, 2, minus, 5, 3, 4. Option C. Minus, plus, 1, 7, 6, 2, minus, 5, 4, 3. Option D. 1, 7, 6, plus, 2, 5, 4, 3, minus. Question 14, 2017. Let T be a binary tree with 15 nodes. The minimum and maximum possible heights of T are. Note, the height of a tree with a single node is 0. Option A 4 and 15, respectively. Option B 3 and 14, respectively. Option C 4 and 14, respectively. Option D 3 and 15, respectively. Question 15, 2017. The pre-order traversal of a binary search tree is given by 12, 8, 6, 2, 7, 9, 10, 16, 15, 19, 20. The post-order traversal of this tree is Option A. 2, 6, 7, 8, 9, 10, 12, 15, 16, 17, 19, 20. Option B. 2, 7, 6, 10, 9, 8, 15, 17, 20, 19, 16, 12. Option C. 7, 2, 6, 8, 9, 10, 20, 17, 19, 15, 16, 12. Option D. 7, 6, 2, 10, 9, 8, 15, 16, 17, 20, 19, 12. Question 16, 2018. The post-order traversal of a binary tree is 8, 9, 6, 7, 4, 5, 2, 3, 1. The in-order traversal of the same tree is 8, 6, 9, 4, 7, 2, 5, 1, 3. The height of a tree is the length of the longest path from the root to any leaf. The height of the binary tree above is. Question 17, 2018. The number of possible minimum spanning trees containing each value from Open brace. 1, 2, 3, 4, 5, 6, 7. Close brace. Exactly once is.